87.
87. But probably he was not doing well for last few days, or
Ravi may be knowing all those details.
or it was sudden. Was it sudden, or he was not keeping well?
Ravi, you can tell, please.
It was, I think, since. Can you hear me?
Yes, yes, please go ahead.
Okay. He was very sick. Before that, I think he had an open heart surgery about 2 years back.
That we know. That we know.
He used to come to office, but lately, I think, of course, 87. I think he was so, and a grand old man, and of course, the Bhishma Pitama, as far as we are all concerned in COS ISC.
Yeah,
he started that
exactly.
center. Yeah,
He initiated the whole thing.
We'll completely agree on that. Yes.
Yeah.
He had to pursue with planning commission and many policy decisions.
Yes, I have just prepared a slide, sir.
Very good. Very good.
Sir. I have prepared just a slide that I can share from here.
Sure. Very good.
Very excellent. We can, we can do that. Shouldn't be a problem. Or whenever you prefer. Yeah, whenever you prefer. I leave it to you.
Was he your supervisor directly? Srinivasan was?
No, not directly. But, those days it was a very small center, so each one knew what the other was doing. So he was very closely following what all I did in my PhD. So, and of course, I worked informally at NAL on their parallel computers. And he was instrumental in...
Sinha. I know those days. I was also into the game. Where is Sinha nowadays? Sinha. Where is Sinha nowadays?
He's also quite old now. Sinha is in Bangalore only.
Yes, we can start the session.
Sir, we are live, sir. Please start the session. We are live.
Yeah, Patnaik?
Yes, sir. Should we start?
Yeah, please.
Okay. Yeah. Very good morning to all of you for this second day of Tropmet 2020. And before we start the proceedings, we have the three plenary speakers by distinguished scientists. and the session will be chairing by Professor S.K. Das and Dr. K.J. Ramesh, who will be chairing the session. And we have three distinguished speakers who will be speaking on this occasion. And as you know, this early morning we got a very bad news: the sad demise of Professor R. Narasimha. And before we start our proceedings, we should just briefly pay tribute to him. So I will just share a slide I have prepared. Yeah. Yes. Hope you all can see this slide. Yeah. So this is a yesterday news. This is the yesterday news. He breathed his last in a hospital in southern India. And basically, his career started with scientific contribution in ISRO and various projects like Light Combat Aircraft project. He was Professor Satish Dhawan's first student. He remained active until the very end, working even in 2020 from the Jawaharlal Nehru Center for Advanced Scientific Research and ISC, Bangalore. He obtained the equivalent of an ME in 1955 and an MSc by research in 1957 from the Indian Institute of Science and his PhD from Caltech in 1961. Returning from the US in 1962, he built an active research group at ISC in aerospace and atmospheric fluid dynamics. His major research interests are in transitional and turbulent flows, the design of aerodynamically efficient wings of turboprop aircraft, the flow within a shock wave, the atmospheric boundary layer in the Indian tropics, and the fluid dynamics of cumulus clouds, a profile shared with TOE by this thing. His contribution, particularly in the meteorology, will be remembered in the field of boundary layer meteorology is significant. IMS is deeply saddened to know his demise and pay respectful tribute to him. Namaskar. Now I hand over the session to our chairman, Professor S.K. Das sir, and Dr. K.J. Ramesh sir to take this session forward. Thank you.
Yes, that's sir.
Welcome you all to this second day of virtual Tropmet 2020. First day was very successful, and we must congratulate IMS. I thank IMS to ask me to chair the session along with our distinguished scientist, Dr. K.J. Ramesh, who has been appointed as a member, full-time member of the Permanent Commission by the Government of India to tackle the air pollution in the NCR Delhi. It's a pleasure for me. And I also pay tribute to Dr. Rodar Narasimha, who has immensely contributed. All will in future. And I would like to say that this particular session, incidentally, all the speakers belong to one of the premier institute in the country, that is to the weather forecasting and as well as the climate modeling, both side of observational studies and the modeling. It is well known internationally, and all the three speakers belong to that institute. As you know, the first speaker will be Dr. Ravin Ranjindya, who is the director of the institute, under whose leadership all the activities are going on. And all the three have been decorated by fellowships and the awards, etc., for their immense contribution to our field. All of you know them. I don't have to introduce by saying so many words about them, but I would like to say that Dr. Ravi Nanjundia has been his most contribution, so far as I understand, to the application of to our field in climate modeling, in monsoon modeling, and he has in pioneer work done in this field, and and published so many papers. And today's lecture by him is also on the similar topic, that is artificial intelligence and ML. And Dr. Krishnan is very well known, who will be remembered for his contribution to this building development of the climate Earth system model, which is for the first time gone into the IPCC. And he has also produced a report for the future. And Dr. Sahai is another distinguished scientist. He will be remembered for his contribution to the extended range forecasting, which we have been getting time and again, several people, and IMD also using those for the extended range forecast, break, etc., active and break monsoon transitions, etc. All these scientists, in addition to their personal contribution to the science, have definitely contributed to the building of this infrastructure and set up scientific spirit in the country, which will be emulated by the young scientists in times to come in future. I consider that these are very significant contribution. With these words, I will hand over to Dr. Ramesh to initially begin his whatever he would like to say before the session. And then we'll invite. So, Dr. Ramesh, please.
Thank you so much, Professor Dash, and very good morning to very distinguished, highly distinguished colleagues. And we are grateful to IMS and the host of Tropmet 2020, the Northeast Space Application Center, led by Dr. Raju and his team, Kundu and all. And they have done a great job in organizing this on virtual mode. And thank you so much for the efforts put in for this event to be organized like this. So coming back to the session, we have a very, very distinguished people talking about on the issues of high relevance of today's weather and climate services globally. And India, led by these three people, have already contributed significantly to the advancement of science in several disciplines. And Professor Nanjundaya's leadership has been demonstrated by the deliverables that are seen and used for operational services, improved operational services in India last 3 to 5 years. And without losing further time, Professor Nanjundaya has been pioneer in parallel processing and writing the Indian version of the global circulation model. And now he is going to talk to us on very important issues pertaining to artificial intelligence and machine learning and their applications in weather and climate services. I request Dr. Das to invite the distinguished speakers for their presentations. Thank you.
Thank you, Dr. Ramesh. Now I invite Dr. Abhinanjan to start his presentation. I would like to say to all the speakers that 20 minutes will be the presentation time, and please leave around 10 minutes so that we can go to the chat session, because we request all the participants to put their questions on the chat session, where we'll look into and discuss for around 10 minutes. And we'll give a signal. Maybe I will raise my hand after 20 minutes. Dr. Abhinanjan, please.
Thank you, Professor Dash, and thank you, Dr. Ramesh. Uh, I mean, it's been a privilege to give this talk on use of AI and ML for weather and climate. And I would like to dedicate this to the memory of Professor Narasimha, who was the mentor for us, for all of us that when we were students and also faculty at COS. And I'll say only a very brief incident about Professor Narasimha. Like 20 years back, I had a discussion with him, and his view was that, the future is going to be data driven, and that it's going to be more like algorithms rather than numerical models. Data-driven things will be more important. Data-driven systems will be more important. This was way back in 2005 or 2006, when I think, and I had a violent disagreement with him and said, no, this cannot be possible. I mean, the numerical model being looked at, being researched on. It is the data-driven methods will have a bright future, is what he said. And AI and ML are, of course, two major data-driven techniques. And his words have come true. Before that, he also had a vision about parallel computing. When the rest of the world didn't really think much about parallel computing, he started India's first parallel computer at NAL. And I was privileged to use it for my research on atmospheric modeling. And it was that parallel computer was a pioneering effort, and perhaps in the world I could say that we were one of the first to kind of run an atmospheric model on a parallel computer, thanks to Professor Narasimha's vision and his sagacity. I dedicate this talk to him, and the co-author with me on this talk, and most of the work has actually been done by my young postdoctoral associate, Dr. Momita Saha, who's an expert on AI and ML. And whatever I know about AI and ML today is thanks to what she has taught me. So please go to the next slide, please. Yeah, so this is a kind of and I'll talk about why we need to do AI ML. These days it's the buzzword and everybody is aware of it, but I'll not spend too much time on that. And how we have used it for Indian monsoon and various aspects, the seasonal prediction of Indian monsoon, looking at, kind of identification of active and break spells, and also perhaps the first model for the Equino based on AI and ML, and then how it has been used for solar energy, and of course about future research. Next slide, please. So I'll not spend too much time on introduction. We all know that weather and climate phenomena are fairly complex. And of course, Indian summer monsoon, I don't have to tell this audience that it's extremely important for all of us, for everything that we do in India. And when we talk about wet and dry spells, predicting them is extremely important, and it will be very helpful in determining agricultural practices. And also, we can also be prepared for extremes. We know that ENSO and Equino are major factors which influence our Indian monsoon, and it is necessary to predict them. I think there are hardly any techniques for prediction. Of course, we can derive data from seasonal prediction models, but dedicated models for Equino are not there. And we have tried to use AI and ML, and perhaps the first model based on AI ML for Equino has been developed by us. And of course, when it comes to renewable energy, you know that solar energy is extremely important and is the future. And we are going to use more and more of it. So it is important that we predict it in a kind of a nowcasting sense in the next immediate future for the next 3 to 6 hours. And it's extremely important for that. And I'll also talk briefly about how we can use AI ML inside numerical models, like using hybrid models, where part of the coding, like empirical part of a model, could be happening within from the AI ML technique, which would be embedded within a numerical model. So that's, in brief, is the talk I'm going to give. Please go to the next slide. So just a brief sentence about why we use machine learning for weather and climate. The key motivation of using machine learning is because now we have huge amount of data available. This data could be coming from satellites. It could be coming from a slew of numerical models. In a sense, weather and climate is now becoming a big data problem. And there has been major strides in AI ML in India and elsewhere. And it shows that these techniques can attain a high degree of accuracy in predicting Indian monsoon and other related phenomena. And please go to the next slide. So Indian summer monsoon, we know it has variation in space and time, right from intra-seasonal scale, or even let's say intra-daily scale to intra-annual to inter-decadal scales. And I don't think I need to spend too much time on introducing Indian summer monsoon to this August audience. Please go to the next slide. Yeah, so I'll now start talking about some of the techniques that we have used for predicting the seasonal Indian summer monsoon. One of them is the clustering-based ensemble approach to prediction of the Indian summer monsoon. The details of where you can find more details of it are in the references which are given here. Please go to the next slide. So when we talk about clustering-based approach for monsoon prediction, we all know that monsoon, of course, varies from year to year or month to month, as we have seen. And we can use two approaches. One is the fuzzy clustering approach, and the other one is called as the subspace clustering approach. I'll not go into too much of details of that. Fuzzy clustering involves the support of blend of different phenomena to a particular year. Why that is a different phenomena. I mean, a year can be more than one cluster, because that's what the whole thing about fuzziness is. And the second one is the subspace clustering. Here you cluster the monsoon years with separate predictors as a particular subspace. That is, you kind of do two separate events, and the details of the flow chart on how we do it is kind of shown here. I'll not go into the details of it due to lack of time. Please go to the next slide. And these are some of the predictors that we use. For various predictors which we use include, can you click on this thing called predictors there, please? Yeah, so these are the variables that we are using, which includes sea level pressure at various parts of the world, including equatorial Pacific Ocean at different lags and from different months. And there are a variety of them ranging from sea level pressure, air temperature, and in some places we also used winds. In this particular one, we have not used winds, but we have used SSTs, air temperatures, etc., and sea level pressure. Please click on the one that's called as back. Yeah, so these are the predictors, and where we use them is that, please go to the previous slide, please. Yeah, so from different regions of the world, using different techniques, we have identified these predictors, and which have the maximum information related to the Indian summer monsoon at different leads. We use this data. Please go to the next slide. So this is result for that, and what we are showing here is the RMS errors in percentage. Using multiple regression, we get three different clusters which are related to nothing but drought, near normal, and above normal. And this is the ensemble, the average of RMSE. And when we use different regression, and you also find that you have fairly good, reasonable RMSE errors when we use this. So we're using two different techniques. One is called as the multiple regression, and the other one is called as the perceptron. And when this was simple averaging, and when we do a weighted ensemble, then we kind of see that there is a kind of an improvement when both of them are giving almost equivalent results. So there's nothing much to talk about it. Next slide, please. So this is a work of essentially Momita's and my as a PhD student. That is an autoencoder based identification of monsoon predictors and prediction of the Indian summer monsoon. Next slide, please. So this is a kind of an overview, the picture of the flow chart on the right that you're seeing. And in this approach, we look for discovering new predictors. And this initiates that we take data as a grid over the entire globe. And each grid acts as an input to the autoencoder. Autoencoders, the idea is that it kind of abstracts information and reduces the dimensions of the data so that it becomes much more tractable. And then based on this new data that it creates using the autoencoder, it kind of goes into a artificial neural network and new monsoon predictors, which could be also combination, a nonlinear combination of the input variables. The input variables, as I said, could be winds, it could be temperature, it could be sea surface temperature, even geopotentials at various height at different leads. We can do is starting from about, we use the data from about 6 to 7 months in earlier and stop at about 2 to 3 months before the onset of the monsoon. That is, we do the predictions more like in the month of April, so that you have a 3-month lead on knowing the kind of monsoon that we are likely to have. So they can be the variables themselves, which are abstracted to a coarser way using the autoencoder, or they could be a combination of them, like you can combine temperature with, of course, you normalize them, and then we kind of do a combination of temperature and maybe pressure or temperature and winds to create a new nonlinear combination. Next slide, please. So these are some of the results, and these are the two figures that I'm showing on the left when we use air temperature, the regions from where we use the data, and on the right side is sea surface temperature. And we find that when we use air temperature alone, we get with an error of absolute mean error of about 4.5. And when we combine air temperature with SST, the error kind of increases marginally to about 4.8. So these are with various variables that you can see, and we are using a regression tree for this particular purpose. And when we are, as I said, 4.5, SST itself is 5.3, but when we combine SST and air temperature, that is a 2-meter air temperature, which we can use over both land and ocean, while sea surface temperature is only giving you information about sea over the ocean. We combine it, then combining sea surface temperature and air temperature, we kind of get an error of about 4.8%. Next slide, please. So we have used different predictors of air temperature, sea surface temperature, and sea level pressure, and they provide errors of this order of 4.4. That's about around 5%, we could say. If you were to look at a statistical model, the most commonly used statistical model is from IMD, which has an error of about 7.5%. And these are the other details. And this is how it kind of behaves for different, if you look at the errors, we find that the error is much smaller for our model. And it's also comparable to what a numerical model does. And it's here we have the correlation, the temporal correlation at 0.81 with the different 2.8. That's around 0.8 you get it, which compares, I guess, reasonably well with what a numerical model does. Next slide, please. So that was just one level of encoder. That is, you have one level of encoder, an input and an output. But what you can do is you can do even better feature extraction if you use multi-levels of these encoders and kind of combine the data in a much more sophisticated fashion. And we use that for the Indian summer monsoon itself, All India JJAS. We also used it for early and late monsoon, that is for June, July, prediction for June, July with a lead of about 2 to 3 months, and August and September with a lead of 3 months. And also for the different homogeneous regions of India. There's the 4 homogeneous regions which IMD generally talks about. So for that, we try to do stacked encoder. That is a multi-level encoders we used. So the data of input from one goes as the output of the first encoder goes as an input to the second one, and so on and so forth. Next slide, please. Next, yeah. So this is about what the autoencoder does. As I said previously, we used only a single level autoencoder. Now here we are using multi-level stacked encoder, and as I said, we do all that which I've already mentioned, and it has an automated feature of learning and identifying new monsoon predictors, and features are learned at different abstraction at different levels, that is at multiple levels you can use it. We tried many levels and then found that after about 2 or 3 levels of abstraction, the increase in information was not much more, so we stopped, I think, at about 3 levels of encoders. So I'll Please go to the next slide. So if we look at it, when we used a multi-level autoencoder with SLP and that is a sea level pressure and sea surface temperature, in April we could get a mean error of about 2.8. And if we used a sea level pressure and U wind, it produced an error of 3.7, which I think is quite good. And you can see its comparison in time. Maybe the chart is a little small, but you can see that it behaves quite well, and most of the extremes are well predicted when we use an multi-level autoencoder. Next slide, please. So this is the prediction that we gave this year. Our prediction based on various parameters range from about 105 to 108. And one of them even showed 110. And if we take the average, a simple overall average using the multi-level autoencoder, we've stacked encoder, that's what I meant. We got a thing of about 107, which is very close to about 108 or 109 that we got for, which was the actual rainfall that happened this year. So you can see that even though we stopped training it in say about, I think training was done for about 15 or 20 years of data. And then we it was done about 30 years of data. And then we had done independent testing for 15 years. And we had not retrained or done anything in the last 3 or 4 years. And even then it has been able to capture reasonably well this year's monsoon. Of course, last year's monsoon, we had some issues. It gave about 102% of it. And actually in June, when things were really going bad, quite a few people, when I told them that my model was giving about 100 or 102%, nobody believed me. And they said, if it reached 100%, I should be lucky and that my model is going to be way out. But luckily for our country, the rains, especially in the later part of the season, was much more. And we actually got excess one after a very long time. That's around 110%. Of course, the model could not capture the extreme of 110 last year, but it did reasonably well by saying that it's going to be near normal or above normal, certainly not below normal, which is what it looked at in the early part of the monsoon last year. Next slide, please. This is now for June, July, and August, September months. And we find that using the same stacked autoencoder, we get a fairly good prediction. That is, for the late monsoon, we get a better prediction at around 5%, while for the early part of the monsoon, that is for June, July, it has an error of about 6%. And if you compare it with the IMD statistical model, which gives about 7.8% error, I think it is doing quite better, and it could be a promising candidate if you want to go ahead with data-driven models. Please go ahead. Next slide, please. Yeah. So this is for various regions and how it has done in the recent past, the validation or the testing part of the models of the model data. And you can see that for the central Indian region, the error is about 4.1%, while for the Northeast, it is 5%. And for similarly for Northwest India, for 6% for the southern peninsular India. And IMD predicts it with an error of about 8%. So it looks like that this is a good method to, if you want to use statistical, if you want to call it statistical or you want to call it as a data-driven model. This looks like a good method if you want to continue with data-driven models. Next slide, please. We also tried to do two things for active and break spells. We all know that active and break spells are very important. A year when there are long active spells are good for the monsoon, and when there are long dry spells, it's likely to be a below normal or a drought monsoon. And there are 2 years. This, I think, is 1975, and this is 2002. 2002 was kind of characterized by a long break in late June to mid or late July, while the monsoon was much stronger right through the season in 1975. So active break spells play a very major role in modulating the strength of the monsoon. And we have tried to kind of identify what active break spells are. using again a data-driven approach. There are various definitions, so we try to kind of use an automated technique, because then if you are looking at very large data, and if you're also looking at hundreds of years of data from models, we would like to know how well they are doing active and break spells. So a data-driven automatic technique would be much better. So we also did for a kind of identifying the active and break spells, and we all after that we try to also predict active and break spells. Okay, so I think I'll have to really rush it. So please go to the next slide. So we used a convolutional neural network based prediction for active and break spell. Next to the next slide, please. Yeah, these are details. I'll skip again of the CNN. Next slide, please. So this is how it compares for lead time of about 5 to 10 days for the period of 2000 to 2003. And we have done a comparison. The only model we could see was the self-organizing maps technique. And we found that the skills were much higher, of about 55% and 43% for August and September. So it shows that the skill is not as great as for the seasonal scale, but we can do a fairly good prediction about 5 to 10 days in advance. Next slide, please. So these are other details of the evaluation matrices which we have compared with the self-organizing map. This is the convolutional neural network. I'll not go into the details, but the average score improvement is about 20.3% in precision, 13.4 in the recall, and 16.7 in the F1 score. Next slide, please. Okay, I'll skip this. Skip the next 2 slides, please. Yeah, skip. This is the accuracy of it, and this is how we are able to predict dry day occurrence accuracy and overall accuracy. We find it's around 60%, which I think this is purely a classification problem. You take a large data and you don't actually use rainfall, but you actually use other predictors like OLR, winds, etc., and try to see if you can kind of see whether it's going to be a dry day or a wet day. And using that, we find that about 60 to 70%, we are able to predict it quite well. This is an initial work, and I think if we improve the data, we can more work on it, better techniques, we might be able to do it with a greater degree of accuracy. The identification. Next slide, please. So these are some other details. It detected all the 10 break spells and also identified 6 active spells. These are the other details of it. Next slide, please. To monsoon spells, this is another technique which we have used also fairly well, the long short memory and sequence to sequence models to identify monsoon spells over India. Next slide. Skip. Yeah, so we try to do it with various lead times, and of course at 5 days the skill is reasonable but not fantastic. But we can say that using, but it is certainly superior to other techniques such as KNN and SVM, which are also fairly popular techniques. So LSTM and sequence to sequence seem to be good methods. Skip next slide, please. Yeah, these are the other details on how well it has done. I'll skip. Equino, go to the next slide, please. So we used a deep learning based technique for ENSO and Equino indices during June to September. Next slide, please. And we basically used an ensemble of regression tree models for this and used unsupervised feature learning using autoencoders, the same method that I said previously, but this time we applied it for ENSO and Equino. Next slide, please. So this is the correlation that we are finding for ENSO. The correlation is about 0.87 with a lead time of about 1 month. Even with the longer lead time, we are getting fairly good correlations. Next slide, please. This is a comparison with existing models, and what you find is that the last one is what our model does. It's the errors that we are looking at, and it's kind of performing very well as compared to most other more established models. This is for JJA and this is for JJAS. This is for Equino, and it performs quite well. Sorry, you go to the next slide, please. Yeah, this is for Equino, and this is for to the best knowledge, the first one for Equino, the first model, and we can do a prediction of Equino at lead time of 6 to 7 months. This is basically the atmospheric component. When we talk of Equino, it is nothing but the atmospheric component of the Indian Ocean dipole. And it's we know that Indian Ocean dipole and Equino, its atmospheric counterpart, have a significant impact or have a significant correlation with Indian monsoon. And so predicting it would also be of extreme importance. So we find that it has pretty good correlation for JJS as well as for each of the individual months with the lead time of about 6 to 7 months. Next slide. This is about solar irradiance we have used for doing solar irradiance forecasting. Please go ahead. I'll skip this. So we have used attention-based dilated CNN so that we can use a longer data set and also see approach for that. And this is a detail. Next slide. Next slide, please. Yeah, so this is how we do. I mean, this is basically done by Momita, not by me. But they have done it for 2 regions. One is for Boulder, Colorado, and Fort Peck, Montana. And this is the kind of RMSE errors that they are getting. And if you look at it as compared to another simple persistence, it is performing very well as compared to simple persistence. That's what I would like to say, the CNN-based approach. And this is how well it does in the time series. We can see that the time series, the fluctuations, even if the actual magnitudes are not well captured, the fluctuations are very well captured by the CNN technique. And this is comparison with smart persistence, where you take additional information and include persistence. As compared to that, CNN seems to be doing much better. Next slide, please. This is another technique. For want of time, I'll skip and we will. Yeah, please go ahead. Yeah, so this is another technique. Yeah, I'm done. I'll skip. Yeah, so basically this is in some sense. Please go to the previous one. Yeah, so summary so far is that it's okay. The data-driven method is a good and cheap alternative and a viable option. Stacked encoders prediction is efficient for the Indian summer monsoon. Active break spells we are able to detect and predict with reasonable accuracy. And we have developed the first model for Equino. And it shows great promise for renewable energy prediction. Next slide. This is now for future approaches. One of them is that the empirical techniques such as cloud processes, cumulus parameterization as we call them, they are largely empirical and they can be built on machine learning techniques. Next slide. So this is basically about hybrid models that we are combining AI/ML with numerical models. So you can either do a parameter optimization or you can take something like super parameterization, which is extremely time consuming, abstract data from that and make AI/ML based technique to develop a cumulus parameterization. And the training of that so that it is computationally efficient, while super parameterization, though accurate, it is extremely inefficient computationally. It takes about 100 times a regular GCM. So, but when we take data, it kind of from that and build an AI/ML, it gives as good a result. That's what I would like to say, that this could be a future method for improving our numerical models. Next slide. Other emerging future research directions are for climate variation monitoring, such as sea level and increase in sea surface temperature, tracking of cyclones and storms, and others like annual interdecadal and spatial temperature. Next slide. Next slide, please. Yeah, for tracking of cyclones and spatial temperature variations, various clustering techniques we can use, and such as Markov techniques, etc., we can use to kind of do this kind of a spatial temporal variations. Next slide. Identifying extremes. This is another area where we can use AI and ML, which will be very important when we are talking of climate change. Next slide. So the question I think all of us have been asking is, can AI/ML replace numerical models? If AI, we have to give an analogy, we cannot replace a truck with a motorcycle. AI/ML is more like a motorcycle, and I would say numerical models are like trucks. They can carry a lot of things. They can do a lot of things. Motorcycle can be fast and efficient. So each of them have their own niches, we could say. So in future, I think numerical models are here to stay. But then an amalgam of both of them would be the best mix and the best win-win situation. Thank you. Yeah, I'm done.
Thank you very much, Professor Ravi Nanjundaya, for this very new and progressive approach for getting the extremes and characteristics of variability and forcings associated with the monsoon rainfall variability. Thank you very much for introducing this, and it has got a long promise to take us to predict extreme events and their variability in line with in complementary with the numerical models. That is wonderful. We have one question from the audience. Briefly, you can answer how the AI can be used for decision making in weather forecasting. Very briefly, please.
Sure, I'll be very brief. It can be used. I mean, it can we can kind of classify and the probability approach if you want to use AI/ML is a very good technique when you want to classify a particular prediction, how likely it is to be, how likely it is not likely to happen. All that can be used using various AI/ML techniques. We can use it to see, okay, we use in weather forecasting. And as I said, for solar irradiation and other nowcasting also, it can be used, and it can be a very efficient and a very useful tool. We combine both conventional AI, numerical methods as well as with AI/ML. We can kind of combine it to give higher quality forecasts. It can be very efficiently used.
Wonderful. Maybe you can try to get the details about the sunshine hours in next 4-5 days. That could be a very useful thing for our renewable energy operators. Thank you very much.
Dr. Ravi, yes, Dr. Ramesh, just one question. It's very interesting. I am also interested in that. One question has come up that can the model bias correction be achieved using artificial intelligence tools? Or in other words, how to combine HPC and NWP tool with an artificial intelligence together? The existing NWP models, how to find out the errors and use the HPC also?
Sure, it's a very interesting and a very good question, Dr. Professor Dash. Yes, we can do it. I mean, when we have enough data of the hindcast and also of observations, we can use AI/ML techniques to kind of remove the biases, and we can do it much more efficiently and much more accurately than any conventional statistical method that we generally use. I think we can use it, and I think people are trying to use it in various parts of the world.
Thank you so much. Excellent.
Thank you so much, Professor Ravi Nanjundaya. Now I'll invite, I have the pleasure of inviting Dr. Atul Sahai for his presentation on this Tropmet 2020 plenary session.
I think Dr. Krishnan sir.
Atul Sahai, please.
Dr. Krishnan sir was second. Dr. Krishnan,
Dr. Krishnan, next is Dr. Krishnan.
No, Krishnan just came. Okay, Krishnan is here. Sorry, Atul. Krishnan was not seen so far. That's why.
Okay, sir. Thank you.
Welcome, Dr. Krishnan. Welcome, Dr. Krishnan.
Thank you, Dr. Ramesh.
And Dr. Krishnan is a distinguished scientist who has built a Earth system model for India. I request Dr. Krishnan for his presentation today on this occasion of Tropmet 2020. Dr. Krishnan, please.
Okay, thank you. Just a minute. How do I share my screen? Yeah, this here.
Yeah, it has come. Go ahead, Krishnan.
Yeah, thank you, Chairs, Professor Dash and Dr. Ramesh, and thanks to IMSP for this opportunity. It's a great honor. Today, I will be talking about the observed changes in the western disturbances over the Himalayan region, given the theme of this workshop, Tropmet 2020 for the mountainous regions. And so western disturbances has been long studied, and there are many contributions by the Indian meteorologists and the scientific community. So the question is, what is climate change? Is it impacting the activity of the western disturbances over the Himalayan region? So keeping this in spirit, here are some, this will be my presentation. Basically, the assessment of climate change over Himalayas is very crucial. This is one of the drivers of the strongest monsoon systems in the globe, the Himalayas. It's a source of 10 major Asian river systems. It's the largest river of ice outside the polar region. It's a biodiversity hotspot, and it has diversity in culture, tradition, traditions and languages. So it's a very, very important region. So how climate change is going to affect the Himalayas is a very important topic. And so this region, the Himalayan region, receives rainfall both during the June, July, August, September, during the summer monsoon as well as the winter monsoon. This is a paper by Bookhagen in Burbank. So the central and the eastern parts of the Himalaya, much of the rain comes during the summer monsoon time, whereas the western Himalaya is more than nearly 50% or more comes during the winter monsoon, during the non-monsoon months. This is just to give a. So I'll be focusing on the. This is the rainfall, global pattern of rainfall during January to April, during the winter and pre-monsoon months, early pre-monsoon months. So the ITCZ, the region of rainfall activity, is mainly located to the south of the equator. You have the storm tracks. This is the big picture. And then you have these disturbances, what is shown coming from the Mediterranean, the Atlantic region. These transient systems, they come and they move eastward, produce rains over the Indian region. This is a very important component. And this is basically driven by the westerly jet stream. People have known this for many, many decades. So this is the strong subtropical westerly jet. We also have a mid-latitude westerly jet. So the subtropical jet stream is a very key component that provides energy for these disturbances to grow and develop through instability mechanisms. And so one of the earlier studies by Professor V.B. Rao and Trivikram Rao, this is 1971, they showed that basically the vertical shear of the zonal wind at about 28 degree in latitude, it can favor the growth of unstable disturbances around 7,000 kilometers. And they had done a very nice theoretical calculation using a quasi-geostrophic model. And they also looked at the data observations at that time. So mentioning that the time scale of this disturbance is about 8 to 10 days. So this was one of the earlier works. And then subsequently now we have more precipitation data and people are trying to look at further value additions, more refinement to the idea of a western disturbance going beyond a baroclinically unstable. And this was much earlier work by Professor Pisharati and Desai. They argued that these disturbances, the structure to the west of on the windward side, you have more of this squeezing of these streamlines, and on the downstream, you have the wind diverging out. This was a very nice conceptual picture. And probably then there was a nice review paper by Professor Dimri, which have so they argued that probably there is the role of the orographic gradients in the western Himalaya. You have all these ranges going from Pir Panjal, Great Himalayas to the Karakoram. So large orographic gradients are there. What is its role in maintaining these disturbances? So this is a very nice review paper. And so orographic impacts would also be important when we look at western disturbance. And this is one important paper by the Japanese, Zahara, Kimura, and Yasunari. They argued that the western disturbance is a quasi-stationary topographic Rossby wave. They say their argument, this is an example they took from the synoptic conditions during 1990. You can see this is on day 28 December. You have two troughs. One is one in the subtropical westerlies and one is a mid-latitude trough. And in the subsequent days, the mid-latitude trough seems to propagate faster, whereas the subtropical trough system is kind of getting anchored. And they proposed a very simple model based on a shallow water system of equation and giving the bottom topography. And they argued that the topographic gradients are very important in anchoring this western disturbance as a Rossby wave. And so why I'm saying this is now when we look at recent examples, this was in 2015 February, there were these deep troughs. When I say deep, meridionally very deep and also vertically, extending all the way from the mid-latitudes up to southern peninsula. And we had one such situation even yesterday, 2 days back. And this produces a lot of rains over the Himalayan foothills and precipitation, I would say precipitation. And this is the example of just on 28th. And so the question is this deepening of this trough, basically the amplitude of the trough is getting stronger. And this is there are many scenarios. I'll be coming to that. Now, when we look at 2020, the earliest, the winter was quite early. This is around 22nd November. areas in Himachal Pradesh, Kufri, Manali, they received substantial rainfall. And the NCMRWF predictions are also doing a pretty good job, not only in capturing the movement of the trough, also in the simulating the precipitation, predicting the precipitation patterns. And 22nd November was also a time when this tropical cyclone Nivar emerged in the South Bay of Bengal, which moved towards, which affected Tamil Nadu and Sri Lanka and other areas. So you can see the trough clear a deep north-south trough extending all the way from the mid-latitudes. And this is located even further northwest of the Afghanistan region, the trough center. And this was the, now this is at 850 millibar, you can see the low-level cyclonic circulation. And again, 11th December, we have another situation, again from the NCMRWF analysis. And this is the 4-day forecast valid on 15th December, that is today. So the activity is still seeing the intensification of the westerlies, the subtropical westerlies. And this is the precipitation forecast for 12th December. And the 24-hour forecast is pretty good. I will come to this. And incidentally, this is the INSAT 3D picture. So they are able to capture the precipitation. Even I've looked at even the 24-hour forecast and the 48-hour forecast. So the models are doing a pretty good job, not just the synoptic system, but also the precipitation associated with that. And so now when we look at 14th December, this is the situation of 14th December, a lot of snowfall in the Himalayas yesterday. And this was the forecast, this is the analysis on 14th December, this is the 1-day forecast on 15th December, and this is the 96-hour, the 4-day forecast starting from 11th. So the synoptic systems are captured very well in the forecast. That's one point I wanted to bring to the attention. So, and people have studied this in for a long time period. Now the question is, and there was a very nice study by Kiran Hunt and Andy Turner group. They have developed techniques for looking at the statistics of the western disturbances using the vorticity fields. This gives a idea that most of them are originating, most of them in the Mediterranean region, and some even in the, when you go back, even in the Atlantic, and quite a few even over the North America and parts of the Eastern Pacific. And I'll come to this later on. And this is one important paper. So a lot of work has been done. I need to acknowledge all of them. A very important paper, review paper by Dimri and group on the western disturbances. And also now the question is, how is climate change affecting, whether there are any signatures of this? And one of the biggest regions where the climate signal is very prominent is the Himalayas. And this was a recent report from the ECMOD, the HKH assessment report, where they show that many regions in the Tibetan Plateau, even the Western Himalayas, the Hindu Kush Himalayas, temperatures have been increasing at a very rapid rate. And in fact, diurnal temperature range has decreased. So the minimum temperatures are also increased in the recent 2-3 decades. And the diurnal temperature range has been declining, a very clear signal of the global warming. And now also there is a very nice paper by Professor Dash and Dimri on the wintertime climatic trends in the Western Himalayas. They looked at the data from SASE, and clearly they said, they noted that the data shows that the percentage number of warm days have increased while the number of cold days have decreased over the Western Himalayas from 1975 to 2006. However, they said that precipitation analysis, it shows a slightly decreasing trends, but spatially there are a lot of inconsistencies. There are no coherent trends spatially. This is what was their assessment. So a lot of work has been done from the Indians also. And I would like to draw attention to this work by Bhutiani et al. One of the important aspects of the temperature rise is there is elevation dependent warming. That the rate of warming as you go at the higher levels, higher elevations, is at a faster rate. Typically for elevations more than 2000 meters, the rate of warming is about 0.5 degrees per decade, whereas for the lower elevations, the warming rate is much lesser. This is at below 500 meters, that's about 0.2 degrees per decade. And many people have noted this. There's also some studies based from the Tibetan Plateau region. And the trends are most prominent during the winter as compared to the annual mean. And so the Chinese have also looked at this elevated Tibetan plateau warming based on the data over the Tibetan region. So much of the warming trend, the elevation dependent warming, is prominent in the vast areas of the high elevation central and eastern Tibetan plateau. And so this is a very important. So why this elevation dependent warming is happening? This is still an open topic of research. There was a very nice review paper by Pepin et al. In Nature Climate Change. They suggest that there are multiple mechanisms, feedback mechanisms, snow albedo feedback, surface feedbacks, water vapor feedback, latent heat release, and so on, and surface heat loss. So there are a variety of mechanisms. It is not just a single measure. So it's a combination of these physical processes that is contributing to the elevation dependent warming in the Tibetan region and other places of the world as well. Is a topic of open research. So I also want to draw your attention to this very important study by the SAC group in Ahmedabad, who are monitoring the snow and glaciers from the satellite. They are looking at the snow cover extent, snow cover area over different river basins. And one of the interesting things that comes out from that study is that many areas in the Western Himalayas, the snow cover extent has apparently increased over time. And I'll just show some of these. Some areas it has also decreased, but over some of the areas in the Bias and Parbati and subbasins of the Satluj, the snow cover extent has increased from the period. This is for the period 2004 to 2014. There has been an increase. This is based on remote sensing. And so the question is, with climate change, what will happen to the snow over the Himalayan region? What will happen to the glaciers? That is one of the very profound questions, because it has implications for the regional water resources. So there was a paper in science paper on the state and fate of the Himalayan glaciers. Dr. Anil Kulkarni is also part of this. So they say that many areas in the Himalayas where the glaciers are losing mass, there are some indications that the Western Himalayas, especially the Karakoram, it has remained mostly stable or probably a slight mass gain. And so the mass gain in the Himalayan Karakoram is also documented by another paper by Gardi et al. In the early 21st century. And now studies are indicating that there was a paper by the GFDL group which is saying that snowfall in the Karakoram is less sensitive to warming because of a unique seasonal cycle. This was based on the CMIP-5 analysis. And Professor Anil Kulkarni and Dr. Sailesh Naik and team, they have looked at the glacier retreat based on the measurements. What they find is many areas, the observations show that the glaciers have retreated, whereas you can see this green spot in the Western Himalaya where it has slightly advanced as well. So there are differences in the way the Western Himalayas has been behaving in terms of the snowfall and the cryospheric processes. And so the question is, is there a role of the Western disturbances, because it produces substantial precipitation in the region during this winter time? And what is happening to the activity of the Western disturbances, how it is affecting the precipitation in that region? So this is a paper by Cannon et al. Which appeared in 2015 in Climate Dynamics. So they looked at they made a very systematic analysis of WD based on the circulation characteristics. This red spot is a place further westward of where the rainfall over the Western Himalayas is happening. So when the circulation center is located at this place, this is the area where the Western Himalayas will get substantial precipitation. Whereas the precipitation, if you look at the central Himalayas, the circulation center at 200 millibar is located further westward. And what they noted was, then they looked at the time series geopotential height variations in these the red spots. They noted that power there was a strengthening of the circulation intensity over the Karakoram Himalaya slight during this period, 30-year period, 1979 to 2010, whereas the central Himalayas, in fact, there was a decreasing trend in the power. And this is one important study. And my own student, Dr. Madhura now, so she was looking at this study on the Western disturbances, trying to understand how it has changed from the reanalysis data. And we also noted that there has been an increasing trend in the amplitude variations of the WD. And this was based mostly on the reanalysis data and the circulation. And we could not make come to any conclusion on the attribution because we did not have model experiments. But we did hypothesize that probably the elevation dependent warming could be having a role in this amplitude variation of the WDs. And nevertheless, so it was more of a speculation that about the role of the elevation dependent warming on the WD activity. This was mostly based on observational studies and the reanalysis data. Subsequently, we wanted to do a modeling study, and I'll come to that. And now when we look at the heavy, although there are no changes in the seasonal mean precipitation over the Western Himalaya, but if you look at the extreme precipitation occurrences, more than, let us say, 90th percentile, that is clearly showing that many areas in the northwest Himalayan region is having an increasing trend. And this is seen in the Aphrodite data. And also when we look at some from the IMD data over the Indian region, also we see this. And more recently, we have looked at the TRIM data, the TRIM 3B42, which is available for a shorter period. That also shows that the daily precipitation extremes exceeding the 90th percentile have been increasing over this region. So precipitation increase have been happening. And now the question is, what is happening to the Western disturbances? Can we attribute it to climate change? So we did some experiments with a very high resolution model, which has the zooming, because we wanted to get the precipitation characteristics near the Himalayan region. It's very important to resolve the orographic features. So we had to go for this high resolution setup with a telescopic zooming of less than 35 kilometer grid. It is the grid spacing is not uniform spatially over this region or South Asia. It is telescopically zoomed. This, my colleague Dr. Sabine did these experiments, and we had two sets of experiment. One is a historical run, which includes all the natural variations like the irradiance changes, volcanic forcing, and so on, and the anthropogenic effects of increasing greenhouse gases, aerosol land cover changes. This is a long run from 1886 to 2005, 120-year run, both natural plus anthropogenic. We call it historical. The second experiment is a natural run, historical natural, which doesn't have this anthropogenic forcing. All the GHG concentration, aerosols, land cover values, and all they are fixed to the pre-industrial conditions of 1886. And only we have allowed the natural forcings to vary in time. So we try to compare this historical and historical natural and see whether we can do some attribution of how the changes in the WDs have happened. And we also have made a future projection based on a kind of moderate scenario known as the RCP 4.5. This was all based on the CMIP 5 scenarios into the future, going up to 2100. And so these are the concentrations of the CO2 concentrations in the future. So the 4.5 is a kind of a medium scenario. So we looked at the circulation centers over the GP1, which is
Dr. Krishnan, kindly 2 to 3 minutes.
Okay. So what we find from this analysis is that our results show that the increase in the precipitation from the historical run over the Western Himalayas is basically coming because of the it is related to the climate change signal, and there is an increase in the synoptic activity, the amplitude of the synoptic disturbances. So we made a detailed analysis. So I don't have time because I already started 15 minutes late, but anyway, I will cut down my talk. So the main gist is that this model is able to capture the synoptic activity and the precipitation changes. The main point is the increase in the historical simulation. When we have the greenhouse gas forcing, we do find an increase in the precipitation enhancement in this region, which we attribute it mainly to the intensification of the amplitude of the Western disturbances. That's the main point. And this is because as global warming is projected to stay in the future, this is going to continue in the future as well. So although many areas may be receiving less snowfall, snow amounts may decrease, the Western Himalayas could be an exception. That is the main point I want to tell. And since there is no time, the main result, what is it doing? This is one main point I want to say, that when we have this elevation dependent warming, what we find is there is a kind of stationary pattern that is being set up at the mid-tropospheric levels. And this is leading to a kind of anticyclonic circulation over the eastern and central Tibetan plateau. And to the western flank, you have a kind of a ridge type of thing. This is a stationary pattern, and this type of pattern favors increased synoptic activity. And this we have seen, you're looking at the layer heights at a different level as well. And so mainly our conclusion is that the winter to spring precipitation in the Western Himalayas, the increasing frequency is related to the climate change is having an important role due to the enhanced amplitude variations. In the stationary wave response, we see that there are changes in the subtropical winds and mid-tropospheric temperature gradients. This is related to the elevation dependency warming signals. And simulations show that snowfall enhancements in this region are related to the enhanced amplitude variations of WDs. And these are the two papers that I tried to cover in my talk. And as I said earlier, we want to investigate this with our own IITM ESM as well as part of the CMIP 6. And thanks for your kind attention. Thank you very much.
Thank you, Dr. Krishnan. It's an excellent talk. You have covered, as far as I know, all the work done on the Western disturbance. And there is first of all, I want to clarify that the 15 minutes delay has been taken care of by us. And we decided that 20 minutes and some discussion. So there is no shortage. Please don't think that.
Okay,
you have covered all. Thank you so much. Thank you so much. And now there's a question. There's a question from the audience. I can see that how the glacier melting part can be effectively done in the model simulation studies. Glacier melting part, how can it be done effectively?
Yeah, so what I covered was only the precipitation changes and the circulation changes. This information could be used to drive impact models like a glacier model and see what are the changes in the glacier mass balance. So when these changes in the temperature and precipitation and other parameters due to climate change, how the glaciers are going to respond. So that can be done. That's a separate study. So the glacier will be more of an impact assessment.
Okay. I would like to ask from my side, I don't see another question so far. So my question is that, there has been all the time discussion about the comparison between the Indian summer monsoon performance and the Western disturbance performance over India. And there is a lot of discussion that or anticipation that the Western disturbances gradually in the climate change projection, maybe the monsoon will be very much affected and the Western disturbance will be dominating, etc. There are so many, but what is your view from your study? What do you think about whether the Western disturbance really come southwards and the monsoon will be affected? What type of...
So one thing is generally the argument is that when with the increasing greenhouse gases, the water vapor is going to increase at a much faster rate as compared to precipitation. So one important dynamical consequence is that the tropical circulations can weaken. So this is what is expected, but still models have problems in simulating the tropical precipitation systems, the latent heating structure and so on. So that's still an open topic of research. But in general, for closed systems like the Walker circulation, the circulation intensity is supposed to weaken. So if that is going to happen in the monsoon region, there could be delays in the onset, and the Western disturbances could have they could get extended activity during May and so on. And so that could cause a delay in the monsoon because you have the cold air coming from the extratropics. The onset could get delayed. So, but we also have to look at what will happen to the withdrawal of the monsoon. So when we look at the sum total, it's not only so the onset phase could be a little tricky, but withdrawal could also, the season could also get extended. So it's a very tricky situation. What is going to, so when we look at the whole season, we have to consider the delayed withdrawal possibility as well as the extended monsoon season. So that is what is going to be important. This is
And now I can
rough
see,
idea.
yeah, thank you. I can see another question from Somanath Datta. Is the increase in temperature over the Hindu Kush region due to more latent heat release a result from increased rainfall there?
Yeah.
Does it, yeah.
Yeah, so it's a that's what, as I said, the elevation dependent warming and the processes are multiple. We cannot attribute it to one. So I would strongly recommend to read the Pepin et al. Paper. They have provided a very comprehensive review. So it may be a combination of mechanisms.
Okay. I think Dr. Ramesh has some meeting. He's busy and he has to leave. As you know, he has already. So thank you so much.
Thank you. Thank you, Professor Das.
Excellent talk. Thank you so
Thank you,
much.
Professor. Thanks a lot. Thank you.
Now, I think I request Dr. Sahai to give his talk on sub-seasonal to seasonal prediction. What are the initiatives and how it progresses? Dr. Sahai, please.
Thank you, sir. Thank you, Professor Das and Professor Ramesh. So, this is my topic, sub-seasonal to seasonal prediction, initiatives and progress. So, this will be my outline. First, I will cover what is S2S and what is this project, aims and objectives, global project, and then how sub-seasonal prediction system under monsoon mission. And then comparison of S2S model performance, and also summary and way forward, and then some climate services, how we application to climate services. So this is actually the weather events are predicted and the predictability is going down. Therefore the 5 to 7 days, maximum 10 days, they can be predicted because they are basically initial conditions driven. And then there is seasonal outlook for El Nino, temperature and precipitation anomalies. They are also having good skill because they are driven by boundary conditions. But in between there is a timeline from 2 weeks or 10 days to almost 1.5 months or up to 3 months, you can say, that is sub-seasonal to seasonal prediction. And this will be about storm tracks, heats, and all those things. So there, how we can give this prediction. So then this study says, this slide shows that there are some predictability in this scale from week to month in stratosphere, sudden stratosphere warming, MJO, and then soil moisture also. But INSO is just slightly away, but there is some effect of INSO also. So this, therefore, there is a large scale frequency, large scale low frequency intrastation oscillations like MJO and INSO. They are important source of predictability, and we can attempt on this. So WMO has taken one initiative and this is a collaborative project. They started proposed in 2009 and under WCRP, WRP, PEX. And then subsequent years of planning and first 5-year phase of project, which was launched in November 2013, and the present phase 2 of project began in January 2019. It will be ending in 2023. And various sub-projects from MJO to extreme weather events are there, and the website where you can find out what are these initiatives. So this is the aim was to improve forecast and skill and understanding of the sub-seasonal, seasonal time scales, and to promote the initiatives uptake by operational centers and exploitation by the applications community. So in the first phase, actually, basically the science and demonstration was there, how it is predicting various teleconnections and MJO and monsoons, how models are picking in this, and how to do the coupling, and what are the systematic errors, and a huge S2S database is available for this. Then in second phase, it was basically for services. So how science can be transferred to services, and how users can be partnered into this. So this is in the second phase is going on. And there is a project archive and data portal also, so where we can get 11 operational centers. And for 2 years, they are also giving real-time data, real-time forecast also. So anyone can find out there and can get forecast relevant to what he wants from these sites. So this is just one verification, this how data portal is there. So this top left is verification of 2-meter temperature, and it is a 5-day forecast from 22nd January, 12 to 18 days forecast, and how different models, ECMWF, JMA, NCEP, are picking these features of the less temperature anomaly, negative temperature anomaly, and positive temperature anomaly. So somewhere there is some mismatch, but some models are giving good results. So this is what we are getting with different models in 12 to 18 days lead time. And this is another example. The top one is the example of South Asian monsoon new bio rain band. And you see that this is the analysis rain band for it is 8 June to 14th June period. And this is the forecast by ECMWF model. You can see even 26 to 32 day forecast, these positive and negative bands were predicted. And if you see the African monsoon also, this is the positive and negative band. And this is also predicted And incidentally, same time, Government of India also planned this activity, and monsoon mission has been started that time, and actually it is started in 2012. And this is also for seasonal to sub-seasonal prediction. So India was at par in starting the initiatives with any leading center. So initiatives was also started same time, and we have collaborated with NCEP, and NCEP CFS model we got, and after several research and this, we are making now this using CFS model at 2 different resolution, T382 and T126, and then SST bias corrected. And again, so this initial conditions are coming from NCMRWF and INCOIS, and then we perturb these initial conditions. And now it is operational in IMD since 2016. And this we are using it for active break forecast during the monsoon, MESO MGO forecast, heat wave, cold wave forecast, and northeast monsoon cyclogenesis, so many things. And it is being used in agriculture, hydrology, energy, health sector, urban planning, etc. So this is what one example in 2017. This is the observed rainfall anomaly, standardized rainfall anomaly over monsoon zone, and we see that there is a active period, and then after that there is a prolonged break period. So there are 3-4 events. So I will concentrate on, though we have predicted all this, but just to show this one, how we are predicting active and break and persistent.
Hello, Dr. Sai? Dr. Sai? Dr. Patnaik?
Yeah. But Dr. Sahasa is, I think, showing weak connection. Just let us wait for 1 minute.
Okay.
Yeah, now I think just a minute.
He's coming back?
No, still it is yellow showing weak connection. Let us see.
Yeah. I think in the beginning today morning that IITM Dr. Ravinanjan initiated, that time also there was a little problem at
It may be their networking problem, sir.
10 o'clock, yeah. Around 10 o'clock when we sat together, before 10 o'clock. Can you contact Dr. Sahai?
Yeah, I am calling. I am just making a call.
Yeah, please.
अच्छा, आपका तो कनेक्शन नहीं आ पा रहा है, नहीं, आपका नहीं, येलो दिखा रहा है, कनेक्शन नहीं जा रहा है, स्लाइड रुक गया है.
And also we're not audible.
ये साउंड नहीं,
He is not audible also.
साउंड एंड वीडियो कुछ नहीं आ रहा है.
Sir, his network is down.
Puna,
Hello?
IITM network is down.
Yes,
I
sir.
don't think so. I am getting net, I think.
Yeah, now it's come.
In the meantime, I request the participants to please, delegates, please put your questions on the chat. In the earlier case, in case of Dr. Krishnan, actually one question came very late to me on the chat, so I couldn't ask.
Yeah.
You're there, Dr. Krishnan?
Yeah, I'm here. Yes, Professor Dash.
Yeah. So I'm again looking for that question.
Okay.
Somebody asked one question. I saw that.
Yeah.
I think Dr. Kulkarni, this is the problem on the network.
Yeah, let me see if I can see the.
Yeah, please, Dr.
Is this
Kulkarni.
the question is
Kulkarni.
where is that? I am not able to see that.
Yeah, no, I saw sometime back. Now I don't see. Dr. Patnaik?
Sir, can you see
please find that question, Doctor? I think at 9 I got it late, but at 9.
I got it. Do the climate change is affecting on the direction, frequency and intensity of western disturbances?
Hello.
Yeah. It is affecting definitely I can say the amplitude of the western disturbances. And the ones that are getting stronger, the over the western Himalayas, the anchoring. The frequency of the very strong amplitude disturbances are becoming more. That's
Dr.
what
Patnaik, can you put your speaker on the mute, please?
Okay, Dr. Krishnan. Well,
okay.
Dr. Sai is there now?
Yeah, I am.
Yeah. So Dr. Krishnan, probably after he ends your question, we got the answer partly.
Okay.
We will have some time after at the end and discuss. Okay.
Okay, sir. Thank you. Thank you,
Dr.
sir.
Saab, please continue.
Okay. Share button, please.
Share, please. Panelist share. Dr. Sahab, make him share. He panelist.
Okay,
It
sir.
is
Done,
not.
sir.
Okay.
Sir, please check, sir.
Yeah. Now it is.
Good. Please continue. It's share now.
Okay.
Dr. Saab, please continue.
Yeah, I am continuing. Yeah. So this was the comparison with S2S forecast. Before that, I was talking about how we are giving this active to break forecast, and then how we are giving heat wave and cyclogenesis forecast, and also we are giving monsoon intra-seasonal oscillation movement from south to north. You can see here, this is a negative anomaly, rainfall band. It is moving northward, and then there is a positive anomaly. It is coming, then again it is moving northward and northward. So this model is forecast is capturing even eastward movement of this anomaly is also captured here as a MJO. So, and similarly on the same, this has appeared in S2S newsletter last month only. This is the forecast for 21st to 27th August. And you see how is the multimodal ensemble mean for week 1, week 2, week 3, week 4 forecast. And here it is, there are many, all the sub-X models are there. There are 11 models. And here, this is what IITM IMD forecast. You can see this positive anomalies and negative anomalies are matching quite well. So this model is giving a good result. And even if you see the Mumbai rainfall of 2017, 29th, this is 29th August observation, and this is the bias. So this is the, you can see over Mumbai and over Gujarat, this region. This is our IITM model. This is ECMWF model. This is Meteo France model. So this model is bias is very less in the positive side, but others are having negative bias, and that is more clear here. This is the observation. This is Mumbai. And this is what our MME forecast, you can see, it is from Mumbai and up to this region, Gujarat region also, the rainfall is there. And this is ECMWF forecast, and this is Meteo France forecast. And this is the average of 5 days from 27 to August to 1st of September. And therefore, ECMW, our model is giving better forecast, and even ECMWF and our model has given extendable forecast in 3 to 8 days. This is another comparison with ECMWF, and the black one is our, and ECMWF is this red. And you can see that different pentats, it is always comparable. Also, it is comparable on the sub-divisional scale also. And this is the comparison with the UK Met Office Glossy 5 model. So these are different regions, and black one is UKMO, red one is IITM. And you can see that almost same at par, but sometimes there is slightly less. But if you see the northward propagation band and frequency and this wave number and domain analysis, so this is the observation here. And UK Met Office model only in week 1 it is matching, but slowly it is going towards more low frequency. But this is up to 4 weeks. IITM model is giving almost same as observations, and here there are a lot of, in high frequency also there are a lot of noise in UK Met Office, which is not there in observation and not there in IITM model. So we can see that this IATM IMD extended rain prediction system has a reasonable skill in predicting the extreme rainfall events and genesis and track of tropical cyclones. Also, significant progress on operational forecast at various spatial temporal scale has been made, and we are at par with top global centers. However, MJO could be predicted up to around 22 days lead time for IATM ERP, compared to ECMWF is having 30 days lead time. So there are still many things to be done for IATM, and for moving forward, efforts are underway to reduce spatial temporal errors by dynamical downscaling, artificial intelligence, and multi-physics based ensemble. And we are engaging more sectorial applications. So first application is a bias correction. So since there are different models, and after some time they will be diverging, large spread in the track and other things. So we did a signal amplification technique, and we based on oriented towards the ensemble mean, there is slightly more technical details here. But when we did it for cyclones, we found that 9-day average direct position index error in our forecast when we are not doing bias correction signal amplification is around 206 or 200 kilometer, but when we are doing bias correction and signal amplification, it is becoming almost 100 kilometers. So 50% improvement is there in the extreme forecast. Similarly, when we are doing multi-physics, now we want to change our system in two ways. Either we can do dynamical downscaling, or we will do multi-physics options. So this is one example of dynamical downscaling. And this is the analysis of two cyclones, Mora and Oki. Similarly here, Mora and Oki. And this is 12-kilometer GFS forecast. And this is raw ERP forecast. And this is what we have bias corrected and downscaled. So you can see the raw forecast is not giving any cyclogenesis activity, anything. But in downscale, it is giving for both the cyclones, Oki and Mora. And also, if you see the vertical structure, even in GFS 12-kilometer is not that much, but it is shown in the downscaled version. So there is a improvement in if we do dynamical downscaling. Also, if you are doing multi-physics ensemble initiatives, we found that there is an improvement up to in third week compared to what we are doing presently. And so we can say that we are working still on this, and we are also using artificial intelligence with this to do the downscaling and bias correction. Now I will show some sectorial applications in different sectors like agriculture and water health and risk reduction. So first, agriculture planning based on extended range climate forecast. So this is a bulletin every week. It is being issued by CRIDA, and the forecast is taken by IMD. So this is a joint venture. And every week on Friday, this bulletin is issued. This is the recent bulletin. And you will find that first they see what is the rainfall anomaly forecast from this model. And then they also see what is the maximum temperature and minimum temperature forecast for the next 2 weeks. And based on the realized rainfall of the previous up to previous week and this forecast, some advisories, agromet advisories are being issued. So for Kerala, here it is about some pest leaf folder attack on Mundakam paddy. Then Tamil Nadu, there will be weather condition for advised to monitor borer incidents. And then Maharashtra also some spot diseases, leaf spot disease and turmeric crop and something like. So this type of for each state and each strategic planning, like Himachal Pradesh, mulching is advised between 2 rows of vegetables, and then newly born calves with milch animals. This is for breeding animals and other things. So different type of planning agriculture is being issued based on our extended range forecast. Then in hydrological forecast also a weekly outlook of aridity anomaly 2 week ahead. This is the outlook, and this is the actual what has been observed. So there is a quite good resemblance in this. And this is just 2 week soil moisture change, how moisture is changing. So this type of various products are there already in our website, in IMD and IITM website. Then there is in health sector. So there are different uses. First use is in heat wave. This is a great success. So you see in the, this is the recent, this is the high, this is 2009, then 10, 11, 12, 13, 14, 15, 16 is the highest anomaly. And so last 10, 11 years, the highest anomalies are observed here in recent, and that is increasing heat waves and deaths and so many things. So how it we have planned it. So 2015, as you see, still 2015 is much less than 2016, but the deaths were maximum in 2015. Then after that, with our planning and intervention of NDMA, this has been possible that even though temperature were very high, but deaths were reduced to less than half. So this has been possible by intervention of NDMA and utilizing seasonal extended and short range forecast of weather and climate by IMD for efficient.
Please, couple of minutes.
Yes, 226, yes, and now in 2020 there are only 4 or 5 deaths. So this is a great success. Then we are how we are giving, this is the observation, and these are the forecast for maximum temperature for different weeks. You can see here. Also, we are giving health advisory based on this forecast for malaria and dengue. This is already experimentally being issued by IMD Pune, and then probabilistic also. This is based on only temperature, but now we have come up with that temperature, rainfall, and all those things can be utilized for better prediction, and then it can be used for malaria and other diseases predictions. So this how we are using in health sector. So the concluding and future scope is the current era, preparing a stakeholder to get weather ready and climate smart. The seamless multi-scale prediction strategy is the backbone of forecast-based risk maneuvering system. So this is what yesterday Dr. Mahapatra was mentioning, how to make weather ready and climate smart people. And we already have a seamless forecast system from seasonal to nowcasting. And initial application based on case studies using a strategy of seamless forecast information in health, agriculture, hydrology shows a great potential in this direction. But there are still problems in extremes. There is a positional shift, amplitude and frequency are underestimated. So work is in progress to address these issues using artificial intelligence and multiphysics in symbols. And therefore, what we want that a strong collaboration between weather climate scientists and stakeholders for research and data exchange and co-production of the product is a prerequisite for further improvement of services. So thank you. With this, I finish my presentation.
Dr. Sahai, thank you, Dr. Sahai. Your presentation shows direct relevance, that is application of the climate products for the climate service, weather and climate is very good really, and direct relevance to the society. I don't see any question on the chat. Probably Patnaik can help me later on, but I have a question now to you because you have done so much of work and continuing to do that in future also. You know that there are we're all getting three external prediction from three sources. And I'm sure that you are examining those very critically. One is that UK Met Office, another is yours, and the third one from IMD side. What is your view about convergence of these three types of extended forecast?
Yeah, there is no confusion. First, it is IMD.
And convergence.
No, just
I'm asking about
No, I'm saying the IITM IMD forecast is same. So there is no two different forecast. Number one, there is different forecast with NCM-IWF. And we are working on to make it multimodal using NCM-IWF and IMD IITM forecast. So this work is going on. Maybe from next monsoon, we will get this multimodal. As far as comparison is concerned, I have shown you that it is well compared with the UK Met Office and ITM and even ECMWF. They are all at par. So a multimodal is very much required, and for that we are working.
Okay. Thank you so much.
There is a question. Can I read, sir? There is a question.
Sure. I am asking you to help me to find out the questions, or you can read the question and Dr. Sahai will answer.
Yeah, this is a one question. Just I think with so many predictions, why farmers are advised poorly?
I don't know which context this question is, but we have seen that farmers are advised properly, and there are various channels to advise them through maybe radio to SMS to everything we are doing, and we are advising farmers with good practice and what they have to do, but they have to adopt. And already this report, NCAER report on how this forecast have impacted, and there is a 50-fold impact in economic value and basically on farmers. So that is already shown. So I don't think in which context this question is. If there is any specific context, you can write me, I will answer.
Yeah. Dr. Patnaik, did you get any other question?
I don't have any question. That's fine.
Okay. So let us thank Dr. Sahai. And
Thank you,
now I think just I'll give, if Dr. Krishnan is here and Dr. Ravi is also here, then I just can give them last 1 minute each to, if they want to speak something on their presentation and that issue. Just Dr. Krishnan, you were telling something that time.
Professor Dash, only thing in the last I had to rush through my slides. The main message I wanted to convey is the elevation dependent warming in the Tibetan plateau is altering the large scale circulation, and this is increasing the amplitude of the western disturbances. So, and this is going to continue, likely to continue in the future, because global warming is there to last for many decades. So precipitation and snowfall in that region, Western Himalayas, Karakoram, may be protected by the western disturbances. That is my point.
Okay.
If everybody will make camera video on, then I can take a photograph.
Okay, Dr. Sahai, you want to add something?
No, it is fine.
Okay. Thank you so much. Excellent. I thank all the three speakers. There is a lot of new information and research going all at the emerging fields. Thank you so much for your cooperation in maintaining the time. I'm sorry if I had to tell you to stop. I'm very sorry for that, but it is my constraint as chairman.
No problem. No problem, Professor Dash. Thank you very much.
I want to say that I don't know where I was stopped in the first, so I started second. So some slides might have been left in that.
No, the time you lost, I had tried to maintain that. I have given you that time to you.
No, I'm not saying time. My slides, I don't know how many I have.
Okay, yeah, that's true. But anyway, this is very good presentation and a lot of new information. And I'm sure all the participants got very good picture of what is happening and what is going to happen. Thank you so much.
Thank you, Professor Dash. Thank you.
If Ravi Sahib is there, we will take a photograph, group photograph, all video. Camera, can you on? Ravi Sahib is there?
Ravi Sahib is there on.
On, but video is not look here. Where is
no, it is there. We can see.
Achha,
is
okay,
there?
Okay. Is there?
I don't see him. I don't see him.
Yeah, now I can see. So, yeah. Fine.
Yeah.
Yeah, I have taken photo. Fine.
Okay. Thank you so much. Bye.
Thank you so much. Bye.
Hello.
Okay.
Am I audible?
Yes, sir.
I am Somnath Datta speaking. Am I audible?
Yes.
Yeah. You are audible.
But I think I am not visible. There is some problem in the camera, I think.
But we can see you, sir.
You can see? Okay, then no problem.
You cannot see.
Kunduji, can you see me? Can you hear me?
Good morning, Soma sir. Good morning, sir.
Good morning to everyone.
Good morning.
Can you see my camera properly and me and my voice is coming properly?
You are visible very well.
And voice is also proper.
Yeah, fine. No.
Okay, thank you so much.
Very good.
We would request to speak one at a time, please.
Yeah, Somnath Datta sir, you are not visible. Panel दिखाओ तो एक बार participants.
Actually, I don't know. Maybe there is some problem.
There only. But can you?
So can we request if one at a time person can speak, please?
Yeah, it's okay.
I am able to hear all of you.
Okay. We can only see whether you are able to share. Alcord, can you enable sharing for?
No, I am not able to share. Correct. I am not able to share even.
Can you enable sharing for Somnath Datta?
No, I am not able to share.
But first one is Som Kumar Sharma.
No, okay, वो ठीक है, but only for checking के लिए सोमनाथ दत्त को कर दीजिए एक बार.
Good morning, Dr. Kundu.
Please check, sir. सोमनाथ सर.
सोमनाथ दत्त सर, आपको शेयर इनेबल किया है?
अच्छा ठीक है, मैं चेक करता हूँ.
शेयरिंग आया है, इनेबल हुआ?
अभी शेयरिंग तो इनेबल हुआ है. आई एम नाउ चेकिंग वन.
जस्ट चेक किया है.
अब देखिए तो इज इट.
आपका पावर पॉइंट आ रहा है, सो आप ऑडियो भी क्लियर है, पावर पॉइंट भी क्लियर है. आई थिंक वीडियो सम प्रॉब्लम मे बी.
Doesn't matter.
Yeah. So fine. I think then we'll start this session.
Okay.
No, we are waiting for the co-chair Rahul Mohanto. You have panel में देखो.
That co-chair is Rahul Mahanta from Cotton University.
He has not yet come. We are just attendee देखो.
Not come.
May I request one of the person to speak at one time, please?
What is he speaking now?
Kunduji, whenever I need to start, please let me know. Dear Dr. Kunduji, whenever I need to start, please let me know. Okay, I am online.
Yes, sir. We are just waiting for Dr. Rahul Mohanto. Just see 2-3 minutes. If
Okay,
then
okay,
we will
fine,
start.
fine.
Sir,
Fine,
you
fine.
might have already got a Excel sheet for evaluation. Now this is the program button. Sir, your audio नहीं आ रहा है आपका.
He
Audio
printed
mute
the
हो-
sheet. Okay.
No, not this sheet, sir. Google Doc में और Excel sheet भेजा होगा किसी ने, वो एक evaluation के लिए.
Okay, no, what I will do, I will evaluate on that 4 points what we know and write on that this one, okay? And then I'll fill in the Google Doc and send to you, okay?
Oh, that's not a problem. You can take it. I just wanted to confirm whether you have received.
Sure.
And one more thing, sir. Actually, after the end of this session, we will just because Secretary MOES wanted to have a recommendation from the committee. I mean, from the entire symposium. So
Okay.
from each session, what is 4-5 takeaway message?
Okay.
If you can give us 4-5 bullets, at the end of the session.
Okay, fine. So that I need to send to you in the PowerPoint or Word format, okay? Your voice is not coming, Kunduji.
What file में 4-5 point में?
Okay, 4-5 point चाहिए the recommendation from this session.
From this session, yeah.
Okay, nice. So afternoon I will send to you. Okay.
Right. क्या हो रहा है मोहन जी? वो लॉगिन किया लेकिन देख नहीं पा रहा है.
So as per my list, the total 10 presentations are there in this session, including mine one. So 9 are contributed and one is mine one is a lead talk. Am I right?
Yes, sir. Your one is the lead talk, sir.
Yeah, and other nine are contributed, and I believe all may be presenting and are present.
Yes, sir.
Okay.
Rekha, can I request you to please take this conversation as a separate thing, because everyone can hear it, and I would request everyone if one person can speak at a time.
Okay, sure.
Good morning, Dr. Rekha. Can you grant me access for sharing my presentation?
Actually, sir, during your presentation only, your share button will be enabled. You want to test it?
No, it's okay. During my presentation, you can access it.
Please check, sir. I given you.
I did. Unmute.
Yeah, we'll start now. Shom Kumar Sharma sir, I think the co-chair is trying. Some technical issue from his end, internet problem थोड़ा सा. So as and when he comes, we'll bring him in. So we'll start.
Okay, so Kunduji, just after 1 minute, I will give mic to you because that you have to do this because co-chair is not there. So it will not look good. I introduce myself. Okay,
No, sir. Actually, formally,
we'll do that, sir.
introduce.
Okay, fine. So I will just should I start now?
No, I think sir, just a welcome from my colleague Rekha. She will do that, and then.
Sure.
Okay, let me introduce you, sir, because all the gathering should know who are you and your field of expertise. Yeah. A very good morning to one and all, everybody present today. Today is the second day of Tropmet 2020, and now we are going to start the first technical session of the today's on 15 December. The today's session is Dynamics and Physics of Orographic Clouds and Precipitation. To chair the session, we have with us Dr. Som Kumar Sharma. And before handing over him the session, I just want to give a brief introduction. Dr. Somkumar Sharma, sir is an associate professor, Space and Atmospheric Sciences Division, Physical Research Laboratory. Sir has expertise in different domains such as study of the Earth's lower and middle atmosphere over tropical and subtropical regions using LIDAR, satellites, and models, vertical and latitudinal coupling of different regions of the Earth atmosphere, study of long-term trends and changes in the Earth atmosphere, observational and modeling studies of clouds. Sir has more than 80 peer-reviewed papers. Sir is an recipient of many awards and honors. With this, I hereby request Dr. Somkumar Sharma sir kindly chair the session. Over to you, sir. And also, I request sir to give the lead talk, and it's an invited lead talk, and the topic of the talk is investigations of atmospheric cloud and boundary layer over India using ground-based LiDAR. Over to you, sir.
Okay, thank you, Dr. Rekha ji, for nice introduction. I am thankful to the Tropmet organizers at the national level and the organizers at NESAC, Dr. PLN Raju ji, Director NESAC, and local convener, Dr. SS Kundu ji, to giving me this opportunity to be with you, to discuss with you my work, and to have a administrative responsibility of chairing this session. So I am thankful to all who has given me this opportunity at national level as well as on local level in NESAC. And as I learned in this session, there are total 10 presentation. So one is a invited lead talk that will be given by me, and other are contributed papers, and they are total 9 papers, and they will be presented in this session. So with this, Rekha ji, should I start my presentation?
Yes, sir. Please start.
Okay, so I will share my screen, and can you see that whether the screen is visible to everyone? Whether Rekha ji, can you see the screen?
No, sir.
Please share,
No,
sir.
The screen is
Okay,
not visible.
okay,
Please share.
okay. Just a minute. I have to share first.
Yes,
Okay.
sir.
So now I have shared.
It's visible, sir. Please go
It's
to the
visible now,
slideshow
no?
mode. Yeah.
Yeah, it is visible, and my voice is clear.
Yes, sir.
Okay. So once again, I am thankful to the organizer at national and at local NESAC level for this nice opportunity to discuss about few things what I am involved since last 5 to 7 years, investigations of the lower and middle atmospheric process. And today I will be concentrating mostly on the atmospheric clouds and boundary layer variability. And in this, as our colleagues, as I told, the SS Kunduji and Dr. PLN Raju from NESAC, because we have one LIDAR laboratory at NESAC, and they are our very close collaborators in this national program which we have started. And another is my colleague at PRL, Sarita Saha. So this is being presented by me, but all has contributed, like SS Kundu, Sarita Saha, and PLN Raju. And I am presenting on behalf of all, or you can say that is a collaborative work which I have initiated over India. So to start with that, you know, the clouds are like astronomical objects. Astronomy is a very fascinating and the oldest field of science. And the reason I could think, because in astronomy, you can see by naked eyes also few things. Some stars, some planets, and few objects you can see by naked eyes if you go to the remote place. Of course, in the urban areas nowadays, it's very difficult to see due to pollution. But if you go to the remote areas, you can beautifully see the celestial objects like stars, planets, galaxies, something you can see. And that's what it makes us fascinating. And same in the troposphere, these clouds are like astronomical objects for us, because every individual can see the cloud in the sky. And the clouds, you see the fascinating view and different facets of the atmospheric cloud. If you see beautiful clouds like like a design, and there are so many structures in the cloud and so many things. I will cover few things here. So they are very fascinating, and you can see by visible eyes. So this is a societal perspective. Everybody sees the cloud. But I will take you into another domain where it's like the scientific view of the cloud. Anybody can see the clouds. There is a cloud, of course, cloud. But there are scientific views of the cloud, why we should study or investigate the cloud, why they are important. So this is just fascinating view. And then you see the clouds are just giving more fascinating view of other processes. Like in the air, you cannot see the wave feature. In clear air, you cannot see by naked eyes the waves. But you can very clearly see the features of the wave in the clouds, which are embedded in the clouds. These pictures are shown that imprint of gravity wave in the different types of clouds. So you see that there you can say in the indirect way of investigating the dynamics, or you can say the wave feature into the atmosphere. So they are providing us the platform. So that is another important thing. And not only to the, you can say the atmospheric scientists, even the ocean scientists, there you see the oceanic waves are also getting imprinted in the cloud structures. There are beautiful oceanic waves you can see. These are the oceanic waves which are imprinted in the clouds, and these are so fascinating. So this I will say now, what scientists try to look into the clouds. This was just like fascinating view. We get the platform for investing different types of waves. Oceanographers can get the oceanic waves. Why to study the clouds? You know, nowadays even if anything you start, even our children ask why I should do this. So as a scientist, always the question comes, why we should study the cloud? So just I am giving you very brief. This is you please, these 5 points are not exhaustive. Exhaustive means there are so many other regions to investigate the cloud. But most important, what I could feel is the clouds are one of the vital component of the hydrological cycle. What does it mean? Hydrological cycle will break or will not exist if there are no clouds, because clouds are a carrier of the water, or you can say they are pitchers. Pitchers, they fill the water from different places, are different near to different water bodies like ocean and water reservoirs, and then they distribute around. You can say globe, or you can say if Indian like that. So the cloud fill the water from ocean, and then they distribute up to Himalayan region, or you can say in the plain region or in the desert region. So they are important part of hydrological cycle. And not only hydrological cycle, they modulate the earth radiation budget, because they does not allow the short wave radiation to reach properly or fully. And then what earth radiate, long wave radiation, they are also being trapped, and you know that. And then reflection trapping behavior depend upon the types of the cloud, and then their science comes. What are the types of the cloud? How much they will reflect, how much they will absorb, how much the short wave they will absorb, how much the long wave they will radiate. And then basically the various atmospheric processes, as I told, they provide the platform. The cumulus cloud indicate the surface heating and the atmospheric turbulence. There are so many other things, as I told, the gravity wave, etc., are imprinted in the clouds. And that's what to scientists also, they are so, you can say, the microphysics of the cloud. If you go to the micro level, then you will find that clouds are really amazing, and they are not only part of the hydrological cycle, they are lot of physics is involved in the cloud. I would like to say here, suppose if they take the cumulus cloud and its thickness is about 2 kilometers or 1.5 kilometers, sometimes they are like that, and lot of lightning is there. Lot of societal aspects are embedded in it, because in the aircraft aviation, every pilot try to avoid the lightning type of cumulus cloud. So first, if we should know there is a lightning type of cumulus cloud or possibility at that place, so then we can try to mitigate that, or try to forecast that, try to tell the ATCs like that. So that suppose 1 kilometer tall cloud is there, and you know in the troposphere the temperature gradient lapse rate is about 6 degrees Celsius per kilometer. So you see the cloud bottom or cloud base height is having X temperature, and if you go to the cloud top, in the cloud top there is a temperature X minus 6. Okay, X minus 6. So you see there is a same system, and it is one side it is a less heated or warm cloud, and if you go on the top of that cloud there is a cold cloud. So there are so many physical processes are there, and indicate physics and microphysics there in the cloud to investigate, and it basically invites us to investigate more and more and more. And then you see that, just for sake of completion, the different types of cloud, if you see, so the clouds are that type of the cloud is altitude wise. If you see the low level cloud, basically stratus, stratocumulus, and this type of there. And as I told, the cumulonimbus clouds are basically the tower type of cloud, and they are having lot of lightning, and they are very dangerous for our aircraft and aviation. Okay, and then if you go to the mid level, then basically altocumulus cloud, you can see this the bigger picture like this, and then altrocirrus cloud is like a altrostratus clouds like this, and then very important, which are modulating the radiation a lot, but sometimes you cannot see by naked eyes. These are the cirrus clouds, and cirrus clouds are high altitude cloud. They are mostly found above 8 kilometer or 7 kilometer up to 14 kilometer or so, and they are mostly made of ice crystals, and they are modulator of the radiation a lot. Sometimes even you may not see in the by the naked eyes. Even cirrostratus clouds are sometimes forming near the sun. The halo, if you see like this type of circular rings type of or thick ring you see, that is due to the cirrus clouds. So this is just low level, mid level, and high level clouds are just to sake of completion. And how cloud, as I told, they are water carrier. Near the water bodies, transpiration, evaporation, like that from trees, the transpiration, evaporation, and evaporation from ocean happens, condensation, and then with the wind. Wind is basically twin sister of the cloud, and the wind basically is a carrier. So once clouds are formed, and then the wind take it to different places, and once the conducive atmospheric condition becomes, then they precipitate. Okay, so always the cloud does not precipitate. There should be a conducive atmospheric condition, then only the precipitation takes place. Okay, so this is just and as I told, that radiation, you see that about 20% of the global radiation is based on the IPCC 2013 report. About 20% of the radiation is reflected back due to clouds. Okay, so it's a very significant amount. The 20% is a very significant amount when you see ongoing radiation, which is coming from the sun, how the clouds are modulating. And then if you see the outgoing radiation also, there also cloud play very important role. So that's what they invite scientists. You can say that the people who are interested in the dynamics, they can do it. People who are interested in the radiation, physics, they can investigate the cloud. And then chemistry also is not away, because the clouds are formed by cloud condensation nuclei, and that is aerosol. And aerosols are having physical as well as chemical properties, means the chemistry of the aerosols. So you can see the clouds are the one entity who are dynamics, radiation, and chemistry. All three you can investigate by just by, you can say, investigating the clouds. So as you now agree to me that we should investigate the clouds, scientists should look into the clouds deeply, because still there is a lot of uncertainties in the prediction of our monsoon. Indian summer monsoon, full India is investigating. Even the global scientists, global groups are looking into the proper prediction of Indian summer monsoon. And in that, if you know, the precipitation and cloud is a very major component in any climate model or any weather forecast. So the proper quantification of the clouds should be, or you can say must be done to make our forecast more accurate. They are there, but sometimes there is a problem of the accuracy, because the input data which has gone, it is mostly, earlier it was going from the NCEP and CAR or reanalysis data set. Now the satellite picture is being added. Okay, from satellite the observations are being added, but satellites also are having some limitations. So to overcome these limitations, we must have the ground-based observations, which can give the cloud-based height, cloud top height, and cloud structures, and the you can say the different layers of the cloud, which should be accounted into the model. And that is our joint effort, or my efforts are there with the in collaboration, how we could provide this type of observation set from India for you can say modelers, and for our investigations also. So we can investigate by satellites, as I told. The advantage is provide the global coverage, but limited, mostly provide the cloud top information, and limited number of passes over a given location. Radio sound, they provide the vertical profile of cloud and the cloud geometrical thickness, everything they but the temporal coverage is very much limited, because you cannot launch radio sound every 1 minute for 12 months and 10 years or something like that. It is logistically and financially, or because the budget wise is not logistic. So this, and then you see the ground-based method. And ground-based measurement, if you make the network, Then advantage very good temporal resolution and vertical resolution, but one limitation is there because you have the pointed observation. Pointed means at the place where you have your observatory or your lidar or radar, there only you have the observation. So this is the limitation of this thing. We have suites of lidar in PRL. That PRL was the first to start that you can say the middle atmospheric investigations using the powerful Rayleigh lidar over Mount Abu in 1996. And since then we are operating our lidar for stratospheric and mesospheric studies. And then recently in this decade, that you can say from 2012 onward, we have added the capability of using it in the Raman mode as well as in Me mode to investigate the clouds and the aerosols. And then we are having that all-weather lidar, because this lidar is limited by the weather condition. So all-weather lidar, when there is a cloud, rain, everything, it's a ceilometer, it's a less powerful lidar, and that we are using at different places for investigation of the clouds and boundary layer. Then we have added one more feather in the PRL's instrument list, and this is India's first multi-channel Raman lidar. And this multi-channel Raman lidar is capable of probing the atmosphere up to 20 kilometers and various parameters simultaneously in the 7 channels, in the 7 wavelengths. I will show few results. So we have the suite of lidars, and of course we have dial and other things I am not discussing here because this is not coming in the today's talk. So for the vertical structure, or you can say the cloud and boundary layer, we have several lidars in PRL, and now in collaboration we are setting up the network in India. So this is iSafe ceilometer lidar, and it gives the vertical visibility as well as different layers of the clouds and different layers of the clouds. That is the beauty. It can give up to 3 layers, and the principle is very simple. The first layer you get some signal, and if this is not a cumulus cloud and very thick and signal is not absorbed, then you get the second layer and third. So mostly when the cloud is like not very thick, then we get the first layer, second layer, and third. All 3 layers we get it by using our lidar. And now I am coming to the result. Okay, you see the beautiful results. The cloud base height. Cloud base height means what you see from the ground. From the ground, if you see towards the cloud, what you see the cloud base height. And that cloud base height, basically, that cloud base height is, you see, there are here that blue color is a CBH1, means cloud base height 1, means 1 layer. CBS2 means second layer, and CBS3 means third layer. So you see the cloud CBH1, of course, all the time 24 hours that observations are shown here. Beautiful, you can see the base height, how it is changing, and then you can see the second layer. Second layer means the CBS2 just sitting above it, that is CBS2, and then occasionally you will see the third layer. Of course, third layer may be present for longer time, but it may be it is quite possible that these are absorbed in the signal is absorbed in the first and second layer itself. So we are getting even the signature from third layer. What you see here, what an interesting thing we found, and we established it. You see that there is a beautiful cloud around at 1 kilometer or so or below that, and then around pre-noon the cloud starts jumping and dancing. Okay, and once jumping and dancing starts, and we have found a beautiful rain happens. So this type of cloud sometimes does not rain. When there is updraft and downdraft, strong updraft, downdraft, they bring the rain. And that you see the enlarged view of this, how the updraft and downdraft are taking place, and we have estimated quantitatively what is the critical updraft and downdraft velocity may give the rain. And with the 2 monsoon we established, if the updraft downdraft velocity is more than 2 meters per second, then we found there is a very high possibility of heavy rain over at least at our Ahmedabad. And these are published results you can see in the atmospheric measurement technique and MTD and in other journals. Okay, so this is just to show you one thought is this type of cloud have drizzling or no rain, and when the jumping of the cloud or you can say dancing of the cloud or updraft and downdraft in scientific language starts, then there is a possibility of heavy rain, and we have. And then, as you know, that that monsoon is like monsoon is brought by the clouds. So there is a pre-monsoon clouds, there are monsoon clouds, and there is a post-monsoon clouds. So in this region, we have further quantified over Ahmedabad and other places in India, like the pre-monsoon clouds are mostly very stable, like Gautam Buddha. They are sitting and there is no variation in their base height. Okay, and there is one layer only. There is no second layer is found, and it's like very steady layer, and they are mostly non-raining type of clouds. Okay, pre-monsoon, just I am giving you one example. And the monsoon, you see there are different layers are there. layer 1, layer 2, and layer 3, and there is a jumping and dancing, or you can say up drop and down drop. There is a heavy rain, and they are mostly low level clouds. And the post monsoon, if you see, there are mid level clouds. And in mid level clouds, sometimes there is a layering. We have found the first layer and second layer, but in the post monsoon also the third layer is very rarely observed, or it is not found. So this is a categorization: pre-monsoon, monsoon, and post-monsoon cloud. And then how we can forget the rain, which is like we aspire for the rain to everybody, whether it is farmers or it is we scientists or lovers or whatever it is there, they love the rain. Okay, so in the rain, normal rain, heavy rain, and no rain. So with the cloud itself, you can say that if there is a normal rain, if there is normal rain, there is a, like then this type of cloud structures are there, or you can cloud base is there. And the heavy rain, you see there are more layer and stratified layers are there. Even there is heavy rain, and then there is a no rain. This type of clouds are scanty clouds are there. There is no rain. One thing it has been shown here, if you see CTS from modest, okay, cloud top height. As I told that satellites are having limited passes over Ahmedabad. There is only one pass we find every day. So this is a basically cloud top height from modest. You can see that the cloud base height sitting over here and the cloud top height is here. And then we try to investigate the cloud top height, cloud bottom height from satellite, and we found reasonable agreement. But you see this movie, okay, at this scenario you cannot get from the satellite. Only one pass. Here also you see the cloud top height is around 10 kilometers, and here you see that no rain. When there is no rain, then from satellite also the cloud top height is like just sitting in between. So during the normal rain and heavy rain, basically it look like that. If there is the cloud top height which is being observed by this thing are there, they are actual, but there is a very huge difference between cloud top height and bottom. So they are able to see the cloud bottom. And that's what there are limitations. So I can say like that the ground-based observation and the satellite-based observation should be combined together to have a very, you can say, the interesting or very useful view of the clouds. And then that first time I looked like day and nighttime cloud characteristics, and we found there is a significant difference between daytime cloud and nighttime clouds. Okay, so that also you can look into in our paper, what differences we have found on the microphysics level in the daytime cloud and nighttime clouds. And then you see the satellite view, the gross view, like that, how the satellite pictures are showing the cloud in the basically cloud top height at a different altitudes over the given region. And then basically if you see from satellite like that, that modest CTH is this, and then by using the algorithms we have calculated the cloud base height from modest. So you see that exactly it is almost same like that, but what you are missing, you are having only one point, and you cannot go further, or you cannot do a deep research by this only one point. But if you have this type of observation, how the cloud base height and cloud structures are changing over every few minutes or few seconds, then you can look into a deeper physics of the clouds. And then, as I told that we have added one more feather in our kitty of Raman lidar, because here you see we were limited to the cloud base height only up to 7.5 kilo to 8 kilometers. These kilometers are very having less powers. So then only cloud base height we are getting. We are not getting structure from the ground. And we then tried with the Raman lidar, and with the Raman lidar, it's a multi-channel Raman lidar. It's a lift-and carry type of laboratory we have made in PRL, and it observed in 7 channels. And 7 channels, like why we say Raman lidar, because we have 3 Raman wavelengths and 2 elastic wavelength 355 and 532, and elastic wavelength we receive in the double polarization. So that Raman, just for few newcomers, if you pump the different wavelength, then you can get the Raman scattered signal species wise. Oxygen gives a different wavelength, nitrogen gives a different wavelength, and water vapor gives a different. So the signal which you are receiving, it depend upon only 2 things: what species you are looking into and what wavelength you are pumping. If you are pumping 532, you will get 607, and water vapor you will get a 660. Okay, but if you pump 355 in UV range, then from oxygen you will get the signal at 376, from nitrogen you will get at 388 around, and then from water vapor, which we use here in our Raman lidar, this we use 355. So then we get 388, 407, and 370. Of course, 266, the power is very less, we are not using. So you can investigate the neutral atmosphere as well as the water vapor and the structures of the cloud, and so many things. So you can see this is first view of troposphere over India. Okay, complete troposphere in the 7 channels. You can see that this is the dust, which usually happens over Ahmedabad, urban place. So you can see how the temporally the dust is growing, or you can say aerosols are growing. Along with there is a mid-level cloud, and there is a high-level clouds and cloud structures. This paper is in preparation, soon we will go pump it. You can see the beautiful structure here. If you take the satellite view, then satellite will show this one, and our oscillometer was showing this one. So now it's just like a radar view of I can get analogy like that. Ionospheric plumes in the F region are seen like this. So you can see the cloud plumes with the help of Raman radar, and then you have the downdraft of cirrus cloud, beautiful cirrus cloud. Recently, one paper in the GRL has come. You can look into that. Our colleague Sarita et al. And that is a paper on the cirrus cloud over Ahmedabad using our Raman radar. You can look into it if you are interested. Okay, so this is a complete view of the troposphere by using our radar. And then you know that if you have long series of data, then always you are, as a scientist, you are tempted after doing the case studies, or you can say that you try to look into that. What is the statistics? Statistically, how the clouds are looking over Ahmedabad. So I'm just showing here the two, you can say, years data. So 2014 and 15, if you see, we have longer one. Of course, then you see winter, summer, monsoon, and autumn. Winter, summer. So how the different year, the cloud characteristic, and in the cloud characteristic, we have seen the cloudy days, and then CBH1, CBH1. This is a red, green, and yellow color. Then CBS2, and then CBS3. So you can have a detailed view. This paper is also published that, and you can look into that. They're very detailed investigation of the different layers of the cloud and during the different season, winter, summer, monsoon, autumn, and then you see that more detailed. But that if you see the CBH height, how varies the 1, 2, and 3. So you can see the 2014-15 the CBS3, as I told that it is very difficult to get CBS3 from ground-based observation by kilometer. From Raman radar, of course, we get, but it is difficult because the power is less and it is mostly absorbed in CBH1. So winter, summer, southwest monsoon, and autumn, if you see how these heights are, the cloud-based height 1, cloud-based height 2, cloud-based height 3 are varying, and what are their height range, whatever their means. So this my student, Vaishnav et al., you can see 2018, all detailed investigations has been done. And as I told that the more things cloud-based height during 1, 2, 3 in what is the, you see, that is the, you can say, you go on the micro level of anything. What we try to look into and what we found very interesting and established over Indian region, at least at over Ahmedabad, what is the separation between the different layers. So distance between third and second layer, distance between second and first layer, and distance between second and first layer in the 2-layered case. In the 2-layered case and the 3-layer case, what is the difference between 1, 2, 3? What is the separation between them? How it is changing? Okay, so that we have investigated into these studies. And as you know, there is a as I told that everybody get fascinated by the clouds. So one of our work has been reported by a leading national daily Times of India, and this is just I am showing to you. They told that they got the title from where they got paper, I don't know. They took it everything from our research paper which were already published. Cloud9 is just 500 meter from you. So you can see on this link. So it is how it is impacting to the societies. You see that our research is directly scientific as well as a requirement of today's era. How we are contributing to the society, what we are giving to the society as we are living on the taxpayers' money. So that you see this was reported in Times of India. So you can have a look what we did. And then I am just switching the gear and reaching to the another topic, that is because time is about to be over. Then atmospheric boundary layer, as I told that cloud and boundary layer, there you can say they are very you can say twin sisters are there. The cloud boundary layer is also known as inversion layer or something like that. So the boundary layer is also important. It basically controls, it's a packing volume of the pollutants and everything what is happening, because above that there is a free troposphere. And boundary layer is a variable. Okay, sun rises, the boundary layer goes up, and then sunset it goes down. But it is not so simple. If you go to the scientific features of the boundary layer, I will show you a few observed features of the boundary layer. It is not so simple. When sun rises, boundary layer goes up. At noon time, it is peak and it is coming down. It is not so. And that's what it again warrants, or it might invites us to have a deeper and deeper investigation. So the control, transport of pollutant and climate forcing constituent, source of heat, water, and turbulence, vital for weather and climate prediction, location of aerosol cloud and pollutants, context for other measurements, human lives in the boundary layer. We live in the boundary layer, of course, that's effect on the rest of the atmosphere. It affects the basically, as I told, the clouds are there in the boundary layer. They are affecting the radiation which is going away from Earth, which is coming from the sun. So boundary layer cloud are very important for them. Please remember this boundary layer cloud, as I told twin sister, I will show you the real observation of this, how the boundary layer is affecting the cloud and clouds are affecting the boundary layer. And you can see that is just a picture from the web. You see that, and this type of observation over even Shillong we have found. I will show you the real observation like that. Capping inversion is the boundary layer is going up, and when the night comes, then boundary layer comes down, and you see that just oscillating around the globe day and night. Okay, and then there's a free troposphere, of course, and this is a boundary layer. That type of, and then you see the why boundary layer is very important, because in the boundary layer, if you see the wind are very turbulent, and the things are very, you can say, wavy and structury, and as you go above that, it's a very less turbulent, and the free troposphere is basically very cool, well, relatively you can say the quiet and calm. So and this boundary layer is very important, as I told, in the aviation sector. When you sit in the aeroplane, then pilot try to take away as soon as possible. He wants to cross the boundary layer, because in boundary layer there is a lot of turbulence, density is more, atmospheric density is more, and there are chances of the luminous cloud, lightning type of cloud. So they try to just go up as soon as possible into the free troposphere for smooth, basically you can say flight. Fine. So this is, you can say, societal aspect is again there in addition to the scientific aspect. And if you see over Ahmedabad, we have investigated the boundary layer, different facets over Ahmedabad, or Shillong, or Dehradun, and so many places. So you see that boundary layer just look like that. And then atmospheric parameters, we try to link the, which are associated wind and humidity. As I told in the previous slide, you see the wind is very important. So wind and humidity, we try to look into that. So you can see when there is a very beautiful boundary layer. Beautiful means morning it goes up, and as I told, idealistic type of, and comes down in the night. So then you will find that winds are like that, very cool and calm. They are coming down, and they are sitting like that and going up. And then humidity, not much fluctuation is seen. But if you see the other days when there is a camel hump, or you can say the distorted boundary layer is there, the structures of the boundary layer are there, then the things are just reversed. You see that if you see the wind is increasing. Earlier you see that wind was coming down, here wind is increasing, and then humidity also. So a lot of fluctuation, there was more humidity, and then humidity came down, and so many other works, other features we have looked into that. Due to lack of time, I may not be able to include here. But if you see, this is a 3D type of view. It's just recent in January 2019 that I want to show you. That's the morning, noon, and evening time, and this also the paper soon is being to it is about to be communicated within 1 week or so. So you see that the 3D picture of that, this is you can say the backscatter signal what we get. So backscatter signal, you see that this beautiful boundary layer goes up. It's a winter time, so it goes about 1.2 kilometer, and then it comes down. But the interesting thing, as I told, boundary layer is a very interesting. When it was coming down, it came down, but same time there is a residual boundary layer again comes up. Okay, so this type of feature you can investigate only by using the LiDAR type of instruments, and then you see that in the January itself there is like that collapse of the boundary layer. You see the boundary layer was beautifully going up, and then what happens, suddenly there is a collapse of the boundary layer, and there is no signature of, and there is no this type of boundary layer. So you see how it is variable from day to day using the similar instrument at same place. So the things which are more variable, more curly, more curvy, they require more and more deeper investigation by all the scientists for us to have the accurate view of that, how it is changing, or how it is affecting our life, or our weather pattern, or climate change, and the other societal aspect of this one. So this is just to show you that. And then if you see that how monthly, January to June, if you see how the boundary layer height, just is boundary layer height in meter, how it is varying. So you see there is a lot of monthly variation. It is monthly mean has been taken. So then you can see that that in May, June, like that, in May, June, you can see that this is much. But always there is a no, it is very difficult to establish like that. It will be, those peak summer comes in the May, June, but you see that in April also there is a boundary layer height is more, has been found like that. So it is a place to place, and time to time it changes, and what time peak occurs, that also is highly variable. And then just to show you that January to March, how the peak height is varying, and you see that winter to summer difference. So winter to summer difference is very significant. Okay, so this is just with have been shown to you with about 6 months or 8 months observation, and longer period observations are on. So winter summer differences, you can see very clearly how the boundary layer is varying from winter to summer. And then not only that, our LiDAR systems, what we are setting up, the Indian LiDAR Observatory, you can investigate the fog and cloud, because low level cloud and fog are always give a lot of confusion. And you know the Indo-Gangetic plain during the winter months suffers a lot, even northeast region, suffers a lot, or you can say life come to stand still due to the heavy fog. And if we predict the fog, then many things we can you can say for due to the society. If you properly predict the fog, what time the fog will be there, then aviation sector even as well as the train and transport system can be modulated accordingly to have a smooth functioning. And that is for scientists also. We can smoke, fog is there, and if you mix the smoke with this in Delhi region, then it becomes smoke. So we have investigated. One of my student has completed PhD using the LiDAR observation over Delhi, and this you can see that this is operational over Delhi Earth Station. So beautiful result we found. If you combine the satellite observation and our LiDAR observation, then you can have a in-depth investigation of fog also using that our network. And then, as I told, that Raman LiDAR gives us an additional tool or additional hand to investigate the association between the boundary layer and clouds. So you see this Raman LiDAR, this is a boundary. Just you see the blue one, just forget for a moment a red one. The boundary layer goes up, goes up, goes up, goes up, goes up, and then there is a structure, and then boundary layer comes down. That is at 355 nanometer. This is the beauty of different channels, or you can say we have different probing wavelengths. And at 532 also you see the similar features are seen. And the cloud is sitting over the boundary layer. It's just like a camel ride. As the boundary layer goes up, the cloud are sitting and cloud are updrafting, or you can say slowly going up with the boundary layer. And this type of unique events are there which can be investigated, this type of multi-channel observation, and we have done that and we are doing further. So this is the association between the boundary layer and clouds. And as I told that we have initiated and succeeded in the like that. We are already halfway through. We have started the PRL has started the Indian LiDAR network, and in the Indian LiDAR network in the northern region we have filled many places at Shillong, where we have the LiDAR observatory. At Delhi we have, Dehradun we have, Mount Abu, Ahmedabad we have, and more we are filling in. That I think next month we will be filling it at the two places, that Chandigarh and Balasore, and then of course we will be going to like that the southern region, coastal regions. These things we will be filling soon. The pandemic has slowed down our efforts, but it has not stopped like that. Things are going on. So that is our Indian LiDAR network program that PRL is basically leading in that one. And then I would like to show a few pictures of the NESEC. We this time in Tropmet, we due to pandemic we missed the opportunity to go to the scenic Shillong. But I can show you the pictures when our LiDAR was being installed. The Professor Raju, Professor Kundu, myself, and our engineer who came for installation. So this was during installation of our LiDAR at Shillong. And then the Shillong, if you see that few very preliminary things I am showing you, the updraft and downdraft, these are the screenshots. You can see that Shillong, there are more beautiful updrafts are there. You see that this type of structure, you see like I can basically emulate this one. Someone is trying to catch it, like that hands are open and someone tries something. This is a funnel type of thing, and something comes and it will be trapped in. It look like that, and then it is repeated. Always it's not like that. You see that this height is in basically fit. Okay, this is in fit, and then you see that how beautiful downdraft, like the collapse. It's a collapsing layer of the clouds. You can see the beautiful collapsing layer of the clouds. How these are happening. So this is about the cloud and boundary layer over the Shillong. And the boundary layer, if you see, you remember that what I showed the artistic view. I will just flash with you that if you see the artistic view of the boundary layer, what I showed, that artistic view we have visualized with our observations. So this artistic view, if you see this artistic view, you see the capping inversion, the boundary layer, and goes up and comes down, and this type of observation we have with us. At Shillong, we have observed our colleague, thanks to Kundu and his team, and thanks to Pil and Rajuji who supporting a lot. You can see this type of thing. You see this beautiful boundary layer, okay, coming down, and it is going up again. It is building up. It was more, of course, but we have cut it to just to show you that the boundary layer building up, coming down, and going up. Okay, and this like that you can say this is a mist type of thing has come, but it has not stopped like that. The boundary layer grown, and then it came down during evening and night, and then it again going up. So this type of investigations are going at different places over India, and we are further intensifying it with our collaborators. And I'm thankful to my collaborators. I'm thankful to the PRL directors who has helped me a lot, and always he supports for this type of initiatives and investigations for the sake of science, as well as we are trying to contribute to the society. With this, I would like to say thank you once again to you all for patient listening, And thank you again for Tropmet organizers to giving me this opportunity. Thank you very much. If there are questions and comments, I will be happy to answer. If there are any questions and comments, please.
Sir,
Hello.
sir, you will be able to, Shamkumar sir, you will be able to see the questions in the chat box. In
Okay,
your
so,
bottom right side, you can see chat, and also there are 3 dots.
Okay,
In
okay,
that,
I saw that.
in that 3 dot, if you click, sir, there is a Q&A. So subsequent questions time also, like when you are chairing the session,
Okay.
in the 3 dot, if
Okay,
you click
Q&A, okay, fine.
Q&A, and then when you click Q&A, questions will come. So I mean, under for all
That
the remaining presentation
questions
also.
I am saying that one question is from Dr. Madhu from IITM. How GPS radios not help on cloud vertical structure, especially in the eye space? Yeah, it's a very nice question, Madhu. In the eye space, it's a difficult. Okay, eye space is in the eye space only our lidar works a lot because they give the scattering. So if we have the lidar observation along with the GPS radio sounds, then it gives a very clear picture of even the you can say the eye space by the scattering. And if you have Raman lidar, then you can get even quantification of the water and ice with the polarization. Okay, so this I think answers the Madhu's question. And then Kandula Subramaniam asked that is BLH is estimated from ceilometer or lidar. Basically, ceilometer and lidar are not different. Basically, lidar, the ceilometer work on the principle of lidar. Okay, so lidar, you know, there are different names of the lidar, like Rayleigh lidar, which works on the principle of the Rayleigh scattering, and this is being used to investigate the atmospheric density and the temperature in the stratosphere, mesosphere up to an altitude of 90 kilometer. Okay, then comes the lidar, and lidar is also a elastic scattering takes place. Rayleigh lidar is also Rayleigh scattering is also elastic. Scattering is also elastic, and scattering is like that from the aerosols and the clouds. So it is being used for investigation of aerosols and clouds. And then if you take the Raman lidar, use the Raman principle. In that you can probe the different species. Okay, so like that, the ceilometer means ceiling height. It is basically was being used earlier only for ceiling height. We have added this component to investigate or take out the boundary layer from that, and by taking this basically these were being used for visibility on the airports and on the Air Force station and all these things. We have started using them in detail like that for scientific purpose and to do the cloud physics, or you can say the boundary layer physics. So the ceilometer, like it is a lidar, and ceilometer name comes is like it work on the principle of lidar. The ceilometer means ceiling height of the cloud, means ceiling means the bottom, cloud base height it gives. So that is basically, and the Raman lidar, if you add, it is more powerful, so it gives the structure also. It is even, it gives inside view of the cloud and top height of the cloud and bottom out, as I have showed you a few pictures.
Sir, I think we are running short of time probably. So maybe
sure. There are no more questions. Thank you so much, and thank you
I
for
request
listening.
you I request you to see the chat and that Q&A session, Q&A for the questions during the technical presentations also.
Okay, fine.
Okay, sir. Thank you so much.
And for contributed papers, the time is 10 minutes, I believe, or 8 minutes, 2 minutes.
Yeah, actually, we are supposed to finish it by 1:15, but I don't know. It will not possible.
Okay, it will be a little late.
If by 2 p.m. we can finish it, will be really good.
Okay, fine. Thank you. Okay, so thank you all members. And the first talk of this session is by Dr. Madhu Chandra Reddy, who is a friend of mine since long, and he is a very enthusiastic worker, scientist who is investigating the cloud and other structures using the radar. He is a radar physicist. So with this, I will invite Dr. Madhu Chandra Reddy for his presentation on radar monitored cloud vertical structures measurement over a complex terrain. Dr. Madhu, please. Dr. Madhu, please you start your presentation. Rekha madam, can you help the Madhu to start his presentation?
I think there is some problem in his end. Network problem.
Madhu sir, your network problem. Please switch off your video and share. Switch up your camera.
Yeah, Dr. Madhu, please
Can't
switch off
hear
your
you.
camera, then you will save bandwidth and you can be on voice and share your screen.
Can you share? No. Your bandwidth is so low.
Yeah, I think we will move to the next presentation.
Yes,
By the
yes,
time
Rekha ji. Dr. Madhu, we will move to the next presentation. We will slot you later in the session, okay? Because there is a bandwidth problem from your side. So I will take the third talk of this session. Is it okay, Rekha ji?
Yes, sir. Yes, sir. Please.
Okay. Okay. So the third talk is by Dr. Kandula V. Subramaniam, and he will be giving the presentation on diurnal evolution of vertical structure of precipitating clouds over the southernmost part of Western Ghat of India during summer and winter monsoon. So Dr. Subramaniam ji, please start your presentation.
Thank you, Dr. Sharma sir. Hope I am audible and my slides are visible.
Yes, you are fully properly audible and your slides are visible. Please.
Thank you. Yeah. Now I am going to talk about the diurnal evolution of the vertical structure of precipitating clouds over the southernmost part of the Western Ghats of India during summer and winter monsoons. So outline of my presentation will be, I will be giving the brief introduction and followed by data and methodology, and I will be explaining the results and concluding with the summary and discussions. So coming to the introduction, so it is well established that the Earth's topographical features plays an important role in global mean precipitations, and it was found that these observed precipitations over the orographic region is mainly governed by the interaction of the orography with the background wind flows, and also these plays a very important role in with the orographics, and there are various mechanisms through which orography can play an important role in formation of the precipitations, and it is very nicely reported by the Krishbom, which is a review paper. One can find more details of the various mechanisms about the orographic precipitation processes, and there have been a large number of studies on orographic precipitation processes and observations on the vertical structure of orographic induced precipitations. Over there, diurnal evaluations are very much limited, especially over the southernmost part of the India, that is the Western Ghats of regions, whose east and west sides are not separated significantly by the plateau regions, which provides the unique opportunity to study the precipitating cloud formation due to orographical mechanisms at diurnal scales. Thus, the objective of the current study is to investigate the diurnal evaluation of the vertical structure of precipitating clouds over the southernmost part of the Western Ghats during the summer and winter monsoon regions. So comes to the study regions. As I said earlier, this region interacts with the strong easterlies during the summer monsoon and with weak easterlies during the winter monsoon. And also it is very interesting to see that the windward side of the Western Ghats during the summer monsoons becomes the leeward during the winter monsoon, especially over the southernmost part of the Indian, as shown in the red color marks in the left panel here. And also the diurnal evaluation of the vertical structure of the precipitating systems over the Western Ghats during the winter monsoon, and then a comparison with the observations during the summer monsoon is relatively a new aspect of the present study. So this is the data I have used for the present study. TRMM data, tropical rainfall measuring precipitation radar. 17 years of the TRMM data has been used for the present study. So we have grouped these data in terms of June, July, August, September, and October, November, December period. So what we have followed the methodologies. Firstly, we have longitudinally resolved the frequency of occurrence of reflectivities, whose reflectivities are 23 dB and above. Those reflectors are considered for the present analysis and for the 2 seasons every year, and the same is averaged for the 17 years in order to get the composite picture of the diurnal vertical structure of the precipitating systems over the Western Ghats regions. And along with the TMPA preview 42 V7 surface rainfall data also has been used to climatological of the rainfall. So this figure gives the spatial distribution of rainfall over the Western Ghats regions. during summer monsoon as well as winter monsoon period. Here we can see that it is evident from this picture that during the summer monsoon period, a large amount of precipitation has been there. Western Ghats experience a large amount of the precipitation, and also over the foothills of Himalaya also we can consider a large amount of the precipitation has been received over the foothills of Himalaya. While when it comes to the winter monsoon period, apart from the Western Ghats and the eastern side of the region also, it receives a large amount of the rainfall. And we can see that the interesting point is the Western Ghats region of the southernmost part of the India, especially in the latitude belt of 17 to 11 degree north, experiences significant amount of the rainfall during the both summer monsoon as well as the winter monsoon period. So the amount of this rainfall will drastically reduces within about 100 kilometers leeward side of the orography. So the precipitation processes over the Western Ghats are well reported, but their mechanism and the time at which take place the precipitation is yet to be ascertained properly at diagonal scales. And this this plot shows the streamline at 850 hectopascal pressure level during the winter monsoon period. In contrast to the summer monsoon, during the winter monsoon, winds are very weak and there exists a cyclonic circulations which is centered around the southern Bay of Bengal and is extended up to 700 hectopascal level also. So the winds from this circulation which will interact with the orographic features over this southernmost part of the Western Ghats region and as opposite to the western side during the Indian summer monsoon region. So this plays important role and forms as a low pressure systems in the southern BOB and further contribute to the precipitations during the over this region. And this gives the longitudinal distribution of rainfall over the Western Ghats regions. This has been 70 to 11 degree north latitudinal belt has been average and the longitudinal distribution we have seen. And red and blue shows the summer monsoon as well as the winter monsoon period respectively. Each dotted circle represents the individual years, whereas the thick line shows the mean picture of the 17 years of the rainfall corresponding years. Whereas the black solid curve shows the function of the topographic height, function of a longitude. So very interestingly, we can see that during the summer monsoon period, the rainfall very peaks just nearer to the orography, and it is a very narrow and drastically decreases over the leeward sides. While during the winter monsoon period, the peak is slightly broader period, and also significant rainfall can be also observed over the leeward side of the orographic. So the winds are very gentle during the winter monsoon as compared to the monsoon, but these observations which emphasize the importance of the height of the orographic as well as the wind speed in the orographic precipitation processes. Thus, this figure provides the insights into the precipitation patterns for the Western Ghats during the summer and winter monsoon period when the wind direction changes from eastward as well as to westward side. So this shows the longitude height structure of the percentage of occurrence of reflectivity during June, July, August at the 4 local interval times 0 to 6, 6 to 12, 12 to 18, and 18 to 24 local times. This is a composite picture. If we look into the 0 to 6 hours, the maximum frequency of occurrence peak situated around 75 degrees east, and this is east belt, and also another secondary band is also observed over the around 82 degree longitude, which falls into the BOB regions. Whereas the large band precipitation, the primary band, what we observed is it is actually a residual of the midnight to early morning, where we have seen that 65 to 75 degree longitudinal belt. When it comes to 6 to 12 local time, the band is the primary band is horizontal action is relatively large and also slightly moved to the eastward side. And because of this band is responsible by for the observed rainfall over the land regions during the 6 to 12 hours. And also during this time, where the surface processes also will be in a peak during this time, and further the orographic is heated by the solar radiation. So all these processes will responsible for the observed precipitation And also the height what we observed is around 8 kilometers in terms of the frequency of occurrence. And also we can see that the secondary band what we observed during 0 to 6 hours is slightly moved further eastward into the BOB region. We can see that. And whereas when it comes to the 12 to 18 hours, so that is late afternoon to late afternoon hours, if you see that the primary band what we have seen that during the previous 2 local times, it is further expanded in terms of the larger areas, but the percentage of occurrence is relatively less compared to the other 2 things in that. But this peak remain around the same longitudinal band extended towards the valley regions, where what we have seen the secondary band, and reaches around 80 degrees in longitudinal during the 18 to 24 hours period. So this is the time where the precipitation band will be centered. Precipitation band is centered around, but this is the one where we can see that the expanded into the during the morning to 0 to 6 local time hours. So thus the diurnal evaluation of boundary layer over the land as well as the all radiation processes play a key role in the development of the vertical structure of these diurnal cycles, as reported in the earlier studies also, which is very nicely represented or clearly we can see in the current slides. This is for during June, July, August, September period, and same has been shown in for winter period. So during the 0 to 6 in winter period, like we have seen in the summer monsoon period, winter also we can see that there are 2 distinct bands longitudinally distribution of frequency of occurrence, and the center around one is at 80 to 82 degrees east as well as 86 to 89 degrees. The primary band which peaks at 80 to 80 degrees is relatively less frequency of occurrence compared to the primary one. When the occurrence of frequency precipitation during 6 to 12 has become stronger and broader compared to the morning hours, and this further, the frequency further strengthened over the secondary band during the late afternoon hours. There we can see that, and their vertical extent also further has been extended up to 12 kilometers. You can see during the winter monsoon period, especially 12 to 18 hours of the period. Both covering the this we can see the both is covering over the windward side as well as the leeward side also. We can see that
Subramaniamji, sorry to interrupt. Can you please come towards the conclusion of the talk, because 10 minutes are about to be over.
Yeah, just 1 minute, sir. Thank you. And
okay.
During 18 to 24 hours, the 2 precipitating bands are observed centered around 80 to 82 degrees and also 76 degrees longitudinal belt. So these principal band during this local time is located over the upslope as well as extended up to the downslope of the secondary crust of the Western Ghats region. So this is just 2 slides, and the schematic representation of the what we have observed schematically represented depicted here. We can see that during 0 to 6 hours we have the 2 primary bands, and whereas 6 to 12 the primary band is slightly moved towards the eastward sides. During the 12 to 18 hours it becomes enhancement in terms of the horizontal extent also, whereas 18 to 12 hours it becomes single cell, which is more causing and over the crust of the Western Ghats region. And this is a schematic depicted in winter monsoon. We can also see that here also we can see that 2 primary bands are there. As time moves, especially 12 to 18 hours, we can see that there are 3 clearly bands are responsible for the observed precipitation over this location. And this is a summary, and I am not going to read out. Finally, what we have observed is the observed contrasting features during the summer and winter monsoons are clearly depicted and investigated, and which is a relatively new aspect from the present study. And it is investigated that these results will help in understanding through which orographic process plays an important role as well in the formation of precipitating clouds.
Okay, thank you, Dr. Subramaniamji, for very nice work on the basically that on this thing in the southern Indian region. Very nicely you have brought out. I'll take the quick question. There are in chat box, there are questions. So the quick question is, one is from Dr. Somnath Datta. he said there are some studies in 2006 and 7 on the development of dynamical model for diagnosing different orographic effects like orography enhancement of rainfall, vertical flux of momentum energy, especially for mesoscale barriers. So, would you like to answer, comment anything on this?
Yes, this is thanks for the question. Yeah, as you rightly said, there have been studies 2006 to 2007 in terms of the dynamical using the model also. But what we are trying to see the relatively comparison observation of the summer monsoon as well as the winter monsoon. That is what we are trying to explore.
Okay, that next question that he says excellent study, Subbu, that Madhu is congratulating you, and he just asking quickly why cirrus clouds are missing.
Yeah, thanks, Dr. Madhu. Actually, why cirrus is missing is this is because what we have used the data is TRMM. So tropical rainfall measuring missions carries a 13.8 KU band radar, which cannot able to detect the cirrus, not the splitting clouds. So that is the reason. So if I try to use the clouds which can able to detect the cirrus, not splitting clouds, we can very nicely can see the cirrus clouds.
Okay, thank you, Subbu. Thank you, Subbuji. You answered nicely, but thank you for nice talk. Now I will take the talk by, he's ready, as in chat box written, Madhu Chandra Reddy is ready. So just Madhu, please, can you share your screen and come on that? And Madhu will be talking about the radar monitoring of cloud vertical structure measurements over a complex terrain. Please, Madhu.
Madhu sir, can you remove your headphones, sir?
Madhu, still your voice is not clear.
Please remove your headphone.
Madhu, your voice is not coming still.
So can you go for next, sir?
Madhu, we will wait for you again. Please check your mic, and I will take the another talk with due to shortage of time, and then later on we will again take up Madhu. Please, please be on that time, and we will take your talk later. Now, I will request Dr. Shashikant, who is the next presenter, and Shashikant ji will be presenting extremely heavy rainfall episode over Northeast India during Southwest Monsoon 2020, a case study. So, Dr. Shashikant ji, please share your slides and start your presentation. Yes, Shashi ji, make it full screen and start presenting.
Sir, am I audible?
Yeah, you are audible.
Okay, sir.
Please go ahead. Start.
So, my title of the talk is Study of Extremely Heavy Rainfall Episode over Northeast India during Southwest Monsoon 2020. It is a case study. So,
Shashi ji, please, I will interrupt. Can you please like that complete in the 10 minutes, please? So you have time for 1-2 questions. That I will request you sincerely.
Okay, sir. Okay. So, roadmap of the presentation is objective, and then I will go for introduction and motivation, and then data and methodology, and briefly result and discussion, and finally we'll conclude. So objective is very simple. Objective is that during Southwest Monsoon 2020, how many episodes of extremely heavy occurred over Northeast India, and what are the associated synoptic systems for these extremely heavy rainfall episodes. So this is the main objective, and introduction is also obvious that monsoon season is main rainfall season for the country, and the same is
You
also
wish you
valid
can
for Northeast India.
skip introduction. If you wish, you can skip introduction and come and give result part more.
Oh, okay. So I will limited my presentation by 5 or 7 minutes, not more than that.
Okay,
So,
thank you.
So heavy rainfall events during monsoon season are important because their impact on socio-economic infrastructure and general public also. And Northeast India is divided as per IMD into 3 meteorological subdivisions, that is Assam, Meghalaya, Arunachal Pradesh, and Nagaland, Manipur, Mizoram, Tripura. So mainly 3 subdivisions I will include. And monsoon, if we look at the observation part, that monsoon seasonal rainfall during 2020 over northeast and east India was 106%. That is, it was normal over homogeneous region east and northeast India. So this is the monthly and seasonal monsoon rainfall of 2020 for 4 homogeneous regions. But if we look at the circles over northeast and northeast India during the month of June and July, it was a positive side, but during August it was in negative of -19, and again in September it is 22 positive. And if we look at the seasonal total, it was 106 as I already mentioned. So August was the only month where it was in negative side otherwise, and all the remaining 3 months it was positive side. So it is a rainfall map, and I have circled for Northeast India. We have 3 subdivisions. If we look at division by subdivision wise departure, it was 21% over Assam and Meghalaya, and for Arunachal Pradesh it was 13, and it was -32 for Nagaland, Manipur, Mizoram, Tripura. So it was a negative side over Nagaland, Manipur, Mizoram, Tripura. Otherwise it was positive, and it was actually axis over Assam and Meghalaya. And that is the main reason, because of extremely heavy rainfall episodes were mainly over Assam and Meghalaya during the period. So this is the methodology. I have collected daily rainfall data from IMD, and including I have also mentioned daily weather reports, and GFS plots are taken from IMD GFS and from NWP division of IMD. So these are the result and discussion. I have included 6 episodes. Based on their persistence, I have included only those episodes which were recorded 2 or more days. For single day events, I have not included. So there are total 6 episodes, and the conclusion in this study are based on all the above episodes. However, in this presentation, I will consider only episode number 1 in detail. Otherwise, the conclusion based on all the observations. So about the event, if we look at during 24 and 28 June 2020, 5 days extremely heavy rainfall reports over Assam and Meghalaya, and 1 day over Arunachal Pradesh. So the major event was over Assam and Meghalaya subdivision, and this is the event. And we look at the rainfall data during the period. So during 24 June, Assam and Meghalaya was the main subdivision. Cherrapunji recorded 36. Similarly, on 25th June, Masanram 29, and over 26th June, it was again Cherrapunji and Masinram, and again 27 Arunachal one station Roing reported extremely heavy. Otherwise again Masinram 66 and Cherrapunji 55. So 27 and 28 was the highest values episodes, that is 70 centimeter and 60 centimeter over Assam and Meghalaya. The region is discussed in later slides. So we look at the synoptic discussion. So 2 major cause I found, that the convergence of strong southwesterly and southerly winds from Bay of Bengal towards the northeast India, and the shifting of eastern end of monsoon trough toward the foothills of the Himalaya. These were the 2 main regions. Because of this, moisture incursion was sufficient. So in this episode, we found that although monsoon trough eastern end of the monsoon trip during 24, 25, 26 was not in foothills of the Himalaya. However, there was a strong wind convergence from Bay of Bengal to northeast India, caused extremely heavy rainfall started from 24. However, during 27 and 28, the shifting of eastern end of the monsoon trip during 27 to 28, and also the persistence of the convergence of strong winds from Bay of Bengal to northeast India caused extremely heavy rainfall during 27 and 28. On 29, again monsoon trough shifted to Bay of Bengal, and the wind convergence weakened, so the episode was ceased. So I have already dispelled. These are some plots. This is the plots A to F for 850 HP wind. So in circled we have mentioned that there is a wind convergence, mainly southwesterly or southerly towards the region. This is the 925 plots, and so this is the consistency with the which I have told. So I have already mentioned, and the same is concluded in the next slide, that the shifting of eastern and monsoon trough to filters Himalaya and convergence of southerly and or southwesterly winds at lower troposphere from West Bengal towards northeast India.
Okay, thank you,
So these are
Sasikanji.
the
Thank you.
main conclusion.
Thank you.
I acknowledge my Director General of Meteorology, NWP, NWFC, and Hydromet Division of IMD for supporting the data. Thank you, sir.
Okay, Dr. Sasikanji, I could not see that any question in the chat box. So thank you very much for
Okay, sir.
nicely
Thank you.
giving the case studies of this one. Again, I will try with the Madhu Chandra Reddy. Madhu, are you ready? So without the
Am I audible
camera,
now?
you
Am I
can
audible this
share the
time?
slides.
Am I audible this time?
Yes, you are very much audible. Very nice.
Excellent.
You share the slide
Excellent.
and start the presentation.
Yeah, thank
Welcome,
you.
Dr. Madhu.
Thank you very much, sir. So this is thanks for a floor for me by Somkumar sirs about the basic cloud studies with the LiDARs, and Subramaniam for using a space-based trim. Here I am going to present a ground-based cloud radar monitored cloud vertical structure measurements over a complex terrain, that is a Western Ghats, for which also he has provided more details. So now I will go to straight away to my back. The cloud vertical structure, Johnson 1999 is proposed that there is a third type of a cloud. It is called a convective cloud, other than a shallow cloud, which is a warm clouds, and another one is a deep convective cloud, which can go up to the maximum 16 or 18 kilometers, where the it is the upper limit of a cloud to go vertically, and it after the tropopause height, it stratifies. So that's why annual clouds will form with this particular type. Whereas the third one is a proposed one is the cumulus congestus. So which is the main bridging gap between the warm clouds and things. So this is a particular slide. Why I'm showing is that this is called the vertical structure of the cloud. So total clouds, all type of clouds can be captured with a cloud vertical structure, a single parameter, which is analogous to similar earlier discovery of a vertical structure of a temperature, which allows us to separate spheres like a troposphere, mesosphere, and stratosphere kind of thing. So here, the same cloud can provide a low clouds, high clouds, and a mid clouds. And as far as a phase is concerned, warm cloud and mixed phase, ice phase. Besides to the convective clouds like a shallow, moderate convection, and deep convection. This is the important slide. So this is the cloud radar site at Andhra Devi, Mahabaleshwar, near to Mahabaleshwar. So this is a Western Ghats region. You can see it is about a height of 1.4 to 1.5 kilometers, where during a tropical westerly jet, so when it is coming, it impinges perpendicular to this west coast and causes a heavy rains. I can show you a second slide. This is the topography. If you see the monsoon westerly jet, when it is gliding over this hilltops, so that is the Western Ghats. The top of the hill, we will get a genuine pure non-polluted cloud systems and give the first monsoon rainfall over this summit. And exactly the near same height, we are having another hill area where we kept the radar. So that is called Mandar Devi radar site. This IITM is having two radars there. So these are the two radars. When they are putting in the vertical looking angle, that is 90 degrees. So when the pulse is transmitting from the radar, the pulse of a particular wavelength, it can able to propagate vertically and gives at every 25 or 50 meters resolution and scatter back the important information of the cloud droplet, number of cloud droplets, and its sizes. So comes as a reflectivity, that is called the equivalent radar reflectivity parameter. That is the first movement. Whereas the Doppler capability allows us to get the radial velocity. If it is in a vertical looking, there is a two-dimensional freedom, either up or down. So the radial velocity itself is the vertical velocity in the cloud. And the third one is the spectral width, which provides the turbulence information in the vertical looking. If you see the 3 MHz S-band radar, if you use the radar reflectivity and the diameter of the atmospheric targets like rain droplets or things, it is very linear. That means it works in the Rayleigh scattering, which is linear, whereas non-linear relations will enter when the 35 gigahertz is a cloud radar, which is sensitive for the clouds, but it is also a problem for a heavy moderate rains of rain droplets more than 0.2 mm sizes. It can enter into my scattering, so is further probing is a problem. So that you have to keep in mind. And here the vertical structure information for a one deep cloud layer, monsoon cloud layer, which extend up to a near to 15 kilometers. This is the first parameter is the reflectivity, and the y-axis is the height, and x-axis is the time. So 300 seconds. So we have every profile of every 1 second, 300 profiles can able to give a deep convective cloud system stops and its complete evolution within the this dotted line. What I can show is a 0 degree isotherm, and at 10.5, 10.35, this is called the minus 40 degrees centigrade. So at a 0 degree below, it is called a warm rain or a liquid rain precipitation, whereas these are the ice particles or the mixed layer things. So here you can show the blue one is the velocities, and red one is the red profile is the velocity profile. So VPR, we call it is a vertical profile of reflectivity, whereas a vertical profile of velocity, which can help to know understanding about the clouds. So there is a LDR parameter, linear depolarization ratio, which is very high when the 0 degree isotherm, where the water changes into ice phase. We can get a strong brightband information by this polarimetric parameter. And the spectral width during a rain, it will give the rain information, whereas non-rainy condition, non-precipitating condition, it can give subtly turbulence. So based on this, the objective is how a cloud vertical structure can be studied for a monsoon system is the objective. So for this, we acquired the radar data in high resolution mode, and quality control algorithms are developed to remove the all non-meteorological things like biota, insects, and all these things, and receiver noise and everything. Then we can estimate the trimodal cloud estates. That means 3 different layer clouds, and investigate the role of the cloud layer phases and their interaction. This is a simple example of a one-day observation where you can see the top portion of reflectivity height time intensity plot, and bottom is after removing the insects and the noise. So if you remove, this is the real meteorological clouds, which can infer about the clouds and cirrus clouds and bright band, whatnot. So this is, you can see more information in the 2017 AMT publication. So which can be used, this vertical structure of the cloud, by inferring the vertical profile of reflectivity, you can able to say the collision coalescence process in the warm cloud processes, whereas the Berggren, Fenderson, and Moset for mixed phase things can be used for 3 different clouds: high cloud, mid cloud, and low cloud. So this is what, if you don't use the algorithms to filter out the all non-meteorological thing, you end up in this gray things kind of thing. So you have to first use a non-meteorological removal, then you will get the better information of the cloud. So this is another example of as it is radar profile. If you take, you will get the mean like this, and if you remove that, the same picture. But if I removed all non-meteorological thing, this is the vertical structure of a cloud, whereas in this also precipitating cloud is there. If you can separate that, this is the main difference. If you separate the rain part, this is only a non-precipitating clouds, which can be studied further for the estimation of, mainly these things will be used to find out the dry and wet spells of the monsoon, because the vertical structure of the reflectivity, velocity, and spectral width can be used to differentiate the all active and break phases or wet and dry phases instantaneously on the same day. Because that's what in the other plenary talk they are telling that they are estimated with the models. So this is an example. And once you have a better reflectivity and meteorological reflectivity about the clouds, you can estimate the ice water content, and we matched with the cloud and liquid water content. And same vertical structure can be used for the evolutional study of a shallow clouds. You can see the first 14 days are the clouds are lying 0 degree isotherm, and whereas the clouds, the mid tropospheric levels are very dry during the break spell, whereas in active spell there is a mid-level moistening is helping to develop the cumulus congestus, and top-level cirrus clouds is descending and handshaking with the mid-levels, giving a strong deep convective clouds which is reaching more than 16 kilometers. So this is what is the convection is handshaking from a shallow to moderate and moderate to deep convection. This is the 60 days 2015 with a cloud radar observation. We are explaining all the rain features at the surface because the rain is before the rain the clouds. So if you understand the cloud vertical structure correctly, you can able to estimate the monsoon rainfall better. So that is the important things. Whereas during Act 2, the reflectivity contoured frequency altitude diagram, that is a histogram at each height level, histogram profile. If you take, you can see the ice clouds are the highly dominant things, whereas these ice clouds are handshaking with the mixed phase regions and causing a rain at the warm rain. So this is a beautiful estate interactions is happening during the Act 2 monsoon time, whereas the break monsoon time, this is a break monsoon time. So even though the cirrus clouds are mostly dominant, even in break relatively dominant, but the mixed phase mid-level regions are missing. So that's why we don't have a much rain during the break monsoon. This is the important important results because of the cloud radar technology. Thanks to the cloud radar technology, if you see the velocity perspective, you can see the velocities are very, very, very small, close to the zero. And when it comes to the rain, they are going to 6 to 12 or 15 meters per second, which I will show in the next slide. So, and using that, the ice water content and liquid water content for the active and break, it can show a significant difference. This all works. Sukanya Patra is presenting in another poster, whereas the rain studies also she is going to. But one important conclusion is that the monsoon monthly heavy rainfall accumulations are better explained by the ice clouds, that is cirrus clouds. When they are present during the active monsoon time, they are actively participating in the rain making process. So that is the important conclusion here. So the take home message is that the vertical structure of the cloud is capable to explore the diverse convection, all types of diversity in the convection and macrophysics and microphysical cloud systems and its through dynamics. So this is the important thing. That's why the ground-based cloud radars are very excellent tools for studying the total cloud vertical structure, which is neither possible with a LiDAR or maybe space-based, because of the high resolution temporal resolutions is required. So cloud radar is able to investigate the non-precipitating and precipitating cloud systems associated with monsoon things, and wet and dry spells are easily be classified, and even on the same day we can tell that which is a active monsoon or break monsoon by means of a mid-tropospheric moistening or dehydrating. So thanks for your kind attention, and thanks to my radar team and my director and Tropmet and Somkumar sir.
Very, very nice presentation. Very, very in-depth, nice presentation.
Thank you, sir.
And that is, you have really very nicely you can say from low level cloud up to the cirrus cloud of 12 to 14 kilometer in single shot with the help of weather radar. You have very nicely told in last 10 minutes.
Sir,
and it is very, very, very
yeah,
good.
That is the reason, sir. That is the reason. Yeah.
Yes,
that
Madhu,
is the reason I asked the questions to. That is the reason I asked about radio sound day to you and cirrus clouds to Subbu. That this is the beauty of the observation, the cloud radar,
exactly.
So which can help to help more vigorous study. Maybe I want to collaborate with you.
Yeah, sure. We are together since your PhD days. Okay, we are together.
Thank you.
So I would just to say like that, it is really the radar, that cloud and rain, the radars are there because they are in the LiDAR. There is always limitation because there are light waves. So there are advantages and disadvantages. So multi techniques always give the complete picture. And radar,
excellent,
of course,
excellent.
Very nice. I could not see. I can see the congratulations to you from this one of that's Subbu about your this thing, and then basically there is no more question. I would just like very quick question. So whether this can be done by MST radar from your alma mater place, PhD place? This thing
we are planning
done by MST radar.
Sir, we are planning a Bhopal, Central Indian test bed. We are bringing a 200 megahertz wind profiler. And
no,
we are
that I knew. But MST radar can be used for this type of cloud studies or not? That is just
no, because it is very sensitive for the precipitating part, some extent. But it is a clear air radar.
Okay,
clear
thank
air
you.
Radar.
Okay, thank you once again, Madhu, for very
Thank you,
nice
sir.
presentation. And
Excellent, sir. Thank you.
I will just move on to next session. Okay, thank you. And I learned that CA Babu, that whose next presentation is there, still is not around. The Trekhaji, whether he has he is in, Mr. CA Babu or
No,
not?
sir. No, sir.
He is
CA Babu
absent.
sir
Okay.
will not present, sir. He is absent. You
Okay,
can move
fine,
to the
fine.
next
So
presentation.
I will move to the next one, which is by Emily Spunan, that presentation. So the floor is for him, and he will be presenting a study of regional variation of electrical properties of precipitating systems and associated rainfall during the pre-monsoon and post-monsoon season. Okay. So please start your presentation. Try to complete in 10 minutes. Then some discussion or questions can be taken. Please start your presentation. Please
Hello.
start your presentation. Yes,
So can you see
we are
that?
able to hear you.
Are you able to
Yeah,
hear me?
we are seeing the slide and able to hear you.
So shall I? Okay. Today, the title of my presentation is a study of regional variation of electrical properties of precipitating systems and associated rainfall during the pre-monsoon and monsoon seasons. The outline for today's presentation is I will give a brief introduction, then spell out the objective, then detect the study region, briefly the data and methods along with the instruments, then we'll discuss the result and conclude.
I will suggest you, please, if you focus more on the results, that introduction, if you can minimize or you can skip, that will be better, because this community knows about that, and you can come to the result and you can have the more discussion about the results. Please.
Okay. So we know that like precipitation plays an important component of cloud electrification process, and also we know that the northeastern region in the eastern region of India plays different orographic formations, and for that matter we need to study this. The objective of my study is to investigate the regional variation of the electrical properties of precipitating systems and associated rainfall at Kohima and Rambohat. The study region is shown in the given figure. Kohima lies at the Patkai range at an altitude of 1,500 meters above the sea level, while Rambohat is near to the Chotan Nagpur plateau, around 40 meters above the sea level. The collector from the tipping bucket. Hello.
Please continue.
Yeah. Data were collected. Data were collected from the tipping bucket rain gauge and the EFM 100 at Kohima and Rambohat. The tipping bucket has the resolutions shown in the given figure as well as the electric field mean. And the number of events during the monsoon and pre-monsoons were calculated for Kohima and Rambohat. Now, when the value of the electric field is greater than 500 volts per meter, we categorize those rain events as electrified rain events, and otherwise it is designated as a non-electrified rain event. The instrument used for this study is shown in this given slide. The table one shows the rainfall events at Kohima and Rambohat. We find that Kohima experiences more total number of events compared to Rambohat. Now, if you consider the electrified and the non-electrified rain events at Kohima and Rambohat for the pre-monsoon, we find that the majority of the rain events are electrified rain events for pre-monsoon, as shown in table number 2. Now, if you look at table number 3, also find that monsoon also, we find that the electrified rain events are more compared to the non-electrified rain for both the sections. Now, this table number 4 shows the occurrence of electrified and non-electrified rain events at Kohima and Rambuha. And the figure 1 shows the pie chart for the electrified and non-electrified rain events for both monsoon and pre-monsoon taken together separately for Kohima and Rambuha. And we find that the electrified rain events contribute more for both the stations. Now, if you look at the average maximum rainfall intensity from table 5, we find that Rambuhat experiences more intense rainfall for electrified rain events, while Kohima experiences more intense rainfall for non-electrified rain events. Now, if you look at the box plot just for the electrified rain events, we find that the rain are more intense. The rain are more intense in Rambuhat for both monsoon and pre-monsoon when we compare for the two stations. Now, if you look at table 6, we find that the average number of lightning per electrified event is more for Rambuhat. And even the lightning per event are shown in the plot box, we find that the lightning per event is more for Rambuhat. Now, this is the box plot for the duration of the electrified rain events over Kohima and Rambuhat. We find that the average durations for electrified rain is more for Rambuhat for both monsoon and pre-monsoon as shown by the plot box. Now, if you look at the diurnal variation for the percentage occurrence of electrified rain events during the pre-monsoon, we find that the peak value of the percentage occurrence of electrified rain events is at around 12 hours for Kohima, while it is around 21 hours for Rambuhat with a phase difference of around 9 hours. But for monsoon, if you look at the diurnal variation for monsoon, we find that there is only a phase lag of around 3 hours. That is the peak value of percentage occurrence of electrified rain events for Rambuhat is shifted from 21 to 15 hours. Now the conclusion. The results suggest that there are more number of electrified rain events for both the stations for both monsoon and pre-monsoon. That is the total number of electrified events is more during the monsoon season compared to the pre-monsoon for both the stations. And it is also further observed that even though the occurrence of electrified rain event is more during the monsoon season compared to the pre-monsoon, we find that the rain events are actually stronger during the pre-monsoon compared to the monsoon. It is also found that over each season, by virtue of higher flash count, the electrified rain events are stronger over Rambuhat compared to Kohima, which suggests a strong mixed phase process in the precipitating systems over Rambuhat. It is also observed that non-electrified rain events have relatively less rain intensity compared to the electrified rain. Now, as from the given figure of the diurnal variation, we find that the peak value of the percentage occurrence of electrified rain at Kohima station is the same. That is 12 hours during monsoon and pre-monsoon, while it is not the case for Rambuhat. That is, we find that there's a phase difference of around 3 hours during the monsoon and a phase difference of around 9 hours during the pre-monsoon.
Please stop that? People can read these conclusions.
So overall, we find that predominantly higher rain intensity events are there. Thank you.
Okay, thank you very much, Amliji. That was a very nice presentation over the Northeast region, how the things are changing. And I could not see any question in the chat box. So now I will be moving to the next presenter, there are basically paper number 7 and 8. There two papers are there, and both are by Dr. Somnath Dattaji. So he has written that he will present both together. Okay. So now I will request Dr. Somnath Dattaji to come and present his papers. The one is a mathematical model for parameterizing the precipitation enhancement and momentum flux associated with air flow over mountainous region. And the second one is again very interesting, the orographic effect on the heavy to very heavy rainfall over Kerala in 2018. So the floor is to Dr. Somnath Dattaji, and please start your presentation and share the screen. Dr. Datta.
Thank you. So as some speaker has already mentioned very rightly that the effect of different effects of orographic barrier over the region. So that's why attempt was made that to diagnose the different dynamical effects of an orographic barrier in an area in enhancing the rainfall, orographic rainfall, or in the vertical flux of wave momentum, wave energy. So one mathematical model was developed, and that mathematical model has been applied over Western Ghats, Khasi Jaintia Hills, Assam Burma Hills, and in the mountain corner in the Northeast India also. So this objective is only to develop the mathematical model and to show that this mathematical model can be used as can be appended to a forecasting model as a subroutine. So our methodology is a bit mathematical. We have used the 7 governing equations under some simplified conditions, which is given here: steady state, dry, non-rotational, laminar, bushniks, vertically unbounded. Dry is not there, it is moist only. And simplified governing equations are linearized using perturbation technique. And this is allowed because the height of the mountain is of the order of 1 kilometer. And also we assume that basic flow consists of both the component, that is along the that is across the mountain, along the mountain, along the major ridge,
Please
across the major ridge.
please. Slideshow, sir.
Slideshows are not there.
No, it is in the. Can you please put in the slide slow mode?
Okay,
full
slide.
screen. Full size screen.
Now it is okay.
It is okay now, please.
Okay. So then after some simplification, we got a second order differential equation. This equation popularly known as, many names there. Somebody tells it is vertical structure equation. Somebody said it is Taylor-Goldstein equation. Both are correct. And this is the equation. Now the next problem is that this equation, one thing I have forgotten to tell you, that simplified equation have been performed your double Fourier transformation. Okay, and this is the equation for the double Fourier transform of the perturbation vertical velocity, and this equation is integrated numerically from top using the boundary condition imposed at the ground and at the top model, top of the model. Lower boundary condition, airflow is supposed to follow the terrain, that is called terrain following boundary condition, and upper boundary condition is vertical velocity decay exponential, that is radiation boundary condition. And using the vertical velocity and along with the conservation of moisture and mass, we have found out the rainfall intensity, which is solely due to orographic. And also after finding out the perturbation wind components and perturbation pressure component, we have been able to find out, compute the momentum, vertical flux of momentum and energy. And it has been applied at many places, just like Western Ghats, Khasi Jaintia Hills, etc., Assam Burma Hills. And some results I will show. This for the Western Ghat, the Mumbai-Pune section has been taken at the exact plane, and the orography has been approximated analytically like this, and it looks like this. But these are the parameter. Height is 0.77 kilometer. This has been taken from Sarkar 65, 66, and Datta 2003. 2006, 2007, then A and B, these are basically half width in 2 directions, And Khasi Jaintia Hill profile is same, only thing is values are different. These are also taken from day 1973, these parameters. And Assam Burma Hill, this has been taken from Das, I think it is 2016, because this is the profile of the Assam Burma Hills. And we know that in the northeast India, two mountain ridge, one is Assam Burma Hills and the Khasi Jaintia Hills, they cut in a almost perpendicularly, and they form a corner. Now, whether it has some if orographic effect or not, that has been also started. This is the corner mountain profile, and these are some results. This is nothing but your contour of the rainfall intensity over a region 300 kilometer by 300 kilometer with center at the top of the mountain peak for different mountain. And this is x-axis, this is y-axis. X-axis means the direction of the major minor ridge, and y-axis is the direction of the major ridge. And when both the components we are taking, then the contour pattern looks like this. And but if we take only the U component, that means which is perpendicular to the major ridge of the barrier, then we are getting a symmetrical pattern. Similar we are getting for Khasi Jaintia Hills also. Okay. And these are the vertical flux also. Vertical flux also we have been able to compute. And now this vertical flux is not uniform for all cases, for all mountains. It depends on the basic mean flow itself. So this is an example I have shown you. This is also another one example. The vertical flux of energy and horizontal momentum. This is another one example. This is energy flux. This is some other example for mountain corner. We can see somewhere that is convergence, somewhere divergence. Both are there. All depends on the flow. And not only that, this is the schematic diagram where I have shown that how this model can be appended as a subroutine in a forecasting model. You see, this is the large scale or forecasting model. Its output goes as an input in this present model, and this present model immediately it diagnoses the computer rainfall intensity, and it returns to the main. Similarly for the flux also. And these are some broad conclusion that, as we have seen, that we obtain one primary maxima and three secondary maxima. Primary maxima is located just behind the peak. Secondary maxima, two secondary maxima are located on the lee side beyond the two ends of the barrier. However, if you take the V component, that we another two components of the wind, then symmetry of this location is lost. And vertical flux, this model is able to compute the vertical flux associated with the internal gravity wave due to airflow across mountains. And this model may be appended as a subroutine. And thank you. This is my first paper.
Okay, thank you, Dr. Somnathji. I could not see any question in the chat box for this paper. So can you please start your second presentation, which is orographic effect on the heavy to very heavy rainfall over Kerala in 2018.
Exactly.
Please start your second paper.
Yes,
Okay.
start. Is it visible? The slide is visible?
Full screen, please.
Slide is visible, no? Okay, fine.
Yes, slide is visible. Make full screen. Yeah.
So we all have witnessed very historical flood over Kerala, and we know that over Kerala also some orography is there. Then we made an attempt whether orography had played any role. That means whatever observed rain we have seen, whether there is any orographic component. For that actually, that is the thing that we all know, that there is a local orography in Kerala centered at Anamudi. This is the latitude, longitude, and height is quite good, 2.7 kilometer, half width 27 kilometer in the west-east direction and 18 kilometer in the south-north direction. And in August 18, we all know Kerala received heavy to very heavy rainfall. Most of such heavy to very heavy rainfall events took place on the windward side of the above local orographic area. This we have seen, and we have made an attempt to understand whether there is any dynamical role played by the local orographic or not. So the approach is very simple, that whatever model I mentioned, that 2007 one model has been developed by Datta 2007. It is a three-dimensional linear dynamical model for orographic rainfall. That model we have used. This model has two parts. One is a dynamical, another one thermodynamical part. Dynamical part computes the perturbation vertical velocity, and thermodynamical part using that perturbation vertical velocity and the mean flow density and specific humidity, it computes the rainfall intensity, that is orographic rainfall intensity. And dynamical part, as I mentioned in my first paper, takes some simplified assumptions, and orography in that region has been approximated analytically as a three-dimensional elliptical barrier centered at Anamudi with height this much and half width 27 kilometers in the west-east direction, like this. And simplified governing equation, this I in my first paper also I have shown you. This is the simplified governing equation. This is the orographic, okay. And thermodynamical part, as I now in the thermodynamical part, moisture content equation has been utilized, and an atmospheric column over any grid point consists of discrete columns like this. At each such discrete column, vertical moisture flux convergence has been computed using computed perturbation vertical velocity, density, and specific humidity. Amount of rainfall has been assumed to be the local convergence of such vertical moisture fluxes, which is a serious limitation of this present study, taking place at each such discrete layer. However, all the moisture condensed into the water vapor over a grid point not necessarily fall as rain due to the wind drifting effect of the mean wind. Accordingly, drifting effect we have taken care in the model. And we have studied all many cases, but here I will show only 3 cases. In 2 cases, in 2 cases the model has been able to estimate, able to produce the heavy rainfall of 30 millimeter per hour. 30 millimeter per hour. This blue color. These are the different stations, and for that day this is the wind profile, and you can see these are the some station I have written here where observed rainfall and estimated rainfall. You can see in some stations it has been overestimated, in some station it is underestimated also. Now in the next case you can see it has failed to produce the heavy rainfall intensity, but on 16th it has been again able to produce the heavy rainfall. Okay, so every day and you can see the wind profile and temperature profile of different cases also. So definitely you can understand that production of heavy rainfall by the model depends crucially on the vertical profile of the mean wind. This is the comparison of observed and computed rainfall intensity of 16 August. You can see as I have told you that in some cases it is overestimating, some cases it is underestimating, and this is my brief conclusion. Model could simulate orography induced heavy rainfall in many cases, although it could not show in many cases. It depends on the vertical profile of the mean horizontal wind and other processes also. There is also mismatch in the location of computed heavy rainfall intensity and observed heavy rainfall intensity. And computed rainfall intensity overestimated the observed rainfall intensity for the stations to the southwest and underestimated the observed rainfall intensity for the stations to the northwest of the peak of the model orography. And as I told, that it is suggested that this model may be thought of to append as a subroutine in a general forecasting model. And thank you.
Thank you very much, Dr. Somnath Dattaji, for very nicely presenting both the papers and keeping that in the things on time. Very nice. And I could not see any question in the chat box. If anyone has a very quick question, so can ask very quick question on either of the paper if anybody wishes to ask. Otherwise, we'll move to the next paper.
Okay, thank you to the organizer
thank you,
for
Daktaji.
arranging
Thank
such
you.
an excellent arrangement. Thank you.
Okay, thank you so much. Okay, so next talk is by S. Mondal, and he will be talking about presenting his work on seasonal precipitation projections using Codex South Asia experiment in northeastern climatic region of India in the eastern Himalaya. Focus will be on eastern Himalaya. So, Dr. Mandalji,
Sir,
please
yes,
start
sir.
your presentation. Yes.
Sir, am I audible?
Yes, you are audible. Please start your presentation.
Okay, thank you. Seasonal precipitation projections using Codex experiment in northeastern climatic region of India, eastern Himalaya. The northeastern climatic region of India is considered as the homogeneous climatic region, one of the homogeneous climatic region of India. However, the elevation range from 2 millimeter at 2 meter at Sagar Island to 7,800 meter at Sikkim Himalaya. But rainfall, annual rainfall varies from 1400 millimeter to 11,000, more than 11,000 millimeter at Cherrapunji. So the objectives of the paper, main objective of the paper is to investigate how much the seasonal precipitation pattern is homogeneous
Your
across
voice is
the.
getting interrupted.
Yes, sir.
Please continue.
Across the predefined homogeneous climatic region to generate region-specific information on present and future seasonal precipitation, to understand the dependency of orographic dependency of rainfall.
Your voice is not coming.
Yes, sir. Database. Model data, high resolution data 50 kilometer by 50 kilometer simulated daily precipitation data obtained from the Center of Climate Research, IITM, the Codex South Asia domain. 3 sets of RCP data are available, only 2 RCM, that is RCA4 and REMO 2009, and those 2 regional model is used in the study. And method, seasons has been categorized as winter, pre-monsoon, monsoon, and post-monsoon. Present scenario has been considered for 1970 to 2005. Projected scenario, immediate future scenario considered for 2020 to 2049. The bias correction done with the quantile mapping techniques, and the comparative reliability of the models has been tested with the Taylor diagram. Trend of precipitation for monsoon precipitation, the observed appropriate data set, the RCA4 model and remove the model, both models are agreed in that the observed rainfall, monsoon rainfall is decreased in the northeastern climatic region of India. But for winter precipitation, the appropriate data set and the RCA4 model agreed that the winter precipitation has been increased. Projected data set for low for 2.6 scenario, RCA4 model and REMO model said that both the models agreed on projection of 40% deficit in winter precipitation across across sub-Himalayan West Bengal, Tripura, Mizoram, and part of Manipur. The RCP 8.5 deficit may be remain at 36 to 40%. In northeastern climatic region as a whole, winter precipitation will increase by 3 to 70% compared to the observed period 1970 to 2005. Pre-monsoon precipitation In low to medium emission scenario, that is 2.6 or 4.5 scenario, both models projected a deficit by 16 to 20% in pre-monsoon precipitation, except in hilly tracts, while a negligible increase under RCP 8.5 over the present mean. The monsoon precipitation, the RCF4 projected a surplus by 14 to 24% across the three RCP scenario over the region, with higher magnitude of increase over central plain of Brahmaputra Valley in Assam. The RCA4 found to be more sensitive in simulating pre-monsoon and monsoon precipitation. And concluding remarks, the precipitation regime of the northeastern climatic region exhibits complex and uncertain response to global climate change, since models showed significant spatial temporal variations in magnitude and signs across RCPs and seasons. The RCP4 is more sensitive to pre-monsoon and monsoon precipitation simulations, while REMO is more reliable for post-monsoon and winter precipitation. Southeast monsoon precipitation decreased during 1970 to 2005, that is in observed period. However, best fitted RC4 model simulation projected a significant increase across RCPs during the immediate future, that is 2020 to 2049. Even in the middle of 21st century, that is up to 2050, surplus in southeast monsoon may be reached up to 14 to 24%, mostly in the central plain of Brahmaputra Valley in Assam. Winter precipitation in northeastern climatic region will increase by 3 to 17% in immediate future, that is up to the middle of 2050 future, and will increase further to 51 to 145% in distant future, that is at the end of 21st century, with a likely shift in southeast monsoon pattern over the region. Thank you.
Okay, thank you, Mandalji. Very nice study based on the model and for future projections. So I could not see any question in the chat box. I have a very small question to you.
Yes, sir.
That for running these models, for boundary conditions and for data input, which source the data you use for running this model?
The code is South Asia domain, sir.
Okay.
IATM.
Okay. Thank you. Okay, thank you. So now we will move.
Thank you, sir.
We will move to the next talk. So it is the last but not least presentation in our session today, and this will be presented by Dr. Amit Kumar, and he will be presenting his work on rain drop size distribution feature of pre-monsoon and monsoon season over the Western Ghat. So, Dr. Amit ji, please start your presentation.
Hello.
Yes, Dr. Amit.
No, I am not Dr. I am JRF student. Okay.
Okay. You can make your slide in full slide mode, full screen mode, and you can start your presentation, please.
Okay. Good afternoon. Today my topic is rain drop size distribution feature over a feature of pre-monsoon and monsoon season over Western Ghat. And I actually directly come to the I use data from 2015 to 2018 distributed data over Mahabaleshwar for this analysis, and directly come to my result. First of all, I plotted mean drop size distribution variation with droplet diameter, and here we find in monsoon season a smaller droplet concentration is very high, but for a higher bigger droplet concentration is higher in monsoon season. But if we see the critical parameter for like mass weighted mean diameter and rain rate in monsoon season, its value is very less compared to the pre-monsoon season, but normalized intercept parameter, its value is very high. It is mainly due to the higher contribution of smaller droplet size. So to further find the other rain integral parameter, we plotted the PDF of the other different rain integral parameter. I like logarithmic of rain rate, liquid water content, mass vitamin matter, and normal industrial parameter. Here we find that for the logarithmic rate, above the when value is greater than net is 0.03, its PDF value is more for monsoon season and then the pre-monsoon season, which clearly indicate that the dominance of light with a small raindrops size with narrow rain spectra. Similar trend is in the liquid water content also. But when we see the mean diameter, mass weighted mean diameter, in monsoon season its peak value is around the 1 millimeter, but in pre-monsoon season its peak value around the 1.5 millimeter. And also in pre-monsoon season, rain spectra width is higher compared to the monsoon season. And through the plot this figure PDF of mass weighted mean diameter, we find in monsoon season the higher value of around the lower higher value for the lower mass weighted is normalized incident parameter in monsoon season, but in pre-monsoon season this value increase and move towards the higher value of mass weighted mean matter. Then to further illustrate the raindrop size in pre-monsoon and monsoon season, we classify the raindrop size in six different rain rate based on the Tokyo and SOT 1996 criteria. And in figure 1 we can see that hello.
We are hearing you, please. Your voice is clear.
Okay.
Please go ahead.
Okay. And in the first figure for rain rate, we have seen that for the rain rate between 0.1 to 1 millimeter per hour for plot in first average, which display the spectra of average rain in monsoon and pre-monsoon season. Here, when rain rate diameter, droplet diameter is less than 1 millimeter, we find that a smaller droplet is more prominent. And also, with the increase in droplet diameter, pre-monsoon concentration in pre-monsoon season increasing and monsoon season decreasing. Similar trend is seen in B and C for rain rate in 1 to 2 millimeter per hour, also 2 to 5 millimeter. But also mid-size droplet number concentration also gradually increasing. One thing also, the breadth of rain droplet distribution is also increasing with the increase in rain droplet, and also the tail of the rain droplet distribution is gradually increasing towards a larger droplet with the increase in rain drop size distribution, rain rate. And similar trend is seen for different rain rate. I like between 5 to 10 and also 10 to 20 rain rate per millimeter per hour, or also for higher rain rate greater than 20 millimeter. Then to find the clear difference between the raindrop size clusters in monsoon period, we plotted the percentage parameter of raindrop size distribution in monsoon and pre-monsoon season. And here the percentage parameter is defined as a ratio of mean droplet contribution in a difference in a season for diameter D and rain rate to the sum of the mean droplet in both seasons. Here in monsoon season, a smaller droplet less than 1 millimeter is more prominent, while in pre-monsoon season, mid-size or bigger droplet contribution is higher compared to the monsoon season. Then we plotted the mass weighted mean diameter for different class, mass weighted mean diameter and the normalized incident parameter different class rate in box Vista plot. In mass weighted mean diameter, we find that in monsoon season and pre-monsoon in both seasons, we find that mass weighted mean gradually increasing with the increase in the rain rate, and also the in pre-monsoon season. In pre-monsoon season, mass weighted mean value is higher compared to the monsoon season for each season class rate. And from the figure second of the mass normalized incident parameter, we find that in pre-monsoon season its value is less than the for each class is less than the monsoon season for each class rate. From these two figures, we can conclude that in monsoon season, must be the mass weighted mean value is lower and normalized parameter is higher for monsoon season. Then we try to find what are the features for the raindrop sustaining convective aesthetic from precipitation over Mahabaleshwar, and for this we utilized criteria of convective estrogen progesterone coefficient based on the Bringe 2003. And here we first of all we plotted the normalized average number concentration of rain droplet for monsoon season and pre-monsoon season for convective static form. Here we find in convective rainfall for both season, droplets convolution is higher compared to the static form rainfall, and also in and also from the plot of mass weighted mean matter and log method for pre-monsoon mass, we will find that in monsoon season we find higher DM value and lower NM value normalized parameter, but in pre-monsoon season reverse is found, and also in convective rain precipitation in both season we find that currently both season and mass weighted mean diameter value is higher, but mass weighted normalized mean weighted higher and normalized also is higher value. And based on this plot, conclude to that a smaller mean droplet concentration is dominant in monsoon season, while in pre-monsoon mid-size and bigger droplet are more than concentration higher compared to the monsoon season. Also, for different class rate, based on different, we can classify the rain droplet in a smaller, mid, and bigger droplet size. And convective statement clearly demonstrate the rain parameter, different rain parameter for each season, and I like normalize and number concentration rain droplet concentration and size also. Thank you.
Thank you, Dr. Amit Kumarji, for very
Sir,
nice
I am not
presentation.
doctor, I am a student.
Okay, that in scientific line you will become tomorrow. I think soon you will become a doctor. That is my wishes.
Thank you, sir.
Okay,
Okay,
so there is a question from Dr. Madhu about you he want to know during monsoon if there exists a moderate to high convective rain event, what could be DM and other parameters vary or not?
DM actually I have used 4-year data, and we find that a DM value is in convective rainfall is higher value compared to static form, and we also only classify all rainfall value in convective and static form, not in higher and mid convective rainfall. So at present I can't say anything.
Okay. Thank you very much for a very nice presentation on the rain drop size distribution in the pre-monsoon and monsoon season over the Western Ghat. And I am thankful to all the presenters of the in this session. They have presented really very nice results, and you can say very topical and recent findings about the clouds, the cloud structures, and then modeling studies for forecast and rain drop size distribution, regional precipitation by using codex, orographic effect, and so many variety of the papers are presented in this session. So I am thankful to all the presenters and for keeping the time, and to the listeners and the presenters who has actively participated in the discussions through chat and asked the questions. So once again, I am thankful to all the presenters and the organizers for giving me this opportunity to organize this session and for a lead talk. And I wish you all the best and good luck to you all for your future research activities in a very important field of research. And please stay very healthy and happy in this pandemic situation. Keep it up. The time will run away. And again, we will be, I think, start having soon the physical interactions during the Tropmet and other workshops and the scientific symposium. So with this, I will hand over to Dr. Rekha ji for if any announcement or what is for further proceeding of the Tropmet.
Yeah, thank you. Thank you so much, sir. Thank you because you have chaired the whole session all alone without the support of co-chair, and we are really thankful to you for that. And thank you for the lead talk that you have discussed many aspects of cloud detection, why it is so important, then different facilities available in PRL, and how your working with ANISEC, our collaborations. So all the discussions, thank you for that, sir. And I'm also thankful to all the participants. Because of them only this session is a successful one, and it's a varied field. In this presentation, full session, we have varied presentation on orographic cloud and precipitations, and it's really a fruitful session, sir. So thank you all. Now our next session will start from 2:15. Okay? Yeah. Okay, we will meet again at 2:15. All the attendees. Thank you.
Okay, thank you, Rekha ji, and thank you to Kundu ji for giving me opportunity. And it went on time. It gave it up to 2 o'clock, so we could finish it 2 o'clock.
Yes.
And I think one talk by Dr. C.A. Babu was absent, so we could make it on time. What time was
sir,
allotted.
on time.
And thank you very much for your kind support and all the help from that organizers angle. And that's what it could have been very smooth. We could organize this very smoothly this session. Thank you.
Thank you, sir. You are most welcome, sir. Thank you.
Okay.
Hello, yeah.
Good. मित्र साहब थोड़ा पोअर कनेक्शन है, पोअर कनेक्शन.
मित्रा, हेलो.
अरे मित्रा साहब, गुड आफ्टरनून.
गुड आफ्टरनून. साउंड ठीक है?
यस.
अच्छा है, बहुत अच्छा है.
ठीक आ रहा है?
ठीक आ रहा है.
अच्छा, वो पीपीटी भी शेयर करके टेस्ट कर लूं क्या, या बाद में?
हो जाएगा, आपको शेयर लिंक एक्टिवेट हो जाएगा. अगर अभी एक्टिवेट नहीं है तो दे विल एक्टिवेट इट, देन यू कैन शेयर इट.
ओके, ठीक है
सर. शेयर कीजिए सर.
जोशी साहब.
यस.
आशीष सर.
सर वो ईमेल मिल गया, भेजा था मैंने.
मिल गया, बिल्कुल मिल गया. थैंक यू वेरी मच.
ठीक है सर.
पटनायक, इसको मित्रा को जाना है 245 में.
सर नमस्कार. हाँ, क्या बोले सर?
मित्रा को 245 पे इंग्लैंड जाना है.
अच्छा.
वर्चुअली
नहीं, एक्चुअली ना 3 बजे एक मीटिंग है. इट्स ए इम्पोर्टेंट मीटिंग. सो 2:45 में मुझे फ्री कर दीजिए. मैं लास्ट स्लाइड में ना लिखा हूँ पर क्वेश्चन वगैरह सेंड ईमेल टू मी. तो अगर कोई इम्पोर्टेंट क्वेश्चन होगा तो कर लूंगा.
लेकिन मित्र साहब, ओके, एनीवे आप तो लीड टॉक के बाद जा सकते हैं. चेयर को चेयर कोई अलग है ना? चेयर को चेयर तो अलग है. जोशी साहब चेयर है, को चेयर सर कौन है?
हाँ, या
सर ये भंडारी सर का था. Yeah, it was for Satyendra Bhandari sir, but then he due to some personal reason is unable to join.
Oh.
So I am there sir to support Joshi sir.
Okay. No issue. Fine.
लेकिन
अच्छा,
क्वेश्चन आंसर छोड़ेंगे नहीं, मित्रा आंसर करके जाएगा.
नहीं, एक्चुअली मैं 2:15 अगर शुरू करेंगे तो 2:35 खत्म हो जाएगा. 20 मिनट्स मैक्सिमम, 15 से 20
लेकिन
मिनट.
ये कोई जरूरी नहीं है.
टाइम तो है.
नहीं, वर्चुअल मीटिंग है, कब कहाँ बीच में कहाँ रुकेगा, यू नेवर नो.
नहीं सर ठीक चल रहा है. ऐसे कुछ मेजर नहीं है. मेजर कुछ प्रॉब्लम नहीं हुआ है.
अरे गूगल में प्रॉब्लम हो गया था कल, तो की वजह से पूरा ही
प्रॉब्लम नहीं होगा. बढ़िया चल रहा है.
नहीं सर, काल का किसमें प्रॉब्लम था सर? काल का किसमें प्रॉब्लम था?
गूगल का पूरा लॉकडाउन हो गया.
नहीं, गूगल में हमारा प्रोग्राम है नहीं. गूगल में जनरल बॉडी के लिए प्रॉब्लम था.
हाँ, वही जनरल बॉडी में.
आज इसलिए फिक्स किया है फिर 5:30 के बाद.
सर यहाँ पे हम लोग गूगल यूज नहीं कर रहा है. इट इज यूजिंग वेबएक्स.
सो हमारा सारा प्रोसीडिंग्स, वीडियो, एवरीथिंग इज अवेलेबल. वो कहीं नहीं गया है.
ओके. लेकिन आज का जीबी का मीटिंग का पटना भेज दिया तुमने लिंक?
हाँ, भेज दिया सर, सबको भेज दिया है.
सर लिंक नहीं आया. आई थिंक सर.
आई गॉट जस्ट नाउ.
अच्छा, अभी मैंने देखा.
मिल गया.
ओके.
अच्छा,
जस्ट नाउ.
कुंडू जी, आप उसको भी फ्लैश कर दो कहीं, या देखेंगे.
आई वाज वेटिंग फॉर द लिंक. लिंक हैज
अच्छा,
कम.
आपको नहीं मिला?
मुझे थोड़ी देर पहले तो नहीं आया था.
हाँ, अभी कुछ भेजा है शायद. उन्होंने बना तो लिया था सुबह, लेकिन अभी भेजा है.
ठीक है, ये अपना पहले कर लेते हैं, सेशन कर लेते हैं, उसका मिल जाएगा.
और हमने भी हमने लिख दिया कि 5:30 से 8 बजे तक उसमें लिखा है.
हाँ,
वो लिंक भी आ गया सर. लिंक भी आ गया है अभी.
आशीष सर, प्लीज शेयर योर स्लाइड. चेक कर लीजिए सर.
Try to start at 2:15 sharp.
Yes sir, we will start at 2:15 sharp.
Speaker is there, chairman is there, and audience is virtual. No, we don't know. So there is no problem.
सर इंटरेस्टिंग बात ये है कि वी आर मेंटेनिंग टाइम बिकॉज ऑफ वर्चुअल. बिकॉज जिन का लेक्चर अभी खत्म हुआ, वो लोग खाया. जिन का बाकी है, वो लोग ऑलरेडी लॉन्च कर चुके हैं. सो
there is no wastage of time because of lunch.
अच्छा, देखिए शेयर हो रहा है.
Yes,
आगे इट्स देयर.
ओके, तो इसको मैं बाद में फुल स्क्रीन कर दूंगा. आई विल मेक इट फुल स्क्रीन.
तुमने शेयर किया, ऑर्गेनाइजर्स ने किया?
नहीं, मैंने शेयर किया.
ओके. नो, इट्स कमिंग नाइसली.
सर Ctrl+L कर दीजिए, फुल स्क्रीन हो जाएगा.
वो जब शुरू होगा ना 2:15, जब देन एट दैट टाइम आई विल डू.
अभी तुम्हारा ये NCMRWF का लोगो चेंज हुआ है या मैं भूल गया हूँ?
नहीं, सेम है. एक्चुअली ये बहुत पहले नहीं था.
हाँ, जब मैं आज मुझे ऐसा ख्याल आ रहा, मैंने देखा नहीं पहले.
ये रिसेंट, इट में भी लास्ट 10 इयर्स में हुआ है. एक्चुअली जब स्टाटस डिसाइड हुआ ना, so earlier it was a project of DST and MOS. Then once we got our status, this logo was approved.
Okay.
Asana? 1 minute.
While speaking, we should keep video off or on?
It should be on. What is there?
On sir.
आपका bandwidth ठीक है तो no problem, you can keep it on.
Bandwidth तो ठीक है. Yeah.
So I think sir we are ready. Then shall we start sir?
Yes.
2:14 हुआ है. 2:14 हुआ है. I think one more minute.
एक मिनट एक्स्ट्रा. 2:16 को स्टार्ट कर.
मेरा यहाँ पे 15 हो गया था. ओके सर.
नहीं, आपका ईस्टर्न साइड है ना, जल्दी घड़ी चलता है उधर.
यहाँ वेस्टर्न साइड में भी 2:15 हो गया.
So shall we start, sir?
Okay, good. 15 to 15.
My sharing is not activated. I can't share.
I can't share it. I can't share it.
Director of
So organizers can see how many are participating.
हाँ कितना है अभी
20-25 ठीक है.
No, 2025 is this link.
Okay.
That is different because all things are not coming here, I think.
कितना missing है
And there is a separate YouTube link also there.
Out of 10, I think, मतलब excluding the lead talk, we have 9 talk, but उसमें 2 people are not responding. So 7 are there. Other than the lead talk.
Okay. So this YouTube links will be available afterwards also?
Yeah. Yes.
Okay, that is good. Yeah.
It is available.
So we can
Your
start now, sir?
IMS YouTube, yeah.
Who is not responding? Kundu, who is not responding?
Kundu sir, can we this share link is not activated? Will it be activated before the presentation?
It will be activated when your turn comes.
Okay.
Yeah. Rishiparna Guha, serial number 9, is not presenting. All other are there? All other? So sir, only one is missing. Now other
So
also confirmed.
has he told that he is not presenting or?
Yeah. He has confirmed he is not presenting.
Okay.
Serial number 9 is not.
Okay.
Request Rekha to start.
Sir, Kerubula Naran Reddy is not come. And Rishiparna Guha.
He will come. He is coming.
Okay.
So let me formally welcome you all. A very, very good afternoon, everybody, all the dignitaries in the panel and all the participants. I'm welcoming you to the technical session 3, that is Land, Ocean, Atmosphere Interactive Processes. Today, to chair the session, we have with us Dr. P.C. Joshi. Sir is a former retired scientist of Space Application Center, ISRO, Ahmedabad. Sir was the group director of Meteorology and Oceanographical Group of Space Application Center, Ahmedabad, and Sir is also a fellow of IMS. I hereby request Sir to chair the session. I am also happy to introduce you Dr. S.S. Kundu, Senior Scientist, NESEC, Secretary, IMS Local Organizing Committee, as the co-chair of this session. Now the forum is to you, sir. Kindly chair the session.
Thank you, Rekha. So, welcome to this session 3A, Land, Ocean, Atmosphere Interactive Processes. And we have, as told by Kundu, we have 9 presentations and 1 lead talk. We have 2 hours time. So probably as roughly it comes 20 minutes for the lead talk, and let us give 10 minutes for the presentation, though we have some cushion, so we can put it in the question answer session or some interactive thing at the end. We can do that so that we finish it in time. Okay, and I request Kundu is the co-chairman. Can I request you to keep the time track? Track the timings of all the papers.
Sure, sir. We'll do that.
And as and when, what we will do is we will invite alternatively one by one as and when it comes.
Right, sir.
वो मेल चला गया था ना?
पटनायक सर म्यूट कर दीजिए.
Oh, sorry.
कोई बात नहीं. Patnaik is the king, so king cannot do mistake. Okay. So now we start the session, and we have the lead talk by Dr. Ashish Mitra, a very long-term associate of mine. And he is at NCMR WF since 1989. And NCMR WF came practically around somewhere 84, 85, if I recall correctly.
No, sir, 89. It came in 89 January. I was the first person to join.
Oh, great. So that's it. Why I say 84, 85 is I was also interviewed for NCMR WF.
Okay.
And that was around 84, 85 somewhere. But of course, I did not agree for joining that time. So maybe that's the initial when the project was going on there. Sorry. So 19. So welcome the first joinee of the NCMRWF to give us the talk. And the NCMRWF is now doing very well. I have been very, very closely associated with each and every activity of the NCMRWF. So I know these friends very well. And Mitra is basically a master's degree holder in physical oceanography. That's a great. He did PhD in ocean modeling from IIT Delhi. And as I said, since 1989, he's at NCMRWF. Now he's leading the center and doing a great job. He has done a lot of work. He has almost around 190 to 100 research papers. And that's a good number for an operational agency, because NCMRWF is an operational agency that way. So for an operational agency to publish so many papers is a very, very remarkable thing. He has been doing in the coupled modeling, data assimilation. The thing which I interacted, I knew more about the merging of the satellite and the rain gauge data for the daily gridded data, and that has been used many places, and that is quite useful. So he has done a lot of work, and let us more hear from him on the seamless coupled modeling at NCMRWS from days to season. That's a great thing. Days to season, because when I joined meteorology, it was we were doing only either day or something like that, and all were different models. And now our friends are doing everything with one model and days to season. Okay, so with that a brief introduction, I requested Dr. Mitra to give his talk. Over
so I hope the screen is visible.
Not yet.
I will make it full screen.
No, they have not
Please
yet
share,
authorized.
sir. Please share.
I have shared earlier. Once more, I will share.
Yes. Yeah.
Yes.
Are you able to see it? Yeah.
Yes, it's there.
So I made it full screen. Is it? Are you able to see it?
Yeah, that's fine.
Okay, thank you, Dr. Joshi. It's very nice that you are chairing this session. I have been interacting with you when from your ISRO days. So thank you, IMS, for giving me this opportunity. So I am now heading this NCMRWF, but I will not be presenting all the aspects of NCMRWF, but one work which is related to development of a seamless modeling system at NCMRWF. Only that part I am going to talk. So what I will cover is seamless modeling system and the data assimilation system we have. Then very briefly, I will cover rest of the topics like what we are doing in medium range, then the ocean model and ocean data assimilation system. Then under the same seamless modeling system, extended range prediction, which is multi-week. Then the coupled seasonal forecast system. And very recently, we are configuring a regional coupled model. And what's our future plan? So this slide shows that we have multiple scales, and particularly for a country like India and the region like India and monsoon, this multi-scale is very important. And earlier the practice was in many operational center, if you remember, that people used to have a variety of model, one model for short scale, one for medium range, one for seasonal, something for climate. But the new trend is in last 1 decade, most of the modeling centers, they are developing something called seamless modeling system. That means you use the same dynamical core for predicting very small scale like thunderstorm to short range cyclone to medium range and 1 month prediction and seasonal, and same model is used for decadal and climate change. So the beauty of this seamless modeling system, why it was decided a decade back, all the modeling people in some workshop they decided, because if you use this kind of model, any change you make in the shorter scale, let's say from the field campaign data, then you can implement same change at other scales and see. So the model development cycle becomes very fast. Otherwise, what was happening, different models were going in different direction. So if you now go to many centers like Bureau of Meteorology, Canadian Met Center, they are all moving to the seamless modeling system. So UK Met Office is the first, they moved to seamless modeling system. And now NSEP has, from last year, 2019, they are implementing a seamless modeling system. The medium range part, they have done it. And over next 2 years, they are going to do it, the short range and seasonal, etc. And we are able to do it because we have a collaboration under a partnership with Bureau of Meteorology, then New Zealand NIWA, and Korean Met Agency, then UK Met Office, and of course MOES in India. So we are all part of the consortium. That's why we are able to contribute and benefit from this partnership. So what we have configured in our NCMRWF as part of this seamless modeling system, you can see, if you are able to see the mouse, so I will go to 12 kilometer global medium range forecast model. It's a very high resolution global model. Then we have a nested 4 kilometer model, which has its own data assimilation system. Then 1.5 kilometer model, and very fine 330 meter model for Delhi. And the beauty is the dynamical core is same. So same, as I said, seamless modeling system. And we have ensemble prediction system for both global and regional. Then the last one is, in last 2 years, we have implemented this coupled system. Again, the atmospheric dynamical core is same, and the ocean parts are different, sea ice and land surface. So the beauty is the same dynamical core is being used across all scale. And very briefly, I will just cover the data assimilation systems. So we have a global 4D-var data assimilation system, ensemble 4D-var, and a regional 4D-var assimilation system. We have a land surface data assimilation system. And very recently, we have implemented the ocean and sea ice global data assimilation system, because you need the initial condition for the model. And looking at the models, part of this seamless, what I showed that globe, you have 12 kilometer unified global model. Then ensemble prediction system is 12 kilometer. It's one of the highest resolution in the world. No other country is having such a high resolution global ensemble prediction system. Then regional 4 kilometer model and regional ensemble prediction system, then coupled model. This coupled model, we run daily up to 2 weeks, then once in a week up to a month. So to give weekly anomaly, then once a month, we run it for next 4 months, and we issue a seasonal forecast. And these are some of the data. Satellite data is the main, which is used in the global data assimilation system. So I will not go into this detail. So this slide will be available, people can see. But one of the very beautiful thing which we have implemented is called forecast sensitivity observation impact. That means in your assimilation system, you can pinpoint for a region during a period that which data is having how much impact. It's very useful for planning a future sensors and satellite, or doing that how much we should invest. You can see the ATOPS is having highest. So this is a very useful tool. And coming to the regional data assimilation system, so as you can see, our priority is now to put all the IMD radar data. So we are able to assimilate the radial wind and the reflectivity. Radar reflectivity is experimental. It will be soon made operational. So this is for the 4 kilometer regional model. So this is the list of all the data which goes into the assimilation system. So to summarize what's happening in data assimilation system, that we are continuously upgrading the data assimilation system, both global and regional. And recently we have experimented with the ELUS wind, which is being used recently, and we'll be making it operational. Very useful, this one. And DWR reflectivity, as I said, from Indian radars of IMD, that will be becoming operational. Then earlier we were doing only clear sky radiance assimilation. Now cloudy sky also we have experimented. It will be implemented. So just one slide I will show about the land data assimilation system. So again, this is the land surface Joules model based extended Kalmar filter assimilation system. So it can assimilate soil moisture and variety of observation, but currently we are assimilating only ASCAT soil wetness and INSAT land surface temperature. Now coming to the global model, I have put only 2 slides to show the recent Nivar cyclone case. So you can see the top left one is the analysis, and these are different forecasts like day 5, day 9, day 7, and day 10. So you can see day 10 was also indicating, but the location was not correct. But you can see day 5 and day 7, even I will say the prediction was very good. This is from the atmospheric only 12-kilometer model. And if you look at the rainfall, same Nivar system. So this is the observed rainfall from the satellite gauge data set. So if you see the observed and look at all the forecast up to day 5, I will say the forecast was very good, because the core of the heavy rainfall, the models have not reached there, but it was indicating well in advance that the forecast will be good. And same thing when we looked at the track errors, so the global model is doing a better job. And one more case, I just recently there was an unseasonal rain, and if you see the observation here and the forecast up to day 5, it was all captured very well, and it resulted from the interaction of a western disturbance with the Arabian Sea flow. So that was again captured 7 days in advance in all the model, global model. Now coming to the regional model, so this is a mesoscale convective scale model. So convection is resolved here. It has its own assimilation system. So one of the new product is this lightning prediction. So I am just showing you 2 slides. So we have Air Force observations on the top left, and these are different experiments we are doing, but you can see largely the area of lightning is predicted very nicely in this mesoscale model. And we also regularly verify these things. So these are the mean observation here, and these are the mean model for May 2019 and June. So if you see, roughly the areas are predicted, but again, a lot of work has to be done because there are biases in the model. And coming to the same 4-kilometer model, that we had a dust storm moving from western to Agra, and it came all the way UP. So if you see all the prediction, very nicely it captured. So these are further useful, these 4-kilometer models. See the wind gust, how nicely it predicted in the 4-kilometer model. So this model has the potential for thunderstorm prediction when we make it 1.5 kilometer, which is already tested, but we have to make it operational. And very recently, this winter season, we have upgraded the 330-meter model for Delhi fog. So the chemistry module is included, and you have now high resolution emission inventory, which is taken from EDGAR, and the IITM emission is used for the Delhi region. And we have also included the biomass, this stubble burning across the boundaries, so that it can be used. So combinedly, if you see, we just did some experiment with, we used this ISRO urban differentiation data. So if you see the urban heat island impact is very nicely captured. Earlier we were using some climatological data, but with ISRO urban fraction, the model is doing good over Delhi. Now coming to the ensemble prediction system, as I said, it's one of the highest resolution ensemble prediction system, 12 kilometer, and we have 22 members. So these ensemble prediction systems are very useful to define the probability. So you might have seen whenever there is a cyclone, we give the strike probability to IMD, and from other model also IMD receives it. And this is very useful for estimating the uncertainty. And we have seen the ensemble mean is generally better than the deterministic model. So this is the global ensemble prediction system. So we have similarly this 4-kilometer, 12-member regional ensemble prediction system. So I'm just showing one case. So recently lightning forecast was in demand. So we are testing that how the lightning count is captured in this ensemble prediction system. So different counts, its probability is shown. So this is again operational and very useful in the cyclone and severe weather prediction system. So the Nivar cyclone also was predicted very nicely. Now coming to the ocean component, because it's the seamless coupled modeling system. So we have a standalone ocean model first. So we have this ocean assimilation system also, which is global. And we use all kind of data like SST, temperature, salinity profile, sea level anomaly, and sea ice also. And like any other assimilation system, it uses a 24-hour forecast. The window is not 6 hours, but 24 hours. And then we produce a ocean analysis, which goes for producing the ocean forecast. So these are some of the ocean field, how it looks: SST, sea surface salinity, sea surface height, and current. So it's 25 kilometer, but the vertical level of this model is very high, 75 layers. Then coming to the coupled model. So what I was showing, the atmospheric model, ocean model, and the land surface model combinedly through a coupler, we have this coupled model. And the CIS model is Las Alamos Laboratory CIS model. And so we run this model for different purpose, like run the assimilation system daily, which is at number 1. Then run the model daily up to next 15 days. So this exercise is mainly to provide the tropical cyclone heat potential, very useful. I will show you one example. And what we are planning is the same model will become a coupled NWP model, 10 kilometer by next year. Then the third item is, as I said, multi-week forecast, every week, next 4 weeks. Then fourth item is the seasonal forecast, every month up to next season, 3 months. And very recently, the fifth item is the regional high resolution prediction system, coupled prediction system for severe weather. So these are the coupled system which we are running here. So the example of the coupled system, I want to show you tropical cyclone Fani. If you look at the top left, shows the tropical cyclone heat potential. So look at the TCHP. So if you remember, Fani took a path very close to this coast and it was moving. So one of the reason we suspect is the high tropical cyclone heat potential available there. And it was predicted 15 days in advance. So it was giving some clue that the heat potential is there and it's going to be maintained. So that's how this coupled model is very useful. And we have also compared the coupled to uncoupled in the ocean forecast. So if you can see the RMSE for Bay of Bengal, everywhere the coupled model is slightly better. So what it suggests that future ocean forecast models also will be from the coupled model. Now coming to the extended trend prediction system. So because you have to give weekly anomaly, so we have produced the hindcast, 23 years of hindcast. And every week we run. So there are 16 ensemble members, and the hindcast has only 6 members. So anomaly is computed like this. So the model climate is good. This is week 1, 2, 3 for biases, not much, but there is a bias in Indian Ocean, which prevents the model to produce the intraseasonal oscillation realistically. So this is a negative point of the model. So more research is required to improve this bias. But we have seen this model captures very nicely the dry and wet spell. So these are some of the example of wet to dry and revival. So 4 weeks in advance, the model was able to capture very nicely. So this forecast is shared with IMD every week. And the model skill at subdivisional level also we have seen. So week 2 skill is usable, and week 3 also many subdivision skill is okay. But week 4 the skill drops. Then coming to the seasonal forecast, so one can look at this paper. So this NEMO and seasonal coupled model is good. So it shows among many models, this is one of the best models. So this was published, and this glossy 5 you can see. So it's a very good one. And so we have compared even with the ECMWF model. So the skill biases are very less. And we have made hindcast. And so each month what we do, we make a run, and we run for almost 10 days, each day 4 to 5 members, and 55 members ensemble is there. And hindcast is for 23 years, and per year 6 members are there. So these anomalies are computed like this. So this is one example of the latest forecast for issued in September, not latest, we issued in September for the October, November, December season. So you can see what it shows. The northeast monsoon Bay of Bengal is normal to above normal. So we'll see how it realizes. So this is the rainfall forecast. The last slide, this was anomaly. This is the full rainfall forecast. And this is the percentile forecast, the high probability of rainfall above normal in the Bay of Bengal and in the northeast monsoon, and partly also in the western coast. So one of the earlier paper, they suggested that if you vertical resolution of the ocean model is very high, and if you call the ocean model very frequently, then you will get better coupling, and the impact of coupling intraseasonal oscillation will be good. So we are aspiring to use a very high resolution model in future. These are the last few slides. So because this is a coupled model, we also produce this polar forecast and sea ice forecast. So one of our center in Goa, NCPOR, they use this forecast. So we use it, we issue this forecast daily up to next 15 days, then extended prediction up to next 4 weeks. So these are some of the example for last one was Arctic, this is Antarctic. And the skill we have seen interannual variability model skill is good. So 1 month in advance, you can predict that sea ice will be below normal or above normal. This was one situation, one of our institutes ship was stuck near Maitri and it wanted to come out, and we were issuing sea ice forecast, and we were predicting that there will be no relief from sea ice. So ultimately a Russian ship was called to pull this ship. So the sea ice forecast is very useful in real-time operations in our Arctic and Antarctic centers. Now the last item is the regional coupled model. To capture the severe weather, we are implementing this model. So same atmosphere, joules, land surface, ocean, but we have an extra wave here. Wave model, wave was 3. So they are all coupled and we started getting early result. We are simulating this cyclone. And if you look at the simulation and actual cloud picture, they are matching well. So this will be most probably next year operational in our center. And another beauty of this seamless model is when you go to field campaign, there are many field campaign MOES is organizing, IITM. So this is one example. We had an Indo-UK field campaign, one aircraft from UK came to India. So a lot of observations were collected. And similarly, there are field campaign in the ocean. So this was again another campaign with Indo-UK institutes. So all these observations at point scale, very local scale, can be used in this unified model to compare the model observation, and you can improve the parameterization here. Now we have seen that ECMWF has moved to a coupled NWP system medium range last year 2019. So this is one of the priority that all our Indian centers have to quickly move to coupled model for this NWP medium range forecast high resolution. ECMWF has done it at 9 kilometer. So we are also planning, if you see the last item number 8 in our future plan, we want to configure a 10 kilometer atmosphere and 25 kilometer ocean by 21-22 for the coupled medium range forecast. So this is my summary slide, and thank you.
Thank you, Mitra. Great. This is exactly the time what we. So time management is great. I'm very happy to see that so many things you are doing and things are working so well. And in fact, I was not very much familiar with the day to season, all coupled things you are doing now. So it's a great thing to know from you. Now, maybe a couple of questions if something has come up.
Yes.
Kundu is there? Or I can check whether is there any.
Actually, Kundu sir is just went out because some problem in our another hall, Brahmaputra.
Okay.
I think there are.
Okay, no problem. Okay, maybe even if it is there, if there is any other question, you can even with the email, you can check with the Mitra.
Please email the questions.
I may have one or two inquiry.
Yes.
Yeah. I forgot to mention to the audience, the Mitra has spent considerable time at Florida State University with Professor T.N. Krishnamurthy in working with the numerical models. I think almost 2 years he was there. And
yes,
satellite data also he has used very often there. And the another wonderful visit was for the UK Met Office. And that is how the UK Met whole thing came here, and that was a great. Now just query is all these like UK Met Office, are they also doing the similar thing now? What you are doing here from the same model or around the same core, everything is running around, or they go?
Yes. Yeah, the software engineering part is, so what they do, the consortium I said, so we have a consortium agreement, our Ministry of Arts Sciences have signed with the consortium. So New Zealand Met Agency called NIWA, Korean Met Agency called KMA, and even US Air Force and Bureau of Meteorology Australia, UK Met Office, and our MOES. So there is a consortium. So the model goes on developed by many agencies. Suppose Australian has developed some scheme, it will become part of the model, but the choice is yours. Which is good for your area. You can use experiment with that. So that's how. So it is open to all consortium members. So if we contribute some, let's say we improve the convection scheme. So if it's working good, everybody adopts that. So for example, Australia has put a new land surface scheme there, cable. So it's working good. Whoever likes can use that one. So the model grows like a tree branch. So we call it, you download a particular branch and use it. So there is provision to download and you can contribute also. It becomes part of the software tree.
Oh, and the ECMWS is separate from this. This is separate from that.
Yeah, incidentally, the ocean model is same, NEMO, and the ocean assimilation system also is very similar. But the atmospheric model is ECMWF is different.
Sir, there is a question. Can you take it, sir?
Yes.
Yeah, there is a question from Prashant. He says that NCMRWF coupled assimilation system is a strong or weak coupled assimilation system. Please say about control variables used for coupled DA.
No, actually we have not started coupled DA. So now the ocean assimilation is done separately, atmospheric model, but we are working on a weekly coupled data assimilation. So we think by 21, 22 it will be implemented. It's still development stage. Again, it's being done in collaboration with the consortium. So because these are very sophisticated things. So currently we don't have a coupled data assimilation. Thank you.
That's it, Kundu.
Thank you, sir. Yeah, there is nothing else.
Okay, with this lead talk is over. Thank you, Dr. Mitra.
Thank you, sir. Thank you.
Here, but I want to, on his behalf, I want to make one more announcement to the audience. The NCMRWF recently started giving the reanalyzed fields, which using every person was using either from ECMWF, NCAR, all the. Now, this data is available from NCMR. Gridded data, analyzed data is available from NCMRWF. And as much as you can use, whatever is my understanding, I may not be knowing the full details, in their website, all details are given. You can use that data. Thank you very much, Dr. Mitra.
Thank you, sir. Namaste, namaste.
Namaste. Okay, so this is over. And now we move to the oral presentations. So in all, we have 9. So 10 minutes time. Please take care. And all, okay, 10 minutes time. We start with the Biswarup Das.
Sir.
Yes. Can you start, Biswarup Das?
Yes, sir. Joshi, sir, can I start my presentation?
Yes, very much, very much.
Am I audible and my slide is clearly visible, sir?
Excellent. Everything is excellent.
Right, sir. Thank you, sir. So the topic is evolution of positive and negative IOD event and associated air interaction process and impact on Indian southwest monsoon rainfall. Objective of the study is to analyze the impact of positive and negative IOD event over southwest monsoon rainfall and how the surface, upper air and subsurface features over equatorial Indian Ocean evolved during positive IOD and negative IOD event, and how the dipole behavior in various parameters like rainfall, SST, heat content, temperature and profile anomaly, basically subsurface, surface and upper air, all three components show the dipole behavior during the IOD event. The study area, classically we have taken 2 boxes. One is western box, which is 50 to 70 degree east and minus 10 to 10, and eastern box is 90 to 110 and minus 10 to 0. So this is taken from literature, the western box and eastern box. So data used, various data, 3 positive IOD years, 2006, 12 and 15, and 3 negative IOD years, 2010, 14 and 16 has been utilized for the study. NOAA IVHRR SST anomaly data, NCEP reanalysis data, IMD gridded rainfall data, and GPCP rainfall data, and Argo subsurface temperature profile data has been utilized. Methodology, SST anomaly has been computed for the PIOD and NIOD composite as well as for peak PIOD and NIOD year, which has been followed by the precipitation anomaly analysis, and IMD rainfall also has been analyzed to see how they behave. and daily march of SST difference with the equatorial SST difference, and the rainfall over monsoon core zone over central India that has been analyzed. The subsurface temperature profile anomaly, heat content anomaly computed from Argo gridded data to analyze the behavior of dipole nature, as well as the wind direction speed anomaly and horizontal convergent divergence over both the western box and eastern box, as well as the upper air data from NCEP has been analyzed for all the 3 positive and the 3 negative IOD. Now we come to the result and discussion section. The spatial evolution of IOD, where the positive IOD composite and negative IOD composite is shown here. Positive IOD composite shows that over western box, the SST anomaly is about positive 0.5 to 1 degree Celsius, and negative over the eastern box, it is about negative of minus 0.5 degrees Celsius. So therefore, this is cooling and therefore warming here. And opposite is the case during the NIOD composite for 3 years, 2010, 12, and 16. Where around 0.45 degree Celsius negative anomaly is seen where there was positive, and where there was negative, there it is showing positive. So exactly coupled behavior, opposite behavior. And the same thing is seen for the one positive peak IOD year for positive 2012 and 14, and similar nature we can see here that warming and cooling are alternate in the positive and the negative year. Now we try to see what is the impact over the monsoon core zone, which is central Indian 73 to 83 degree east and 18 to 25 degree north. In this using IMD data, we saw that over positive IOD composite, PIOD composite for 3 years, anomaly is about 1.7 millimeter per day over this box. Whereas in the negative IOD year, it is 0.9 for almost half of this. And individual years also, we have tried to see that whether this IOD has an impact over monsoon core zone rainfall. So we could see that during the positive IOD years, like 0.5 millimeters per day and 1.5 millimeters per day, both are positive. Whereas in the negative years, it is minus 1.2 and minus 0.1. So negative composite or negative years shows negative anomaly over the central Indian monsoon core zone. In addition, during 1st August to 31st October, this is the IOD peak period. During this period, the GPCP, using the GPCP data, we try to see how the precipitation anomaly over the equatorial Indian Ocean behave, and we saw that western box is about 2 millimeters per day, and eastern box is about minus 5.5 millimeters per day, which is exactly opposite in case of NIOD year, where this area becomes positive rainfall, about positive rainfall anomaly of 2 millimeters, whereas this area is minus western box is minus 1 millimeter. So exactly opposite rainfall anomaly also shows the similar. Now we also tried to see whether the SST difference over the equatorial Indian Ocean region between the western box and eastern box, and how they correlate with the monsoon over the central monsoon core zone, that is the central Indian region, which earlier we have seen. So we could see one thing clearly, that PIOD and NIOD here, that the rainfall and the monsoon are exactly inversely proportional. Whenever the SST difference is less and the rainfall is more, and vice versa. And another thing, and same is during the NIOD year, another issue was that this is having so many peaks during PIOD year, NIOD comparatively lesser value and lesser peaks. So obviously there is a conclusion that PIOD is having more amount of rainfall over monsoon core zone. This is for the composite. Now we tried to also see that in the central monsoon core zone, the rainfall peaks and crest, they're exactly in opposite phase. That is from 1st of June to 30th of September. For all the 3-year composite, the black color is PIOD composite and red color is NIOD composite, where they're in exactly opposite phase. And we also tried to see how the DMI by ST, that dipole mode index, the difference of anomaly between the SST of the western box and eastern box, how they behave. We tried to see, and we found that the diverging pattern actually starts somewhere around May, and around mid-October, the difference between the DMI, dipole mode index, between the western and eastern box is actually peaking between the positive and negative IOD here, and thereafter it is again converging towards December. We try to see whether there is a link between the dipole mode index and the oceanic Nino index, that is Nino 3.4 SST anomaly, and which is generally the index for the El Nino. We tried to see, and we found that in 2006, where the DMI is peaking after 3 to 4 months, this red color is indicating when ONI is peaking. So there is a time lag after that. ONI, it's like DMI is peaking around October, November, and then next year around 2007 February March, ONI is peaking, indicating El Nino condition. And but in 2010, when the DMI is negative IOD condition, where the DMI is very less, and ONI is also showing negative anomaly of about 0.8. So both are in phase. There is no time delay in this. A similar condition we tried to analyze for 2012 and 2014 and 16, where we saw that 2014, this is a positive IOD year where the DMI is peaking after 3 to 4 months, then ONI is peaking. Whereas in case of negative anomaly, negative IOD year, 2014 and 2016, both DMI and ONI index both are almost in the same phase. Almost both are showing negative trough almost in the same time, hardly very less time difference. So this cannot be generalized, but at least for 6 years, this is the trend. Now, looking at surface, now we try to look at subsurface also using Argo subsurface gridded data from Inquires. We try to see in the anomaly, because all the IOD signals are actually in the anomaly, not in the actual data. So in the subsurface temperature profile anomaly, we saw that PIOD composite is showing cooling, whereas NIOD composite is showing warming. Exactly opposite is the case during the Western Indian Ocean also. This also PIOD and NIOD composite is showing exactly opposite. Where there was cooling, now this is warming, and where there was warming, now this is cooling. We try to compute the heat content anomaly up to 100 meters in the ocean, and we saw the anomaly, heat content anomaly is also showing a dipole behavior where the warming is almost this value is 307 joules per meter square, where in the cold condition over eastern box it's around 0.96 into 10 to the power 7 joules per meter square. And if you see the NIOD composite, where is exactly this is more, this is less, and now this is exactly opposite. Now this is less and this is more. So this subsurface also we can see the dipole nature is observed. We try to look at the signal in SST anomaly as well as OLR anomaly, and we found that in the positive IOD year 2006, the western box is having an SST anomaly of 0.5 to 1.5 degrees Celsius warming, as well as it is having an OLR anomaly of minus 20 watt per meter square. Whereas in the eastern box is minus 3.2 to minus 1.2 degrees Celsius, which is cooling, as it is associated with OLR anomaly of 50 watt per meter square, which is aiding the cooling process. And exactly opposite is the situation in case of 2010 NIOD event, where the cooling and SST and the OLR both are supporting the cooling and warming process. We try to look at the wind direction and speed anomaly during the PI.
You have to conclude now. Time is over.
Yes, sir. Sir, just 1 minute, sir. Half a minute, sir. Half a minute, sir.
Yes, yes.
So wind direction and speed anomaly, where we can see that the wind in the wind direction and speed anomaly, we can see from eastern box to western box, the wind is actually flowing from high to low, as well as from during the negative year, exactly opposite is wind direction is from the western box to the wind directions are exactly opposite in the anomaly pattern. And also we can see here that there is some amount of divergence, which we try to plot the convergence and divergence also. We saw that during PIOD year, the eastern box is divergence and western box is convergence. So actually there is a flow which is this divergence and this is convergence. So and when we try to compute the similar thing for NIOD composite, we saw that there is a both are showing convergence. However, this convergence value is very less, 0.4 into 10 to the minus 6 per second, whereas in eastern box is minus 2.9, almost 6 times of this value. So much more convergence. Now we try to have a look whether the Walker cell will give an indication, because and Walker cell we saw that in 2006 PIOD year the main upward motion is concentrated around 65 to 70 degree, which is over Indian region, whether western box was there. And NIOD, the Walker cell NIOD year, the Walker cell actually shifted from 60 to 70 to 90 to 100 degree east. And we tried to see whether this is the case for other years also. And we found that this is the case for other years also. 2012 and 15 both are positive years where the upward vertical velocity is in the center 60 to 70, whereas in the negative years, mean upward vertical velocity, the core has shifted to 90 to 100, which is over eastern box. So these are all in consonance with each other. So we come to the summary and conclusion. It is observed that significant variation takes place in southwest monsoon rainfall over monsoon core zone during PIOD and NIOD years. It has direct bearing with assisted difference over equatorial Indian Ocean region. And it also emerged that the study that the enhancement in the precipitation over the western box and the eastern box and subdued precipitation over the eastern box and opposite happens during the negative IOD events. And it can also be stated that not only SST, but rainfall, upper air, subsurface temperature profile anomaly, heat content anomaly, and wind anomaly all exhibit dipole-like behavior in the Indian Ocean region. Even if the total southwest monsoon rainfall does not show a particular pattern during these IOD years, but region-wise significant spatial variation over monsoon core zone over the central Indian region, that can be observed. That is enhancement of rainfall during PIOD year and opposite, that is subdued rainfall during NIOD years. So here I finished, sir.
Great. Thank you, Vishnu. It was a very good presentation and the data and everything used was very good. Any question? Where does Kundu in the chat box it comes or where is it?
Yeah, it comes in the chat box, and even close to chat box there are 3 dots, horizontal dots. If you click there, Q&A comes. So in that
anyway,
also it is visible, but
I'm not able to see, but please take care of that. Okay.
Yeah, I'm taking it, sir. There is no question now, sir. There is no question on this.
Okay. Thank you very much.
Thank you, sir. Thank you, Kundu, sir. Thank you.
Thank you. Thank you very much.
Now we move to the next talk by Bivin Jose. Your slide is coming. It is shared. It's very. Now only my request is, if there is no Wi-Fi problem, if you could switch on your camera also, then we could see you speaking. Then it looks like we are very closer to somewhere nearer to physical. Otherwise, it's really virtual. So if there is no problem, you can please switch on the camera. But sometimes there is a problem with the Wi-Fi. Absolutely, there is no requirement. So we move to the Bivin Jose, impacts of various rainfall forcing on soil moisture distribution. Over to Bivin.
Sir, can I start?
Yes, please.
My topic is impacts of various rainfall forcing on soil moisture distribution over India for a 3-year period using land information system.
Is it possible to switch on camera? You are from.
Okay, we'll try, sir. Start video.
Okay, leave it.
Sir, now it's clear?
No, slide absolutely clear. Yeah, now you can see you. At least great. Good.
Okay, sir. So let me introduce what is land information system. So LIC information system, it contains the land surface modeling, data assimilation software. That's actually a software framework developed by NASA. And also it can integrate the satellite derived data set, ground-based observations, and model reanalysis data to force the land surface models. It consists of land surface models like NOVA AP, CLM, like models are available. Also, LSMs can run in LIS globally with a resolution as high as 1 kilometer. And the LIS consists of 3 parts. One is LDT, other one is LIS subsystem, and third one is LVT. The LDT means the pre-processing unit of LIS that will process all the forced data set, everything processed by the LDT. The LIS subsystem, it consists of the models. That means the NOVA model, everything is coming under LIS subsystem. In the data assimilation techniques, everything is coming under LIS subsystem. And the third one, LVT. LVT is a post-processing unit. That means we can assess the result. For that, we are using the LVT. This is all about LIS. Not moving, wait, sir. Hello?
Yes, please go ahead. We can hear you and see you.
The slides is not moving, sir. That's why.
Oh, slide is not moving. This is PDF or PPT?
Sir, please switch up your video, sir. Your bandwidth is low.
Okay.
Sir. Yes. And also again share, sir.
Okay, now
Stop share. I'll stop your share. We will.
share now. Sharing option is not available. Okay,
Yeah, just
I got
wait.
it.
Can you share?
Yeah, now I share. Okay, sir. So now
Yes.
it's visible, sir. Hello.
Yes, yes.
Okay, coming to the objective, my objective is to estimate the uncertainty of soil moisture to different precipitation forcing. That means I have done 3 simulations. In the 3 simulation, only the difference is that I am using 3 different rainfall forcing. In the first one, I am using the G dash rainfall forcing. In the second one, I am using the TR forcing. The third one, I am using the IMD gridded rainfall forcing. In all 3 cases, I am using the same G dash meteorological forcing I am using. And after the result, I am validating by using the IMD in situ soil moisture station data I am using for the validation. This is the domain, study domain. You can see the right side. This total 5 homogeneous regions are there, and also the yellow we can see the hilly regions. In these hilly regions, the IMD in situ soil stations, soil moisture station data are not available. So I have removed the hilly regions and also the northeast regions because the in situ data is limited over these regions. So coming to the next slide, the model I have used the NOVA with a version of 3.6 LSM with a resolution of 0.125 degree. And also the data I have used the meteorological forcing data I am taking from G dash, TRMO and IMD, and the land surface parameters that is used to force the NOVA LSM that I have used the land cover data I have taken from the MODIS, and the blended soil texture map I have used Statisco FAO soil texture map I have used, and the elevation I have taken from the SRTM, and the albedo, slope type, bottom temperature, these things I have taken from the NSUP data. This is the methodology. That means the initial state I have taken by spinning up 5 years. After reaching the equilibrium, I got the initial state. After getting initial state, I am using the atmospheric forcing I am taking from the G dash. I am forcing to the NOVA LSM. Similarly, I am giving the land surface parameter that we have seen in the last slide. That also I am forcing the NOVA LSM. And for the first simulation, I am using the G dash precipitation. And the output, what we are getting, the LIS output, from that we will get the soil moisture. In that soil moisture, I am evaluating the soil, the IMD in situ. That for the first simulation. For second simulation, I am using the IMD gridded rainfall. For the third one, I am using the TRMM rainfall. So these are coming the results. And this is what I am showing is that time series of grid average soil moisture over different homogeneous regions for the study period of 3 years at 15 centimeter depth. That means in that the red color we can see that is the G dash, that means G dash forced simulation. That means G dash rainfall we use forced one, that is the red one, and the blue one that means TRMM forced run, and the green one that is the IMD forced. And you can see the purple one that is the in situ. That means that is the actual truth value. IMD in situ soil moisture that is coming the purple one. And we can see that in all cases, that means in central northeast India for 2012, 13 and 14, and I can see everywhere all 3 simulations are overestimating the truth. That we can see that. Also we can see that green color, that means the IMD forced NOVA LSM, that output is coming close, that is close to the in situ. That is the close to the in situ. This is for the 50 centimeter depth, that is for central northeast India and northwest India. And also this is for west central India and peninsular India. I have done the same thing for the 5 centimeter depth and 30 centimeter depth. And there also I got the similar output also. That means the IMD in situ is coming closer, and everywhere IMD forced simulation coming closer to the in situ. And also I have found the comparison of correlation coefficient I have found. In that almost 22 stations are there. Out of 22 stations, almost 15 stations, the IMD forced simulation showing higher correlations. And also I have found the RMC for in that RMC also in all season, winter, pre-monsoon, monsoon and post-monsoon, in all seasons, in all homogeneous regions, the IMD forced one showing the least RMC. You can see that everywhere the IMD forced simulation showing the least RMC. Then these are the conclusions. Conclusion means that I am saying that all simulated soil moisture outputs are overestimating the IMD in situ soil moisture. The soil moisture output using IMD precipitation forcing is closest to the IMD in situ measurements, followed by GDAC-TRMM. And the third one, the simulated output soil moisture using IMD as precipitation data has the lowest soil moisture RMSE over all the homogeneous regions and all seasons, followed by GDAC force simulation results. The IMD force simulation show higher correlation coefficient for most of the in-situ stations as compared to the other simulation outputs. Thank you, sir. Hello.
Time. Now, I will just suggestion to you.
Okay, sir.
You have made soil moisture is one of the important parameter for the study. Now, IMD, the data you have used, that is the observed one, the real actual one. TRMM is satellite derived, and GDAC, the data assimilation system. So even without doing it, I would expect that the IMD rainfall would definitely give a good correlation. So what is the purpose of doing for the TRMM and GDAS? Are you trying to see that how they are closer so that you can use that for that, or what is the purpose of the study?
How the satellite and satellite one and the modeled one and this one is the rain gauged one. How these three will differ. So that one only.
No, but for what? There should be some purpose for doing that.
So,
how they will see IMD will be best, no doubt about that.
So for doing this, after that we can found now we know that the IMD bus. So we can force this IMD, then the output we can use for running the WRF like by using coupled NUWRF we can run by using this output.
Okay. Any other question?
No questions, sir, from participants. No questions.
Okay. Will you take up the next one?
Yes, sir. We can. We should.
Huh?
We can take up, sir. Next one.
Okay, take up the next one.
Hello.
Yeah, we can hear you. Yeah, we can hear you.
Yeah. Okay. So probably he's asking me to take over. No problem. Now this is from the Shivan. ETL transfer convective sources during active and back phase. Okay. Go ahead, Shivan. We can see you very well. Thank you.
My
Go ahead.
objective of the study is. Hello. Objective of the. Can you hear?
Yeah, hear and see everything is
Okay. So the objective of the study is to find out the convective source and age of air parcels during the active and break phase of India's summer monsoon using Tropmet Lagrangian back trajectory model for the year 2017. This is just a case study for the year 2017. And to quantitative estimate of the convective air transport to the TTL region from different regions. For this study, we use 17 break days and 4 active days for the year 2017. And the Tropmet Lagrangian back trajectory model with the ERA interim data and the kinematic vertical velocity is used. This is a satellite coupled model where the probability of convective influence is measured by using Himawari geostationary satellite and Meteosat second generation satellite observations. Here the satellite data is used to infer whether the source region of air parcel at a particular level or potential temperature surface contain convective cloud or not. So the trajectories that pass beneath this cloud is marked as the convective source. And the time taken for this air parcel to encounter the convective source is the age of the convective air. So results. So first of all, we discuss about the active phase. For this study, we launched the air parcels from 360 Kelvin and 380 Kelvin potential temperature surface over the Asian monsoon region at a 1 degree resolution. So the figure A shows that the convective source during the active phase of 2017 upper troposphere, that is 360 Kelvin. From the figure, it is clear that the maximum convective source is from the northwest and northeast Bay of Bengal region, and moderate is from Central India, Northeast India, Tibet region. And the age of convective air is shown in the top right, where there is less than 4 days is taken to reach the upper troposphere. Air parcels will take less than 4 days to reach the upper troposphere. And the figure On the bottom left, that is C, shows that the convective source during the active phase at 380 Kelvin, that is at the TTL surface. From this, the major convective sources are from Northeast India, South China, and Northwest Bay of Bengal. And the transit time for the air to reach the TTL is greater than 18 days for most of the region. This is just to quantitatively estimate the convective air transport to the TTL region. For this, we just divided into six regions: 4 continental region and 2 oceanic region. Arabian Sea and Bay of Bengal, South China, North China, Tibet, North Africa, and Central Africa. Firstly, we discuss about the active phase. For this, the maximum convective source is from South China region. The figure at the top showing that the maximum source is from South China region and the moderate loading is from Bay of Bengal and North China. And the minimum transit time is taken from South China and the maximum time is taken from the air parcels from Arabian Sea to reach the detailed region. Next, we're discussing about the break phase. So the convective source at break phase at upper troposphere shows that the maximum source is from the central Indo-Gangetic plain and the Himalayan region, and the time taken is less than 3 days. And the figure at the bottom shows that at the TTL region, the maximum transport is from the Northwest Bay of Bengal, China region, and the region closer to Rajasthan, where the transit time is more than 16 days. This is the quantitative estimation of different region. So from the figure as similar to the active phase, the maximum transport is from South China region. It is from 8 to 14%. And the minimum transit time of less than 16 days is shown in South China region. And the moderate loading is from Bay of Bengal region. Conclusion. By using this Truxilla back trajectory model, we successfully determined the source and age of air parcels at upper troposphere and TTL region. And at the upper troposphere, the maximum convective source is from Bay of Bengal region and least is from Arabian Sea during the active phase. And the analysis at TTL region shows that the major convective sources is from South China region and minimum transit time also during both the phases. The air parcels from China will take less than 70 days to reach the TTL. Thank you. Hello?
There is no question.
Joshi sir?
Yes.
Yeah, there is no question from anybody. So.
Okay.
Hello. Hello.
Yes, we move to the Shaikat Sen Gupta. This is from where? The IITM and?
Yeah, IITM.
IIT Kharagpur.
Yeah.
Okay. So I think the topic is already visible. Your face is visible. Your slides are visible. You go ahead.
Okay. Thank you. So good afternoon all. This is the topic of my presentation. So in IITM, we actually work in paleoclimate group where we study the climate change through high resolution proxy. Now, what do you mean by the high resolution proxy? The proxy which will give you the past climate information in annual or say 2-3 years interval. So in that case, we choose the tropical treading, mostly the teak or Himalayan conifers, and also the speleothem, that is the carbonate deposits, which is actually can be resolved in annual basis. So we study the oxygen isotope of these two, which will give the informations of the climate. So the reconstruction is based on the principle that these oxygen isotopes of these two species or these two proxies, they are in equilibrium with the.
Sir, please slideshow, sir.
Oh, full slideshow. Just a minute.
Yeah, full.
Fine? Is it okay?
Yeah, it's fine, sir.
Okay. So this is one principle based on which we do the reconstruction. One is it is equilibrium with the then rainwater isotopes from which it forms. And secondly, the rain amount and isotopes, they are negatively correlated. So based on these principles, we do the reconstructions. So in isotope means we study oxygen and hydrogen isotopes principally. The stable isotopes, as we all know, that oxygen has 3 stable isotopes, 16, 17, and 18, and hydrogen has 2, protium and deuterium. So we mainly study the ratio of heavier to lighter isotopes. And this is how we represent the values, that is called delta 18O, and it is expressed in the unit of per mil. So apart from this rain amount, the rain isotopes based on which we do the reconstructions, they also actually depend on they also infer about the evaporating condition of the moisture sources, moisture transport and rain mechanisms. So based as it is considered as a useful conservative tracers to know all these situations, there are many isotope enabled general circulation models are available which actually simulate rainwater isotopes considering all the physical processes that I mentioned above. So this is one diagram you can see. This is a 3-ring oxygen isotopes have been plotted, and you can see that the periodicity is well representing the ENSO, standard ENSO signals. So the cellulose gelatino signals that they record, ENSO signals, it is a known thing. Now, as I told that the reconstruction is based on rainwater isotopes from which they form. So how are the signals of the climate variability recorded in the rainwater isotopes? So this is the next slide, which is here. It is an old study also. They showed a large variability of the oxygen isotopes, which has a very good correlation with the NINO 3.4 indexes. So we can see that the monthly composite, these are all monthly samples, they also record the ENSO signals. Now problem is that the long-term rain isotope data, whatever available, see if you see this study, say which has recorded 60 years data, they are mostly of the monthly composite samples. So now question arises that if we increase the frequency of the sampling, probably we can capture more high frequency signals like intraseasonal oscillations. So following these, actually there are 2 studies I have shown here that they have used daily rainwater samples instead of the monthly samples, and they are able to capture the signals of the Meren-Julian oscillation in their rainwater samples. So these small circle, these are showing very low isotope values. As I showed earlier, that this low isotope values is marked with a high rainfall events. So this high convective rainfall is actually indicating the convective phases of the Meren-Julian oscillations. So similarly, another study which has also showed how the Meren-Julian oscillation signals can be seen in the vapor isotope. Our earlier study in Andaman, where we have analyzed 2-3 years of rain isotope data, there we also found a 10 to 12 day periodicity of the delta 18O of the rain samples, and we inferred that it is capturing actually the signals of monsoon interseasonal oscillation, which is a quasi-periodic propagation of the rain-bearing systems that we all know. Now, all this from all these results, what we understand now, there is a variability during the convective and break phases of the intraseasonal oscillations. But which factors control the isotope variation among various convective phases of monsoon? Because even during the convective phases, if I can see these all the convective phases, they have a large isotope variability in between. So which factors control that? And secondly, if in a station we have a long-term data set, does the isotope variability solely depend on the monsoon interseasonal oscillation, or there is some other factors which is controlling that? And thirdly, the general circulation model, how they simulate the isotope enabled general circulation model, how they simulate the rain isotope signatures of the monsoon interseasonal oscillation. So in order to address these objectives, actually we need long-term daily based rain isotope data, which is in India is very scanty. So in addressing all these objectives, we actually collected rainwater samples in 2 locations which are in the southern West Bengal, very closely situated to the coast of the Bay of Bengal. And there, this is our data set. In one location, Barasat, we collected samples for 2 years. These are weekly composite samples in another locations, Kharagpur, where we have taken daily samples. And all these collected samples, these are the standard protocol that we all know, and it has been published in our earlier publications. So based on this protocol, we collected samples and we have analyzed oxygen and hydrogen isotope ratio of the rain samples, and they are all measured in isotope ratio mass spectrometer. So these are the results. This is the oxygen isotope data, the open red circle you can see, and these are the model delta 18 values which are in the blue open circle you can see. This is the data set of our entire study period. And the two important thing what you can see here, that there is a large variation of delta 18 values which is varying from say 18.2 to 2.8 per mil, and this 20 per mil variation is significant we consider. And secondly, the vertical green line bar, which is the rainfall, the daily rainfall. So lower delta 18 values are not always associated with the higher rainfall amount. As I told you in the principle of the reconstructions, that the rainfall and isotopes are negatively correlated. This is not always observed if you go to the higher resolution sampling. So this is what we can see here, and this is a longitude average 85 to 95 degree time latitude representation, a standard way to see the convective and break phases of monsoon interseasonal oscillation. And these are the stable isotope data in the upper panel, delta 18 you can see. So based on our this OLR anomaly data, we can find 16 convective phases of monsoon interseasonal oscillation, and you can see that this is the variations of isotopes, and mostly they are very negative, very low values we found during the convective phases, but there are many high values also in some of the convective phases of the monsoon interseasonal oscillation. So even during the convective phases, if we can see the all convective phases, then even within the convective phases we find a large variation of the isotope values. Now why it is so? In order to understand the problem and in order to know what could be the possible reason, we actually take the help of this published literature of Suhas and Goswami, who actually defined the convective phase speeds. It is the speed by which a convective phase can move from 5 degrees south to our study location. So it is generally few degree per say this is how we define the phase speed, and you can see that this is a typical example of how the phases moves. A particular phase, phase number 16 we have considered here. So we actually estimated the phase speed for 16 different phases, and during the phase speed it is a, you can understand that this convective period will stay over the study location for a few period. Whatever the samples we collect at that time, we make a grand average of that. Then whatever the rain takes place along these convective phases over Bay of Bengal, that we also take a grand average. And so therefore we have 16 sets of convective phase speed, 16 sets of delta 18 or oxygen isotope values of the rain that is collected during that period, and 16 sets of cumulative rainfall during the period of Bengal that we have. So when we plot them, we find that there is a fantastic statistically significant also correlation between phase speed anomaly and delta 18 anomaly, and there is a negative correlation between delta 18 anomaly and rainfall anomaly over the Bay of Bengal. So in a nutshell, we can tell that more rain over the Bay of Bengal and slower convective phases leading rise to more negative isotope values. Now, why it is so, the physical process may need some explanations. So in isotope values, generally when it evaporates, the lighter isotope values prefer to go into the vapor phases, and during the condensation on the opposite, on the other processes, the heavier isotope prefer to go into the rain phases. So if there is a more rain over the Bay of Bengal during the convective phases, we will get a more isotopically negative vapor at the coast, and therefore this negative isotopic vapor will give rise to more negative rain in the study area. So that is the physical processes which is actually explained by the results. So apart from that, we actually plotted the stratiform rain fraction with our oxygen isotope values, and we find a statistically significant negative correlations. Although in the model the relation is found to be very weak. So here also there is a published literature already that it shows there is a large variation of stratiform fraction and delta 18, but they are negatively correlated. It is all over data. So we found that in our area, apart from monsoon interseasonal oscillation, stratiform rain fraction also significantly controls the rain isotope variability. So this is our observation and model delta 18 data are plotted, and you can see that general circulation model has some correlation with the observation, but it is generally weak. Even if we take out only the convective phases, still the correlation doesn't improve much. So our major conclusions are that the oxygen isotope variability within the convective phases of monsoon interseasonal oscillation depends on rain amount and phase speed over the Bay of Bengal. Apart from monsoon interseasonal oscillation, stratiform rain fractions, even during the convective phases of monsoon interseasonal oscillation, significantly control rain isotope variability. And lastly, ISO-GSM simulated rain isotope values weakly correlated with observed values and stratiform fraction. So these are part of the results which we published recently. And thank you.
Thank you, Saika. Good presentation, good study, a lot of new directions. By the way, this data that you are using, is this part of IWIN program data that is used, or you are aware?
No, IWIN program I know, but it is a separately we have collected during my PhD study actually, and that we continued in IIT Kharagpur.
Good, because the time period almost overlaps with that time period, but this may be a separate site and separate places.
Separate sites, and the 2004 and 5, this partly data we published long before when IWIN started even.
Very good. Thank you very much. Thank you. So we go to the next one. This is Nellipudi Nanaji Rao. Yes, he is there. Nellipudi Nanaji Rao.
Yes, sir.
Yeah, very good. Please go ahead.
Sir, is it clearly?
Yes.
Thank you very much, sir. Good afternoon to you. Very good afternoon to everybody. Thank you very much for this arranging the sessions. Myself, Nanaji Rao from NARL, and another co-authors, Dr. V.S. Babu from NARL, Dr. C.V. Srinivas from IJCAR. Now, I would like to present the impact of surface roughness parameterization and prediction of tropical cyclones using the coupled ocean atmospheric model. These are the objectives of the present study. Studied the sensitivity of tropical cyclone predictions in the coupled atmospheric ocean model. For this, we have used a WARP model and a ocean mixed layered model. And another experiment to surface fluxes parameterization is examined for a group of 7 tropical cyclones in the North Indian Ocean. The main purpose of this present study is to understand the role of ocean surface flux exchange coefficients of drag and moisture enthalpy and the tropical cyclone formation, development, and intensity. For this purpose, we have chosen 7 tropical cyclones like Failin, Lehar, Hudud, Varda, Gaza, Fani, and a recent cyclone in 2020 Amphan cyclone, which are formed in the Bay of Bengal. Data we have collected from the for the validation of model central sea level pressure and maximum sustained wind data, and taken from the IMD, and best track model simulated path compared with the IMD best track data, and precipitation predicted precipitation compared with the trim precipitation, that is 25 km horizontal resolution, and calculation of moisture, wetland integrated moisture convergence and transport, moisture transport for the parameters horizontal wind, meridional wind, and temperature, relative humidity, and sea level pressure data collected from the ERA 5 data. This is collected wetland integrated calculation from surface to 300 hectopascal level. For model, atmosphere model, for WARF model, we have taken the initial and boundary conditions collected from the ends of GFS data, which is available at 25 km horizontal radiation. And for the ocean model, initial conditions collected from the HICOM. This is the ocean model.
Further model configuration is ocean mixed layer model is a coupled model with a WRF model. This the ocean model is a ocean mixed layer model. For examine the influence of coupled model dynamics and oceans feedback process. And next, we have conducted a series of experiments for the exchange coefficients like drag coefficients, moisture enthalpy coefficients. These exchange coefficients are enabled in the atmosphere model. The model is designed with two interactive nested domains. First domain is 9 km and second domain is 3 km. Vertical resolution is 70 vertical levels. In the ocean mixed layer model, included in the drag coefficient, because of drag coefficient, moisture enthalpy coefficients, these are the plays key role for the formation and development and intensity of tropical cyclones. Because of latent and surface heat fluxes plays a major role. In ocean mixed layer model include the drag coefficient. And atmosphere model, this is the atmosphere model. And atmosphere model, three options is there. These three options include the drag coefficients and moisture enthalpy coefficients. These are included in the atmosphere model. Therefore, we have chosen the for ocean mixed for coupling of ocean model. We have chosen the ocean mixed layer model. And another part we have chosen. We are studying the exchange coefficients, drag coefficients, and enthalpy coefficients to impact on the tropical cyclones. In these two equations included in the WRF model in the recent versions. In the first one is option 1, so option 2, option 2. In first option 1 include the Garrett drag coefficient and moisture enthalpy coefficients, and next one is Donnellan and constant. Moisture enthalpy is constant. But in option 2 include the Donnellan drag coefficient and Garrett CD. These are the results. First one is 7 tropical cyclones movement. These are the movement. 7 tropical cyclones track compared with the IMD best track, and black color is IMD best track, and red color is option 0, and blue color is option 1, and option 2 is green color is option 2. Clearly here we can observe the first 42 hours there is no difference sensitiveness between the three options, but after 42 hours we can observe the lot of difference between the three options. Clearly we can observe WR of OML mixed layer model, coupled model option 2 predict very well for the post monsoon cyclones, but WR of OML option 1 predicted very well for the pre-monsoon cyclones. This is the vector track errors in kilometer for simulated cyclones with surface flux parameters. Clearly here already I said up to after 42 hours, we don't have observed any difference. But after 42 hours, clearly we can observe a lot of difference. Here, clearly we can observe for M1 cyclone, Fani cyclone, these are the pre-monsoon cyclones. For pre-monsoon cyclones, clearly you can observe option WR of coupled model with option 1 producing the less track errors. But post-monsoon cyclones of Phylline, Lahar, Hudud, and Warda cyclones, clearly we can observe option 2 producing the less track errors. This is the intensity of simulated tropical cyclones. These are the for the coupled model response very slow up to the 42 hours initial time. But after initial time, attending initial time, we can clearly observe the lot of difference between the three options. But in between three options, option 2 gives the less errors for the post-monsoon cyclones. Clearly, we can observe coupled model can capture the deepening and mature stages. This is the sea surface temperature. Passes of tropical cyclones leave footprints on upper ocean surface because of deepening of maxillary depth and cooling of SST. Here we can simulate sea surface temperature anomaly with coupled model and the surface plexus coefficients, and these model simulated sea surface temperature anomaly compared with special sensor micro imager satellite SST anomaly. Clearly we can observe passage of tropical cyclones on the upper ocean surface. It causes to reduce the cooling of sea surface temperature. Coupled model clearly coupled model can able to predict the cooling of sea surface temperature. For filings, but Amphan cyclone, this is the super cyclone storm. Clearly, we can observe in an observation figure, more spatially and intensity, more cooling of sea surface temperature along with the track. However, these three options also well predict the cooling and intensity of the sea surface temperature. Cooling of sea surface temperature is depending upon intensity of the tropical cyclone due to the upwelling. Therefore, cooling of sea surface temperature. Clearly, you can observe for Phylline cyclone it is a pre-monsoon cyclone, post-monsoon cyclone. Amphan cyclone is a pre-monsoon cyclone. For pre-monsoon cyclone, option 1, WROML option 1. Clearly producing the intensity and spatial extension of sea surface cooling of SST. This is the moisture convergence, wet integrated moisture convergence, wet integrated moisture convergence and wet integrated moisture transport. Well, estimate to the prediction of precipitation. Therefore, prediction of precipitation is depending upon the moisture convergence and moisture transport. This is the wet integrated moisture convergence. For moisture convergence, clearly we can observe in the more moisture convergence, accumulated moisture convergence occurred at the left side of the cyclone track. But here in Hudud cyclone, moisture convergence around the near to the landfall because of Eastern Ghats. But in Fani cyclones, clearly we can observe along the moisture convergence accumulated along the track. But in moisture convergence, there is no difference between pre-monsoon cyclones, post-monsoon cyclones, depending upon surface plexus. But in clearly you can observe option 2 experiment while producing the moisture convergence in the case of predicting the moisture convergence. Why option 2 producing moisture convergence compare for convergence compare the intensity and track? Because of in option 2 including the modification of moisture enthalpy exchange coefficients with Donnell and drag coefficients. That's why option 2 experiment giving the results for the moisture convergence with coupled model. This is the precipitation estimation of precipitation. Already I said estimation of precipitation is depending upon the estimation of moisture convergence and moisture transport. Here clearly we can show the clearly you can noted the option 2 experiments while producing the predicting the precipitation. These are summary of conclusions. Coupled ocean atmosphere model and sensitivity to the roughness schemes significantly influence on the tropical cyclone forecast. For all the case studies, for surface roughness experiments depict the main track error are like this, but option 2 experiments giving the well results for the post-monsoon cyclones, but option 2 experiments, option 1 experiment giving the gives the good results for pre-monsoon cyclones. But in the case of moisture convergence and moisture transport and predicting of precipitation. Option to WR of OML option to experiment produce the well results because of modified CK included in the Garrett equations along with the dominant momentum. Therefore, option WR of OML option to gives the better results for the precipitation. These we have these surface enthalpy coefficients included in the newly versions of WRO model, and OML model we have coupled. Thank you.
Thank you, sir. Thank you very much. There is no question from any participant.
Thank you, sir.
So we'll move to the next presentation, which is by Karivula Narayan Reddy on flavors of El Nino and associated genesis with a special emphasis to 2006-7. So yeah, over to you, Mr. Reddy.
Yeah, thank you, sir. So is it audible?
Yeah, very much.
Yeah. I am Narayan Reddy, and my work is related to the flavors of El Nino and associated genesis with special emphasis to 2006-7. I did my work at IITM Pune under the guidance of Anand Parekh, sir. So I am going to the introduction. So my work related to the El Nino. Everyone, I think, know about El Nino. So I will just conclude what is El Nino. So El Nino is the anomalous sea surface temperature increases over the eastern Pacific Ocean. So that we are termed as a El Nino event. But the condition is continuously 3 month running mean continuously 5 months. Magnitude is more than 0.5 SST anomaly that we are known as a El Nino event. So one of the main precursor of the El Nino is the westerly wind event, which excites downwelling Kelvin waves over the western Pacific Ocean, western equatorial Pacific Ocean. So which can propagate all the way to the eastern part of the basin. They can deepen the thermocline, potentially initiate an El Nino event. So in this study, I used era 20th century and era 20th century zonal wind data and ERSSTL SODA and era interim and ORS data are used. And my main objectives are variability of El Nino and La Nina from last century, the genesis of El Nino with precursors of warm water volume and westerly wind event, the dissimilar spatial pattern of 2006-7 El Nino and sensitivity experiments. So coming to the variability of El Nino and La Nina from last century. So this is the variance plot. So epocally, last century divided into 4 epochs in each 30 years. One is 1895 to 1924 and 1925 to 54, 55 to 84 and 1985 to 2014 and the total period. So from this panel, so the variance is increasing and extends westward with time. So coming to the right hand, so the epochal variation of El Nino and La Nina events. So the El Nino events from last 2 epochs, it seems to be same, but the La Nina events are increased. So coming to composite, epochal composite. I took one epoch and each El Nino event I was composite whatever formed in that particular epoch. So this is the SST anomaly is increasing in recent period than earlier. So this is the Nino 3.4 SST anomaly time series, and the below plot is longitudinal variation of SST anomaly in epochally. From here, there is a westward movement of the SST anomaly increased. See here, there is more. And coming to the La Nina, it was decreased and it was shifted to the eastward La Nina intensity. So from this plot, the La Nina intensity is more during recent epoch than earlier, but La Nina is decreasing. But I did mainly focused on the El Nino event. So I took 2 precursors. So that is object 3. So one is warm water volume and another one is westerly wind event. So the warm water volume is the equatorial Pacific Ocean, the D20. So thermocline depth D20 and with integration of the longitude and latitude for the equatorial Pacific Ocean. So this is epochally, it is decreasing more in recent epoch warm water volume. It is also composite of El Nino events over the particular epoch. So the lead lag correlation between Nino 3.4 anomaly and warm water volume anomaly is 0.45 in the lead of 5 and 6 months. So from this the variance SST is more, but we cannot say using warm water volume it is increasing, but it is decreasing. So I took another precursor, that is westerly wind event. So the westerly wind event plays a vital role in the El Nino formation, as I said before in the introduction. So the westerly events are classified in 3 types. See here, W, C, and E. So I defined as so everyone in literature saying is 2 days zonal wind anomaly more than 7 meter per second is enough. But I am saying that it is compulsory for 5 and with exceeds 5 meter per second. That I termed as a 1 event. So I will more dig on that. So zonal wind anomaly at 10 meter height or these regions exceed 5 meter per second continuously 5 days. It is considered as a 1 event. I computed using daily data from 1900 to 2010. So it is the from that period 111 years I divided to 2 periods. One is 1900 to 1955 and another one is 1955 to 56 to 2010. So the seasonally this more occur in boreal winter season. So coming to time series of the westerly wind event, it shows the bar diagram indicates number of westerly wind events that occurred during the particular year. So from last 10 years, it was very less events was found, and these events are occurring before the onset of the El Nino. However, there are some events, there is no westerly event, but the El Nino was found. So during the study period, C-type and E-type events are reported, followed by the E-type and W-type events. So there is no westerly wind event, even though El Nino was found. Those are reported 5 events. Those are one is 1911-12, 1953-54, 1963-64, 2004-5, and 2006-7.
Your internet has some problem, probably. You can mute your video.
Six was checked more.
Yeah, Mr. Reddy, please switch off your camera because your bandwidth has some internet speed has some issues.
Yeah, is it audible? Sorry, sir.
Yeah, now
Is it
audible,
audible?
yeah. But not.
Yes. In 2006 shows. In 2006 shows different and maximum SST are placed in 2 areas. So I do analysis about 2006-7 and 2006-7. See here, it is Nino 3.4 index and the longitudinal variation anomaly. So what the literature is saying about 2006-7 is Murphy et al. And Arnold et al. Saying that is a warm pool El Nino. So warm pool, Central Pacific El Nino, dateline El Nino, both all are same. And one person is saying canonical El Nino event. So I did composite analysis about the 2006-7 El Nino. So the composite analysis between canonical and Modoki and 2007. See here in canonical El Nino, it shows that sea surface temperature anomaly is situated in the eastern Pacific. In Modoki El Nino is situated in the only near dateline. But in 2006-7 shows that there is a 2 SST anomalies more than 1 degree in 2 different areas. One is eastern Pacific and one is central Pacific. So even it is a zonal wind anomaly. Hand panel. See here, in 97-98, it is the strongest El Nino in this long century, recent century. See here, there is a more westerly winds are occurred, and 91-92, it is only 3 events are occurred. It is the strongest El Nino event. But in 2006-7 case, in 2006-7 case, it is like there is no westerly wind event, even though El Nino. So it is like quite surprising how it was formed to now. So, but it seems to be different through some how it was created or formation. Through it is different than others. It is a homolar diagram SST anomaly. The canonical and central is a Modoki and the 2006. The formation also it seems to be different, and even SSH anomaly also shows that different. But the Kelvin waves propagation from the Western Pacific Ocean to the Eastern Pacific Ocean, see, this is more. But even but the SSH anomaly or what we call as downwelling Kelvin waves, it was propagated or started from the Central Pacific Ocean in near. So in canonical, but it is very weakened in the Modoki El Nino. But in one case it is more. Even warm water volume also it is shows that there it is different others. So these results oceanic feature shows that it is. But even though Walker circulation, I was looking into the atmospheric connections. Those are Walker circulation. I plotted this. Above first one is 2006-7. It shows that there is a two limbs. One is at near day, one is at Eastern Pacific. Shows that there is a two places a rising motion. But in canonical there is one area, and in Modoki also there is one area. But even 6-7 is two areas it is showing. So these results either wind is really forcing or really acting as a factor to formation of El Nino. So I did some model experiments. So this is the model experiments. So 2006-7 and 97-98. So I used MOM5 model. So after 50 years of I do control run, which is forcing files are corrector interval forcing, and used zonal and meridional components from ERA interim. So this is the control run. So control run are also able to capture there is a two anomalies is more in two areas. Even it is slightly, but in control run El Nino was not found. And then I are influencing or not. I did some sensitivity experiments. So in 2006-7 I applied 97-98 zonal and meridional winds. In 2006-7 oceanic features. See the experiment one. It is also 2006, but I applied 97-98 winds. So there is a canonical, strongest canonical El Nino event was found. In experiment 2, I applied 2006-7 winds to the 97-98 ocean features. So it is like very weak El Nino is found. So I am concluding this objective is, so winds are really forcing, and especially the westerly wind events are forcing or initiating the El Nino event. So my conclusions. So more than 100 years of SST and zonal wind data and modeling experiments have been analyzed to study variability. So spatial pattern of SST variability clearly brought out that Eastern Pacific has SST variability and displayed westward extension with time. And it is noticed that in the recent year, the C-type westerly wind event E-type and playing a role in El Nino formation. And 2006-7 El Nino formed in the absence of westerly wind event, and it was neither canonical or El Nino Modoki. It is shown different kind of spatial and temporal features, and model experiments revealed that absence of westerly wind leads to the formation of unusual pattern, especially this kind of mixed type, and they place your thermal structure into spatial pattern of Eastern Pacific plays a role in thermostructure in 2006-7. Thank you.
Joshi sir?
Yes, go ahead.
Yeah, actually there is no question from anyone. So
okay.
So we'll move to the next
This
presentation.
study was good. A lot of data he has used and good analysis has been made. Good presentation. Move to the next one. Kundu, go ahead.
Yeah, so our next presentation is by Pratibha Gautam. And the title is Understanding the Role of Land, Ocean, Atmosphere Interactive Process in Monsoon Intra-Seasonal Oscillations. Over to you, Gautam.
Hello.
Yeah, you're audible and your presentation has also come. Please go ahead.
Okay, thank you, sir. Good afternoon, all. I am Pratibha Gautam. Currently, I am doing PhD from IITM Pune. So my topic is understanding the role of land-ocean atmosphere interactive processes in the monsoon intra-seasonal oscillation. So, as we know that Indian summer monsoon is one of the most important land, atmospheric, ocean coupled climate system over the tropics, and it is generally accepted that ISM low frequency variability in the land ocean atmosphere system can be generated through the interaction between its component. Since many of the study they have more focus on the role of SST in predicting the ISMR and its variability. Study by Sharmila et al. They have shown the role of SST and the ocean heat fluxes has a strong role in the phase propagation of monsoon interseasonal oscillation over the ocean. Now the next question is there any similar role of land surface fluxes or parameter in the phase propagation of meso and its intensification? So, according to the atmospheric water budget equation, the change in precipitation is contributed by the change in evaporation, and the change in the moisture divergence term. And this change in evaporation is further linked to the albedo, roughness, soil wetness. And the second term, that is moisture divergence term, is linked to the local circulation and the large scale dynamics. And this change in precipitation is linked to the cycle. If we change the land surface state, let's say change in the soil, water, vegetation. So further it will change the evaporation sensible heat fluxes. Again, it will lead to change the humidity, temperature, wind profile. Further, it will change the precipitation pattern over that region. And change in precipitation will further change the land surface state. So it is a kind of feedback process. Here in this presentation, the second term we are denoting as a delta F. So if we transform this equation in frequency domain, here I have plotted the time series of standardized anomaly of rainfall and its power spectra. Similarly, I have plotted for evaporation also. So from this power spectra, we can see in rainfall, we can see it has a significant low frequency variability around 40 to 50 days. Similarly, we are getting evaporation also. So since the second term, that is moisture divergence term, is already known to predict in the precipitation, and in power spectra of evaporation we are getting low frequency variability, hence it can be used to predict the monsoon rainfall. And this statement also shown by Dreamer et al. That land state can also provide the predictability in weeks to month, that is in S2S time scale. So to understand the role of land surface in monsoon intra-seasonal oscillation, we are using IMD data and air interim reanalysis to calculate the lead lag analysis and the spectral analysis. Also, we are using a land information system, list framework. In list framework, we have different type of land surface model like NOAA, VIC, Cashmere. So in this presentation, we are using NOAA model. For that, we are using GDAS as a meteorological forcing, and these are the fixed file for the model. And output, we will get the energy fluxes and surface runoff as a output. So we have seen in many studies this delta P and delta E relationship is already known for ocean fluxes. Study by Sharmila et al. They have shown the net heat fluxes over the ocean. It acts as a preconditioning term for the monsoon intra-seasonal oscillation. Now we will see how is this relationship over the Indian land. For that, I have analyzed. The lead lag relationship between evaporation, temperature, specific humidity over the different parts of India and over the Bay of Bengal during the JJS active days. And these active days are identified with respect to the region identified. When the standardized anomaly of rainfall is greater than 1, then it is considered as the active days. It is based on the filter data. 20 to 100 is filter, and here day 0 represent the rainfall maxima, and this green represent the temperature, this red line represent the evaporation, and this blue line represent the specific humidity at 850 HP. So from this lead lag relationship, we can see that before the rainfall maxima, there is a peak in temperature, and this peak is different over the different region. Here I have plotted the combined plot for evaporation over the all 5 different regions. This bold line represent over the Bay of Bengal, and this all 4 represent over the 4 different Indian regions. And this is also for a combined plot for specific humidity. So from this plot, we can see that this relationship is different over the ocean and over the Indian landmark. So we can see that before the rainfall maxima, there is a peak in temperature. So it suggests that land surface can have a preconditioning role of low frequency variability that is 20 to 100 days over the Indian region. And this preconditioning is different over the different region. So to get the proper low frequency oscillation over Indian region, we need to understand this land atmospheric coupling in the model. For that, I have analyzed the impact of land atmospheric coupling in the in the land surface model. Here we are using NOAA list. So I have plotted here the surface runoff during the active and break phases. This is from the NOAA model using GDAS precipitation, and this is from the ERA reanalysis, and this is the difference between model minus observation. So in difference, we can see that there is a positive huge bias in runoff over the many different parts of river basin and over the center, over the northeastern area also. Further, I have analyzed the co-spectra plot during the May to September over the one river basin, over the Mahanadi river basin, and over the northeast India from the list from the model and from the reanalysis data. So this is the co-spectra plot between soil moisture and specific humidity. So from this plot, we can see that there is a shift between the model and the observation, between the reanalysis. And below the 40 days, mostly they are in out of phase, because in model we are getting mostly they are in negative. So and between to 40 days, between to 40 to 16 days, they are showing in phase relationship, but it has very low amplitude. So overall, we can see that model and reanalysis are not in same phase. So the conclusion of this study is both the ocean fluxes and land fluxes play an important role in preconditioning of monsoon intra-seasonal oscillation. And to improve the sub-seasonal variability and its prediction scale, we need to understand the link between ocean, land, atmospheric processes. Acknowledgement. I would like to acknowledge the organizer and coordinator of the symposium, Indian Meteorological Society, and the director of IITM Pune. Thank you all.
Thank you, Pratibha. Good presentation.
Thank you, sir.
Yeah, Kundu, go ahead.
Yeah, and then we don't see any question also for her. So then we'll move to the next presentation, and in fact the last presentation, because the number 9 is by Dr. Ishiparna Guho, and he is not available. So we'll move to the last presentation of this technical session by Ananya Karmakar, and this is on thermodynamic wave train connections of monsoonal heating to the Canadian Arctic in NCMR-WF unified model forecast. So yeah, we can see the presentation. So over to you, Ananya. We can't hear you.
1 minute, sir. Sorry.
Yeah. Can you speak a little louder?
Yeah, is it clear, sir?
Yeah, it is fine now. Fine now. Go ahead, please.
Okay.
Make it a full screen slideshow mode.
Yeah. Sorry, sir. I'll start my video also. Yeah, is it visible now, sir?
Yeah, visible. Make it slideshow.
Yes.
Yeah. Please go ahead.
Okay. So good afternoon to everyone. Myself Ananya Karmakar from NCMR-WF Noida. Today I'm presenting the topic thermodynamic wave train connected towards the monsoonal heating to the Canadian Arctic in the NCMR-WF unified model forecast. So starting with the introduction and the objectives. Medium range forecasting of the monsoonal and its teleconnection to the both poles is of the great interest to the scientific community, but such relationships remain unexplored in the forecasting systems till yet. So the objective is to study the teleconnection of monsoonal heat and the generation of wave trains towards the Arctic region for extreme rainfall events from the INSWAM forecast system. This is the objective of our study. And for this study, we have used the unified model version 8.5 system at INSWAM WF at 17 kilometer resolution. And the analysis and the forecast for the lead times day 1, day 5, and day 7 valid for the time of the heavy rainfall events are used in this study. To validate this model outputs, we have used the ERA interim datasets. Daily long-term mean has computed from the ERA interim long-term datasets, that is 1993 to 2017, almost 75 years of the data. And to understand the monsoonal heat wave train in for towards the Arctic, we have computed the moist static energy at the level of 300 hectopascal and vertically integrated from the 100 to 1000 hectopascal from ERA interim and in our interim analysis as well as the forecast. So how to select how we have selected this heavy rainfall event for 2017. The national snow and
Yeah, Ananya, you are not audible.
I think we lost the connection, seems.
Yeah. You can stop your video. So only just keep
May not
the
be,
audio.
now somebody has to inform her actually.
We are informing. Otherwise, maybe she has to again share. वही low bandwidth. And actually, we lost connection in between.
Ma'am,
So
please switch off your camera and
okay,
share
okay.
your presentation.
Yeah,
Please switch off your camera.
Okay, fine. Should I switch off my camera, sir?
Yeah, better because bandwidth issues are coming. So you can switch off your camera. After that, you share your presentation. After that, you share your presentation.
Okay, fine, sir, fine.
Yeah.
Fine.
Yeah, it is coming.
Okay, sir, am I audible now?
Yeah.
Okay.
Yes.
Okay, fine. So now next we are seeing the moist static energy anomaly during the for this 29th August 2017 rainfall case. So this figure is left-hand side figure is showing the moist static energy anomaly from the ERA interim data set, and this is showing from the INSWAM analysis is our data set. And this right-hand side figure, we are seeing the this moist static energy anomaly for the INSWAM day 1 forecast, day 5, and day 7 forecast. So from this figures, it is clear that this MSC anomaly wave trend during this 29th August in ERA engine, this is becoming weaker during this the forecast lead time in our INSWAM forecast days, day 1, day 5, and day 7 forecast. Next, this is the similar figure as we seen earlier for the 29th August case, but for the 4th February 2017. So in this also, this positive wave trend, moist static energy, this anomaly, this is which we see in the era interim, this is becoming weaker for the forecast lead time for day 5 forecast and day 7 forecast. But for this case, this 4th February case, this is this western towards the Arctic is better captured than this summer monsoon time, which is the 29th August 2017 case. So why this weaker western is there for the means how much this weaker in the 29th August case, to see the we have made the trajectory analysis for particularly for this 29th September 2017 case. Mostly this trajectory are used to track the forecast of air mass movement and to account for the uncertainty in the associated wind patterns. So this figure, this left-hand side panel, is showing the trajectory for from ERA interim datasets, and this right-hand side panel of the figure is showing the our interim analysis interim forecast trajectory. So from this, you can see this the ERA interim trajectory could reach up to this Canadian Arctic, whereas this interim trajectory displays over this 10 days trajectory. Over this 10 days, this parcel could reach up to the halfway to the Arctic, for this interim forecast. So this is much weaker. We can see this western is much weaker from this trajectory analysis. And why this is the means this weaker, the reason behind this, for to know the reason behind this, we have done the component analysis, means each component of the moist static energy terms. So first component of the moist static energy, this figure is shown for the 29th August 2017 case, and this is figure is for is the difference of the each component of the moist static energy term of interim for our data set. So with respect to the ERA interim, and this is the first component of the geopotential height. This is for the temperature, air temperature component, and this is the third component, which is the latent heat component in the moist static energy term. So from this figure, we can see that this is the analysis, interim analysis difference, and this is the day 1 forecast difference from with respect to the ERA interim. And this is the similar figure as the above one, but with for the 4th February 2017 case. So from this, we can see the this interim latent heat, that is the third term, which is that latent heat term of this moist static energy term. This third term is showing the gives a negative impact on the total moist static energy anomaly wave train, whereas this is the positive in the ERA interim or the observation in that. So next, now we are seeing the latent heat.
Ananya, you are again not audible.
From this is clear that, hello?
Yeah. In between there was a break.
Okay,
Yeah, you can continue. Continue, please.
Okay, fine, sir. So now, from this vertical distribution of latent heating term, this is clear that the interim analysis and forecast is formed less cloud at the mid-troposphere, and hence this is hence the less heat generation over the northern India and the Pakistan region. So to understand the this wind pattern during this event, we have plotted this difference of the interim and ERA entering 500 hectopascal wind. Suppose we can see this is for the 29th August case. In this we can see this anticyclone over this region is this is weaker in the NCM, and the pathway is also much more weaker for in.
Ananya, you are not audible. Can you hear us? Video with you.
Almost she has completed. I think only concluding slide is required.
Right, sir. Yeah.
She has some problem with activity.
Some bandwidth issues are coming
Yeah.
repeatedly.
If you are able to hear, you just show the concluding slide. I think mostly you have already gone through, everything is over. If you are able to do that, otherwise we have heard it. No?
Are you there?
So we can assume she's coming.
Beat map project, and I'd like to thank the Tropmet 2020. Thank you.
Very good, very good, very good. There are some issues of the connectivity.
Video de do.
Okay.
It's okay. It's okay. Don't worry. It's okay. It's all. Because you are almost finished. In between, little bit was right. Thank you very much. Good presentation.
Okay, thank you, sir.
You have all the way
Thank
gone
you so
to
much.
the architect, from Delhi to architect. So it's a great thing to see, right? Good, good. So I think this is the last. This was the last presentation, oral presentation of this session.
Yes, sir. This is the last one.
Yes, yes. We had a very good session. Started with Mitra, who gave us a good glimpse of the NCMR WF. Actually, we started with NCMR WF. We are ending with NCMR WF. That is how it goes. So Mitra told us about the day to season, all the progress they have made, and the different variety of applications they have made, and good presentation were made. And then subsequently there are many presentations on tropical cyclones, certain simulations, certain parameterizations, then schemes, impact of them, certain data assimilation, and some papers were there on the ENSO, different type of the impacts they have on that, different simulation. Also on the IOD, different IOD impact on the rainfall. So overall, this was a good land-ocean atmosphere interaction. Quite a bit of that we could see in this. So immediately after this, we have to go for another session where I am again supposed to go. So I am ending here. I thank the organizers for giving me the opportunity. Kuntu may like to say something to conclude.
Yeah, I think, sir, you have already covered the spectrum that is covered in this technical session. And I'll just again take this opportunity to thank all the speakers for sticking to time. Mostly we are on time. Thank you, everyone. Over to you, Rekha.
Yeah. On behalf of IMS Shillong chapter, I just want to convey thanks to the chair of the session, Joshi sir, for taking out time and chair the session. Indeed, a successful technical session with series of presentation on different aspects of land-ocean atmosphere interactions. And thank you, Kundu sir, for co-chairing the session. With this, we come to the conclusion of today's third technical session. Now we will move forward towards
4:30.
So that is at 4:30, right?
4:30.
So 10 minutes tea for us.
Yes, sir. Please, sir. You need certain
Okay.
minutes. I think your
Okay.
link can remain, sir. Probably. Yeah.
Okay. Only as I said, I will need a. You have to give me the permission for sharing a small slide.
Yes,
I will make.
Yes, yes,
Okay.
yes.
Just 5
Yeah,
minutes back, and I am coming back.
Yeah, Alcord, who is there? Please note that Joshi sir will first because he will be chairing the next session. But while chairing, please give him sharing rights. He will give a very small presentation, and after that, the actual presenter, Dr. Rupa Kumar Kolli, will take over.
Okay,
Please
sir.
note. Yeah.
Okay, sir. Noted.
Yeah. Thank you. Okay. Anyway, there is.
Hello, Patnaik. How are you? You're muted.
Yeah, good afternoon, sir. Good afternoon.
Good afternoon. So, how are things? How many people are actually listening or participating?
All these sessions are now actually the registered participants more than 300, and the paper printing only registration for attending another 100 150. And we have also put in our YouTube.
Okay.
So that is separate. That only Himalayan health things are broadcasted in that YouTube. These are not all. So yes, so I think good. It is going on smoothly. I think there is not. We are getting good response. People are happy. We all talks again. Everything will be available also in our site. All
Very
the
good.
house, everything.
Very good. Very good.
So that is
Yeah,
also.
NASDAQ has done an excellent job.
Yes, sir. Yeah, this is the first really such a large scale. This is the first time a virtual event in this scale.
Yeah, you're doing very well. Actually, technically, it is, I think, of high quality. So that's nice.
And yesterday I wrote a mail, but I didn't get response. So probably they are not comfortable timing.
Actually, they just went from Pune to Seattle. It seemed they reached yesterday at 4 p.m.
Oh.
So, in fact, Saurabh Pant actually wrote to me that he is very happy. So I think he said they will try because it's 3 a.m. in the night now, so it may be difficult.
Yeah.
Hello, Joshi sir.
Hello, Rup Kumar. How are you?
Good. How are you?
Good. In fact, it doesn't look that we have not met because last couple of weeks I have seen you in webinars, different places.
Yeah.
So it looks like this COVID is actually very helpful.
Yeah. We are connected physically, not physically, but cyber connectivity.
Cyber connectivity, yeah.
But one thing, good thing happening, sir, for Tropmet that actually during Tropmet physically, after the first day something in our session, very less people are physically attending. But now it is more attendance.
No, you do not know also how many are attending. So you assume this is 300, no problem.
No, but at least no what at least in our section, let us say in our section 10 students are there. Everybody watching from morning to evening. I am seeing here.
True. So Rukumar, they have at 5:30 they have scheduled another IMS-GB meeting probably.
Yeah.
Correct?
Yes, sir. Yes, sir.
I'll take some 10, 12 minutes I will take. And then Rukumar, then is that okay? You can finish in 45, 50 minutes?
Perfect.
Okay.
In fact, that will be the right sequence actually. No, you are so close to Pansar. So
That's why we selected him, sir, for this one.
yeah, of course. He is family. So it is a natural sequence.
Toward the end, I actually we have some photographs of Pansab attending that Banaras Tropmet. He could not attend so I can share that one. Just I have two slides something there. Because
I have included that in one of my. You need not do that. If you want to do it, you can do it.
Yeah.
I had few slides, so few photographs. So at the end, I am including Patnaik's photographs.
yeah. So let us see, just confirm. We have to check once that other two parallel sessions are over. Let me find out.
Yeah, that is important because this is plenary, no? So,
this is the main hall, no? Yes.
Yeah. So if they are delayed, maybe we can.
2 minutes. Yeah, other two panel sessions.
Yeah, Dr. Kundu.
Yeah, just 2 minutes, sir. I'll confirm, sir.
Yeah, just please confirm.
Yeah.
Today morning we had just 2 minutes that tribute also. We pay tribute to Professor Narasimha.
Yes. We saw that. We are attending.
Yeah, that's because it was morning.
When did you pass away?
Yesterday, late Monday something you returned. Exact timing I don't know.
2020 is turning out to be a very bad year.
Yeah,
So many departures. So how are you, Joshi sir? You are mostly at home or?
Yeah, at home.
Yeah, home kind of confined.
I have come to Ahmedabad now. Yeah. In fact, today morning, Mrs. Pant talked after reaching there.
Yeah, she sent me a message that they reached 4 p.m. yesterday. So
yeah. Today morning she gave a call, so they are fine. They have reached. They are settled down.
yeah, I sent a message to Saurabh about this talk, but it is 3 a.m. for them. So I told them that we'll send a video recording. Maybe the entire session, including Joshi Saab's presentation. I think if you, Patnaik, if you can click, you are muted, I think.
YouTube link is already there. So, but
not that way. If you can clip this part separately,
yes.
If you can take a clip of that, then we can send it separately.
Yeah, we'll do that. Sir, that will.
Otherwise, if they go to YouTube, they have to find out exactly where this is.
Yeah, correct. No. We'll cut that part, that person and send.
Yeah, sure.
So, Rup Kumar, you are in office or?
I am at home. Actually,
Okay.
My daughter has come from New York.
Oh.
It's Saturday, so we have to actually, she has to do 14-day quarantine.
Oh.
So along with her, we also have to do.
Oh, yeah. Okay.
Actually, there is no difference. Even if I go to office, so I'm confined to my room and I cannot meet anyone. Nobody can come to me. So there's absolutely no difference.
Yeah. That's why this WFH is very popular now.
Yeah.
In newspaper, I saw many. What is this? Then later on, I realized WFH is work from home.
Yeah.
So this WFH is working well now.
Working well, but people are actually feeling the pressure also because since everything is electronic, but we cannot act in that speed. So our speed is human speed.
Yes.
So things keep piling up on you.
Yeah.
That is why people are actually saying that they are doing more work if they are working from home because there is no time schedule concept. So things can come to you at any time.
Well, that will be quantity, but it definitely impact on quality because physical work is anyway different type. Quantity, yes. That's why IT is so good. There is no problem for IT people.
Yeah.
Looks like still sessions are going on other halls.
Slightly 10-15 delay, there is no issue for that. That's right.
In the other hall, this Himalayan hall, I was the session chairman, so I made it to see that everything is over by 4:15.
Yes. So now this experience shows that such a big event, 3-4 days international conference can be arranged virtually.
Yeah, but one important aspect of conferences, that is people talking to them, interacting informally. So that part cannot be replicated online.
Yeah, that's true. That physical interaction is.
Yeah. That social connections are required for people to feel like a community.
That is the reason actually that monsoon, that Warsaw international monsoon also, that is 7, that was initially planned for March this year. Actually IMD means here it will be hosted. So we didn't get, they wanted physically more people. So we have postponed to next year.
Okay.
2020. One maybe around September, something like that.
Okay.
Yeah, sir, actually, Ganga Hall things are finished. But in the Brahmaputra Hall, there are still 2 presentations. So it may take time. I don't know whether you can start this.
Can otherwise one can be summarized something. Can you just test who is the chairman?
Chairman is from NRSC, KHV Durga Rao.
You just pass on the message to him because we are going to start the.
What will you do? I told him that to make it fast, but still 20 minutes to lag jayega. It will be delayed.
20 minutes will be too delayed.
Too delayed. But Ganga Hall is free now. That is over. One hall is over. This is over. So only one hall there is.
Can we know how many people are now this using now attending?
Our host, Webcon Events, can you brief on anything on this? Mute.
Yesterday that memorial talk we had, but that was also good. That timing.
I think GB meeting we have after this.
GB meeting no issue because that's a closing time we have not fixed.
Yeah.
5:30 to 8 we have written.
Mute.
Or you announce 15 minutes late, we will start.
Yeah, another 5 minutes we can start. I think 4:40 now.
5 minutes, just the way he is saying, in 5 minutes it will not be over in that hall.
Yeah, so that's why. Just Durga Rao, no. Let us.
Do you have any mechanism for making plenary announcements when the parallel sessions are on?
They have a provision to notice board that can flash in all the halls.
Yeah, because those who have completed, I think they should know when to come back.
No, they know. They know.
Yeah, but if they are waiting at 4:30, they may not know what is going on.
No, okay.
If people actually come to Himalaya and expecting to start at 4:30, so they don't know what is going on and they may leave.
Yeah, so okay, we can make an announcement here itself.
Yeah, you have to tell them exactly what time this will start.
So, good afternoon to everybody. So, we are going to start our the second memorial talk very soon. So, please join. Maybe another 5 to 10 minutes maximum. We are waiting. So, we will start by 4:50. Okay, 4:50. So, please join at the sharp 4:50 time. All the participants and register participants from different hall, so that we will start our second memorial talk at 4:50.
YouTube live হয়ে আছে
I think, sir, we can start slowly. Say they will join in 5 minutes, so that no issue.
Okay.
Yeah. So, good afternoon to everybody. So now we will be joining for a memorial talk. So now may I request Dr. P.C. Joshi, sir, to kindly chair this memorial talk session. Please.
Okay.
Yeah.
Thank you, Dr. Patnaik. First of all, thanks to the organizers and Indian Meteorological Society having started these memorial lectures. Last year we heard at Visakhapatnam Koteshwara Memorial Lecture, and probably they thought that since Koteshwaram belonged to that department which was organizing, he has done everything, so they started Koteshwaram Memorial Lecture there. So this year we have this lecture, memorial lecture for a Himalayan person who has worked for the Himalayas in Himalaya Hall. So this is a very good coincidence, and I'm very happy to be part of this and remembering a great climatologist of the country, known in will be known in a variety of ways. So, in fact, this is today is 15th December. Dr. Pant passed away on 15th November, just 1 month back. So this is 1 month only is over. And that was at the age of 75. And I will take few minutes before this memorial lecture of Dr. Rupa Kumar to say a few things about Dr. Pant, which I have some information, maybe more than some of you in the audience have. There is a feeling in our meteorological community that Joshi and Pant, they are very close relatives. That's not true. We are that way very distant relative. In fact, I was trying to calculate, it's a 7-generation tree. If you connect there, we will be connected there. But we have become much more closer than the closest relative when I was in Pune or subsequent many years in the meteorological profession or all that. So that it's much more closer than the closest relative. That is, we are as some few minutes back, Rup Kumar was saying, Joshi Sahab is family orphan. That's true. It almost kind of like that. So Dr. Pant comes from Uttarakhand, a place earlier is called Almora district, a place called Khantoli. Now it's a Bageshwar district of the Uttarakhand. And my native place and his native place are very close. I know the whole family so well, the location, everything, culture, everything quite familiar. In fact, the 8 siblings is also sometime he had 8 siblings. So this 8, many times, many places I have heard 8, the 8th one is always a great person. So here also this 8th person was the youngest of the family, and he comes from a very respected religious family in that village. I know practically every person in that. In fact, the eldest one of Dr. Pant's eldest brother, he was the person responsible for the development of the Haridwar, whatever you see today. For a long time, being an administrator in Uttar Pradesh government, he was assigned that task of developing Haridwar, and the Haridwar we see today, the facility, it was all because of his eldest brother. So eldest has also done for Himalayas in activities and the youngest one has done for the science of Himalayas. That is what it comes out to be. So born some 75 years ago in the Bageshwar district, Khantoli village, and he had elementary schooling there only. In fact, I also happened to be the alumni of the same high school that he had gone, but we had no interaction. In fact, my interaction with Dr. Pant started only after I reached Pune. I joined Pune only after that we had the interaction. Anyway, so he was a good student, no doubt about that everybody knows. He had his graduation from the Agra University. He was gold medalist in the Agra University in his master's degree in physics. He passed in 1965. And then subsequently for 3 years, he was involved in certain small here and there lecturership, instructorship, and in fact, he started his career first with the space that UP State Observatory that was called at that time. Now it is called ARIES, Aryabhatta Research Institute of Observational Science in Nainital. He started from there. And again, I am surprised to see the coincidence. He started his scientific career from the ARIES, and last responsibility, what he had, major responsibility towards the end, was also ARIES. He was the chairman of the scientific advisory committee of that institute. And in fact, we learned recently that just a month or 2 months back, he had a meeting of the advisory committee of the institute, virtually, of course. So he started from ARIES, and the major activities, major responsibility also ended with the ARIES. That way, if we come to the Meteorological Society, he has been the president of Indian Meteorological Society. Again, there is uniqueness. Outside Delhi, the president of IMS has been only Dr. Pant after Pisharoti, nobody else. So that itself is a unique thing. He has been the fellow of Indian Meteorological Society. In the beginning, the chapter, Pune chapter of the Meteorological Society was activated under his guidance, and he was responsible for organizing the Tropmet also at Pune. So a lot of activities from the Meteorological Society as related with Dr. Pant. About his scientific contribution, much of this will come from the Dr. Roop Kumar, his closest colleague. He will be telling. So I need not say much about that, but he has been member of the large number of governing bodies of the institutes in the country. Like he was very fond of telling many times whenever we interacted. In Pune, there is an engineering college called Pune Engineering College. They don't have meteorology or, but he was the governing council member for some 10, 12 years. So anything comes to that, as the chairman of the governing council of the Pune Engineering College, he always used to interact with Dr. Pant. Similarly, there is a Wind Technology Institute in Chennai, where he actively participated and had many activities there, activate their institute, and then many Sase, again in Himalayas, coming to Himalaya. He was in the governing board of the Sase, probably even related, even probably if I recollect correctly, he was chairman of the Sase governing board also. Also governing board or scientific advisory board. Like that, beside many institutions advising and giving to that, he has been the initiator of the modern climatology in India. I would say modern. IITM has been doing climatology for a long time, but when he started, he took the leadership of the climatology group. It started getting modernized. The paleoclimatology was started by him. He has been the pioneer of the paleoclimatology. He has been association with the variety of groups of the paleoclimatology. I myself am witness to that. Like he used to interact with the Birbal Sahni Institute of Paleobotany. Even locally, Deccan College, I used to see often his interactions with them. Even in Ahmedabad, Professor D.B. Agrawal from the Physical Research Laboratory, and his activities in the Jammu and Kashmir, those all rocks of that. So I have seen a variety of those things. So that was a new paleoclimatology discipline started. The climatology, normal climatology, modernization started. the seeding for the numerical modeling of the climate, and the provision for the further growth, involvement of the many persons in the climatic research. That was his great contribution, and we'll remember him for those contributions. Needless to say, I'm too small a person to say his activities. He has written 2 books, and the books, I think I had the name of the again, that was Climates of South Asia and Himalayan Climate. He has been in the editorial board of the international journals, national journals. So that way the climatology has been propagated by him to not only within India and to abroad. I was very happy to, just 2-3 days back, somebody was saying that the master of the dendroclimatology, they are exploring the possibility of holding one international conference in his memorial. I was very happy to learn that. Probably the seeding has taken place and it may come up sometime, and we may know even his international colleagues, the collaborators and all others, they may participate in that and know in that. And so this, as I said, I am more of a personal touch. The scientific ones will be more given by I am sure it will come much. What I have learned from the Roop Kumar is one of the things. Now these days we hear too much of IPCC. Dr. Pant was one of the first person to join the IPCC from India. Those time nothing was known about IPCC. We never knew about that. So that is how I say that the message of climatology, the science of climatology. But he was not only a climate. Before he had his PhD on the energetics of the atmosphere. That was his PhD. He came to IITM in 1968 after 3 years of the initial moving around his native place, Nainital, Almora, Delhi. Then he came to 1968 to IITM as a junior scientific officer. 1972, he moved to USA after resigning from the institute for doing his PhD at Purdue University. Then came back and again joined the IITM. And in 1976, after doing his PhD, 76 or 77 probably, and then after that he continued till end retirement, even beyond 2 years after that in the institute. And the institute, I have seen him, I was there in the institute. Institute itself took a different direction after he took over because there were many difficulties. We could see that some of those things were so energetically, so with a long view of scheme, they were taken up by him, and that is where now the IITM is one of the great centers for the climatological research that we see and produce so many good scientists from there. So that is what I have to say, a few things about him. But as I said, he was a personal relative, closest relative. I will just share one file. I had few photographs. So I will just try to see if it can come. Quickly run through those. This is there. Let me see if it comes. Yeah. This is his early age photograph. Looks like his son Saurabh. Somebody may just confuse with him.
We cannot see Joshi sir.
Yes?
We are not able to see.
We are not able to see. What shall I do now? I do not know.
Maybe someone can assist.
Please share.
Reshare? What should I do?
Share, sir, share.
No, I had shared it. Share. Microsoft.
Yes.
Is it there now?
Now it is coming. Yes.
Yes.
Okay, okay.
Just slideshow, sir.
Slideshow.
Okay. But the position is not very proper. I do not know why. Let me see what is the next. Okay. Leave aside that that was the. I thought that's a very good photograph. Somehow that the position is misplaced. I may not be able to improve that. Okay. So we'll go to the next one. This is the early age, his photograph. This is with his friends. See how much later on he put up and with college friends. And when he came to Bombay first, gateway of India, this is the Pahadi effect. Pahadi means those who belong to the Himalaya, they are called Pahadi. So hesitation in going to the rivers and terrains, good at that, and relaxing with the excursion with that. And then when he reached USA during PhD days, and then he came to Ahmedabad once in a marriage ceremony. In fact, he stayed in our house. So I had this photograph. He has to do certain religion in that Bharat. He was supposed to be a big Pandit in that day. So he especially, and he enjoyed that. He was that type of. Then this is his fondness for the Kumaoni food and vegetables. A special vegetable he's preparing. He himself he's preparing, and of course Mrs. Pant helps him in the product to come finally. Yeah, this is the oldest friend of Dr. Pant. This was framed in his house for 1995 to 2014. Like his family, she was with us, and when she died, he framed this and he wrote this: "When you feel me in your heart, just look up." So that was his. Now this is the just outside this. There is a big kitchen garden. He was fond of kitchen. There is a huge kitchen garden. Those of you visited his house, there is a big kitchen garden, and the Monu still sits around with a family member like family. Oh, this I say again is a Himalayan effect. The kitchen garden is in the blood. Yeah, this is the three generations of Dr. Pant. Dr. Pant, Saurabh Pant, his son, and his daughter. There are the three generations of Pant. This is a happy family. All families together. Dr. Pant, then Saurabh's wife, Mrs. Pant, and daughter and the two granddaughters. All family together. And this was the photograph I realized this was very close to his bye-bye when he was still not well and coming towards closer to bye-bye, this photograph. Now that's the small number of photographs which I could collect, and then I found that in the IMS website, Patnaik has put certain photographs of the BHU Tropmet. So I just copied them and put there. In fact, Patnaik was to show that. I said I have put in my slideshow. Let me see whether it is coming or not. Yes. This is behind that is the Malviya ji and speaking. Rest, I don't have to speak. So that's it. That is this is what I had. Now I have to go back to the yes. So I'm not sure because I'm not good at these slides and photographs showing, and probably I don't know whether you could see the photograph. So now I will come to the what is this? Is it coming now?
Please share again.
I've shared it. but it's not coming. It's not going to the. No, this is something different. It is.
Actually, your sharing is no longer there, Joshi-san. So
what is it?
You are no longer sharing, so that's not a problem. So I think maybe they have to switch on the sharing for me.
Yeah.
Okay. So this is over, right?
Yeah,
so
yes, sir.
Next, we have to go. In fact, I'm supposed to be the chairman of the session, so I have to say a few words about Dr. Roop Kumar also. So this Roop Kumar, Dr. Roop Kumar was his closest, one of the closest. I am the closest relative. Roop Kumar was the closest colleague. So he will be giving us the J.B. Pant Memorial Lecture. And just for those of the who are not knowing about Dr. Roop Kumar joined IITM somewhere in 80s and has been there for almost 35 years in the institute and went to WMO and there for almost 1.5 decades and now returned back and still he's doing certain. He's the executive director of the International Clivar Monsoon Project Office. So now we'll hear from Dr. Roop Kumar, the J.B. Pant Memorial Lecture. Over to Dr. Roop Kumar. Sorry for some mix-up.
Okay. Can you see the presentation?
Yeah, it's there.
Okay. Thank you, Dr. Joshi, for that excellent and personalized introduction of Pansab and also myself. First of all, I would like to express my gratitude to the National Executive Committee of the Indian Meteorological Society for giving me this great honor and privilege to speak and to give you a lecture in memory of Dr. Pant. And in fact, as Dr. Joshi has already mentioned, my association with the Pansab has been so extensive, and Pansab's versatile personality has been so wide and far-reaching. It is very difficult to confine everything in one talk. And in fact, as Dr. Joshi has already mentioned, Pansab has had a tremendous linkage with the Himalayas, and he had, of course, he was the son of the soil, and at the same time, even his scientific career had a lot to do with Himalaya. And given that the theme for this Tropmet is on the mountains, I thought I can actually cover a little bit of the work that was done by Pansab and also the legacy that he left behind for us to take forward. And in fact, this is not even, I'm not an expert on the climate of the Himalayas. I know there's a lot of work that was done and that is still being done, as we have seen in the various presentations in this Tropmet itself. But at the same time, I wanted to use this lecture as a kind of nostalgic journey through one aspect of Pansab's work. And in fact, I would like to sprinkle with a little bit of anecdotes here and there to give an idea of the personal attachment that we had during the last 3 to 3.5 decades. In fact, I also roped in my colleague, Hemant Burgaonkar, to work with me on this presentation, and he had He also had a long association, even longer than mine, with the Pansab, and in fact, we were all part of one family in IITM. There's a lot of work that was actually carried forward by Borgaonkar after Pansab left the service. So in that sense, there will be some mention of the work that is still being done and that was done after Pansab retired, and also which is likely to continue in the times to come. Before we go into that, let me pay my personal tribute to Pansab. He was a mentor, guide, leader, friend, family, philosopher, and above all, our beloved Pansab. In fact, we never referred to him or called him Dr. Pant. He was always Pansab to me. Dr. Pant, we used to feel it's a bit distant and too formal. So Pansab is in that sense, it's very close to our hearts. And this is my homage to Pansab. Of course, as you can never imagine that he's not with us. He was such a lively person, and he still continues to be with us in spirit, if not in physical form. So I learned a lot from him, and in fact, much of my professional career, including what I was able to do in WMO over the last decade or so, was all due to Pansab's training and the experience that he shared with us. Not only experience, in fact, he had a worldwide network of colleagues and friends. He, in fact, shared and helped us to become part of that international community, which was a great gift that Pansab gave us, which we try to make best use of, not only to improve the quality of work, but also to give back to the society for the kind of support that the society is giving us. This is actually a view graph that I keep repeating in many of my talks. This was actually developed as part of the IPCC third assessment report, which actually lays out the framework for actually trying to understand or doing something about climate change. As you know, as Doshija has already mentioned, Pansab was the first climate scientist to be contacted by IPCC way back in the late 80s, when IPCC was just established. So in that way, he actually helped us to become part of the IPCC assessment process right from the beginning, which is a tremendous experience. And in fact, the entire climate change debate, as it evolved over a period of time, now that it is grabbing the attention of the entire global community, it actually tries to address three fundamental questions, which also define the research that goes into climate change and also the policy guidance that actually emanates out of the scientific results. So what we need to do is what changes that have occurred in the past, either through observations or through some proxy information that we can get. So once we have that kind of observational evidence, then we should focus more on how well do we understand the past changes and how the present climate is behaving. So this is where the most of the observational assimilation and the modeling that goes on. So once we have some capacity to understand, we should use that understand to actually to determine what lies ahead in future. So this is the entire time frame, from paleo and instrumental records to the future, including the model-based projections. So the PANSAB was involved in the entire spectrum. So that is the most important part of PANSAB's scientific career, that he actually spread himself throughout the climate spectrum and made remarkable contributions. Of course, more focused on Indian climate and the Indian monsoon. Now, I will not be able to cover the entire work, so I will only provide a few glimpses, and more importantly, the areas of work that was closest to his heart, and actually he laid the foundations for some of the activities that will be there for all times to come in the future. In fact, when he started working on the climate change, one of the first things he wanted to understand was to see what were the long-term changes, of course, on a very broad scale. So he tried to synthesize a large number of multidisciplinary studies and results by painstakingly going through a large number of papers and reports and all that. So he synthesized that into at least 4 major epochs in the last 10,000 years or so. So before 10,000 years, it was essentially, of course, the Ice Age, as per the cold, dry period when the monsoons were very weak. And then it was followed by 10,000 to 4,500 years before present, marked by very humid and warm climate with frequent flooding. And 4,500 to 3,500 before present, it was marked by warm, humid, but with less number of extremes. And the present warm, dry, with frequent droughts, with seasonal extremes, has actually started about 3,500 years before present. So these are this synthesis was based. This was published way back in '87 in collaboration. One of my younger colleagues at that time, Josh Malekal, was also part of PANS group. Now Josh is now in the US, in the State University of New York. But that was a very deep insight into understanding the changes, and it was also known through a number of studies that many of the ancient civilizations they appeared and disappeared largely because of these long-term changes that were happening to the climate and the monsoon. So this was brought out very early, which actually laid the foundations for us to do further work on the long-term changes. And in that context, actually, we should look at the Himalayas and their role in the regional climate. Of course, this is much of this is well-known information, basic information, but to place the context, let us actually try to recapitulate. So, in winter, Himalayas act as the effective barrier to the intense cold continental air blowing southwards into the Indian subcontinent. And in summer, they actually force the northernmost edge of the moisture bearing monsoon winds to deposit the monsoon rains in the southern slopes. And the plateau of the north of the Himalaya, with average elevation of about 5 kilometers, acts as a high-level heat source for the large-scale monsoon circulation, which also establishes the anticyclonic circulation and establishing the easterlies that are such a fundamental part of the monsoon circulation at the upper levels. And the snow-covered mountains also, because of the albedo, they have another big role in the energy feedbacks. And the extensive land area covered with snow, ice, rivers, water bodies, forests, biodiversity, and the surface, they provide unique playground for a number of specific weather systems that are so specific to the region that it's fascinating in some way, but it's very difficult to get a handle on, to understand them, and also to provide the scientific basis for many of those systems. And the extensive thick forest cover also is a major carbon sink in the global climate change mechanism. And in addition to helping the upper easterlies, the monsoons and the configuration of the mountains, they are closely linked, and the sustainability of the heat load, the monsoon trough, also depends upon the Himalayas. And they also give rise to a variety of mesoscale systems, and some of these things were actually also mentioned in the earlier talks in this Tropmet. One aspect that I would like to highlight is that Himalayan climate is not is critical and to understand and predict not only for the people living in the Himalayan region, but even for the other part. That in fact, when people talk about Arctic, there is a famous saying which that whatever happens in the Arctic doesn't stay in the Arctic. In the same way, whatever happens in the Himalayas doesn't stay in the Himalayas. The entire subcontinent is dependent on the Himalayas. And in fact, this was studied quite extensively. And in fact, the impact of the Himalayas on the monsoons was one of the earliest studied sensitivity experiments with various models. So in that way, so the role of Himalayas in the regional climate needs no further emphasis. So that's why, in fact, the Himalayan climate has always been a major factor in understanding the regional climate. Not only the fact that the beauty of the Himalayan region, but also the fact that this is Nainital in 1868. The role of the Himalayan snow cover in determining the monsoon variability was recognized quite early in the late 19th century. And in fact, that formed the basis for the first science-based seasonal forecast in the world. Blanford, even with very meager amount of observational evidence, has postulated that varying extent and thickness of the Himalayan snows exercise a great and prolonged influence on the climate conditions and the weather in the plains of northwest India. So this was the basis with which the long-range forecasting operations have started in IMD way back in 1886. So that is how the Himalayan climate has played a role in starting the seasonal prediction activity in India. So that way, it's very important for us to understand the climate variability over the Himalayas and how they change, not only during the observational data period, but also earlier. So Pansab's work actually starts where this was published in 1984. He started with the analysis of the various long-term observational data sets that are available for the Himalayan stations. So in the early work itself, it's clear that there is a recent warming. That is, this is Mukteshwar. So this was one of the earlier studies documenting the climate change that is happening using observational data sets. And this was subsequently extended with a number of additional stations in the Western Himalaya. So where we clearly see a long-term warming, which is quite significant, and very few, maybe on a seasonal scale, a few cooling trends happening. So this was very clearly brought out by Pansab and the work that was done subsequent to his work by my colleague Borgankar. So this was these are the number of various stations within the Himalayas, which also highlight the widespread nature of the warming trends, and also the fact that the temperature trends are now accelerating in the recent decades. That is also clearly brought out. This is actually the mean temperature data sets over Western Himalaya, which also underscores the same point that there is a rapid warming that is taking place, at least in the Western Himalaya. So this is also another way of looking at it based on the CRU data, where you can see there is an all-round warming all around the Himalaya, which is a cause for concern. Whereas in the precipitation, there are some differences in terms of, though there are some areas with significant drying, and there are also some areas where there is significant increase in the precipitation. So these are some of the studies that were done to look at the observational data sets that are available over the Himalaya. But as we know, the complex topography of the Himalayas cannot be captured by a few number of stations. So there is greater need for us to use satellite-derived data or other data sets to get a better idea of the observational changes that are taking place in the Himalayas. But we also know that observational data sets extend hardly about 100 years before present. So in that sense, our ability to understand really long-term changes is limited to the available observational data. So this is where the tree rings and climate comes into picture. Pansab again played a pioneering role in bringing this new scientific discipline to India. Tree rings are based on the the ability of some trees to form annual rings with clear demarcations, which can be precisely dated. In fact, some rings can also be even seasonally resolved. These ring widths or ring density or their isotope characteristics have been established as reliable markers of climate sensitivity. So once we are able to relate the tree rings during the observational data sets and create some models which can be used to reconstruct past climates. Tree rings can take us back to several centuries in the past. And an advantage is that we get a continuous record. And because the entire Himalayan region is covered by a thick forest with very, very, very old trees. So there is a tremendous potential for us to reconstruct past climates with greater density of locations. So Pansab started very early in bringing dendroclimatology to India, and in fact, his first paper on dendroclimatology was published in Mausam in 1979. That actually mainly dealt with the Himalayan forest zonation, where he identified different species and their growth ring characteristics and their potential to be used in dendroclimatology. And he also started looking at some of the samples and available samples in those days. And this was probably the time when I met him, just before he published this paper in 1983. I joined IITM in 1982. So when I was introduced to him, I found it very strange to see him actually, his desk covered full of tree ring samples, and he polishing almost like a carpenter. So that was the first time actually I came into contact with the tree ring concept. And though I was not part of his team initially, very quickly, actually, I became close to him as a person rather than as a scientist, and very quickly we started working together. And in the initial stages, he brought his experience in the US, where he worked with some of the best in the dendroclimatology field, some of the world's best names, and he brought the entire technology, the treating sample preparation, and also the modeling expertise, and to work out the response functions. This is the response function with temperature and precipitation for a particular sample in Nainital region. And it's important to see that the climate sensitivity of the trailing series, based on their statistical relationship studies with the observed data, forms the basis for us to go back and reconstruct. So that is how he clearly established the scientific foundations for us to go forward with this important new area of research. So this is this was his trailing with measuring experience in Lamont, where he actually went as part of UNDP training fellowship, and he actually did a tremendous amount of justice to the UNDP fellowship program, because the UNDP fellowship program is meant for helping people from developing countries to be trained in new technology and apply that in their own countries. So that's why he did full justice to that program, and it's very rare to see that kind of effort where one makes maximum use of the opportunities that are available and also shares that opportunities with others. So he established a training lab in IITM, though with a very modest equipment in the initial stages, but over a period of time we were able to improve that. And he also started straight away an extensive fieldwork program because we need to collect samples from the undisturbed forest locations to actually get samples that can reflect the natural variability that is happening. And he embarked upon many challenges in actually carrying forward with these fieldwork programs. Even I was part of many of these field expeditions. We took samples from stubs like already cut trees, or from living trees, and living in or staying in very inhospitable locations. So he actually had that energy and also determination to make it work. And he of course is Joshi mentioned, he was a true Pahadi man, and I think nothing can deter him from taking up on difficult tasks, and he adequately demonstrated and gave us an example to go forward with that work. And at the same time, he was always jovial, and he made those fieldwork like almost like a picnic, though there is a lot of hard work. That is how actually we remember Pansab. And in fact, I am very glad that I went with him on all these field trips because that helped me to get closer to him as a person, and we became almost inseparable friends after these field trips. So with that extensive fieldwork program, this actually was some time back. I think later on many more samples were added by Borgaonkar and his team. So there are many samples and a lot of kind of a rich repository of training data sets were compiled in IITM, which even now is a great resource for IITM scientists to benefit from, because these data sets can be used and reused with better techniques and technologies. So these are some of the early collections of Pansab that were different types. Some samples from living trees and some from stubs or cut samples. And we also started to modernize the equipment as resources started resources started improving. And this was even an earlier picture. And in fact, now IITM has one of the best dendroclimatology labs in the country, maybe comparable to any other dendroclimate lab in the world. Pansab also actually promoted another aspect, which many people may not be aware, that since IITM had these facilities, he did not confine these facilities to only IITM scientists. He openly invited many scientists like PRL or Birbalsar Institute of Paleobotany for those scientists to come here, work with us in our labs, and collaborate on a nationwide scale. And we also had a number of international visitors who actually came here and worked with us, particularly from Japan and the US. So this is how he actually helped IITM to be truly national and international in the way dendroclimatology is developed and applied. So with his guidance and support, an extensive treating sample collection exercise was done with different projects. And this is all, of course, mostly in India. But there are, like, you can see that there is still a lot of scope, particularly in the Himalayas, to collect additional samples and extend the trading network. So these are some of the response function analyses that were done for different parts of the Himalayas. We can see, as you can see, the rows are simply the species and locations. So there are coherent signals that are coming out in highlighting the response of the tree rings to the climate, which is the fundamental requirement to attempt any reconstruction. So with that, those response functions, and with the confidence that given by the response functions, a number of reconstructions were attempted for different parts of the Himalayan region. I will not go into the details, but just to give an idea of how much in the past we can go. This is from the 18th century in the Western Himalaya. And these are some of the tree ring series extending back up to 15th century, particularly at the high levels. And there are also reconstructions which gave us clear ideas about major warming and cooling epochs in the last 400-500 years ago, which is a good piece of information to understand how the climate was changing over the Himalayan region. And this is based on another study, also, of course, in collaboration with IITM's scientists, IITM groups, which also highlighted some of the recent wetting that happens on in the Karakoram area, which also was mentioned by other speakers in this morning. So these are some of the things, and in Sikkim also there was a lot of work that was done to collect the samples and reconstruct dating back up to the 16th century. And they also gave a good piece of evidence that the recent warming is quite significant, and also matches with many of the other studies that were done in the neighboring region like Bhutan or Nepal. So these are that was just a few glimpses of the work done under Pansab's guidance. And some key points are that there are increasing trends, mostly significant in maximum temperature. And there are some cooling trends in the minimum temperatures at some stations. And the key issue is that the warming is more rapid after 1960. And also that the warming over the Western Himalaya is higher compared to other parts of India and also the globe. And in terms of rainfall, there are complicated changes that do not indicate any major large-scale trend, but there are small-scale changes that can be noticed. But in a general sense, there appears to be some areas with decreasing trend of precipitation. These are based on observed data analysis. And in terms of dendroclimatic reconstructions, Pansab's and his team's work clearly indicated some clues and of long-term changes since the last several centuries. And most of them actually give information on summer temperature conditions. So there are few epochs of the medieval warming and little ice age, but they are not so significant, which is again an anomalous observation that actually was brought out from these sharing studies. And definitely there is significant warming trend over the last few decades, which is also reflected in most of the reconstructions. And in fact, the tree studies can actually help us to extend even spatially, even within the instrumental record period. If they can extend, they can help us to extend in a spatial resolution to know the climate changes in areas where there are no observational data sets. And there are also some precipitation reconstructions indicating weather conditions in recent years, particularly in northwest Himalaya, including Kashmir and Karakoram ranges. And it also is seen that high altitudes near the glacier levels, the tree ring records can give us a lot of information on long-term temperature variability and the associated glacier fluctuations. So that is something that is still, there's a lot of unmet potential that we can actually exploit. So Pansab actually, after retirement, he did not take rest. He spent a lot of time in consolidating all the work that was done over the Himalayas, and he published this book on climate change in the Himalayas. And in fact, it's one of my prized possessions of his personally autographed copy of this book. In fact, he consulted even when this was done when I was in WMO, and he consulted with me in developing this book. And he tried to summarize in very simple way the various aspects of the climate change in the Himalayas, including the impacts in various ways and the extremes and some of the associated disasters. So this is a very important contribution by Pansab, and we are lucky that he found time to actually bring out this book where much of his knowledge is now permanently preserved. Another important aspect of Pansab's work that I was personally involved is on the modeling approach to the climate change problem, particularly to get an idea of the future. And we know that global models have very little scope for giving us high resolution information. So that is where the regional model approach was introduced under Pansab's guidance to IITM, in which I was fortunate to play a significant role in the initial stages. This actually happened with the Indo-UK program on climate change impacts in India, which is a national program with many other institutions. IITM had 2 projects under this program, and Pansa was singularly responsible for this these projects to come to IITM, and that is how the climate change modeling work, particularly in regional climate modeling, took shape in IITM, and giving IITM a preeminent role within the country as the most authentic source of climate change projection data. So in those, this was, of course, more than 15 years back, this project was completed. So the the simulations gave us some hope that the regional models can give us useful information, which was also applied in many sectors. And IITM openly shared much of these data sets with not only within the country, but also with neighboring countries, which is again another facet which even influenced my own work in WMO that I carried out on a different platform. So this is out in the same project. There was some analysis on the impacts on water resources using those projections and applying them in different river basins, and to bring out some of the key aspects of the hydrological impacts. And subsequently, with more advanced and more detailed analysis of regional models, some studies were also made to examine how the future changes are reflected over the Himalayas. So this is for the Kashmir, where you can clearly see the, in terms of the temperature projections, an overall increase into the end of the century simulations. Whereas in terms of precipitation, I'm sorry for the quality of the graphic. In the precipitation, there are some, while you can see in temperature there are extensive warming, but in precipitation there are some changes that are a bit complex in terms of spatial patterns. So, but this shows that the regional models can help us to understand better the spatially complex patterns that are part of Himalayan climate. And again, Dr. Joshi has mentioned this before, the climates of South Asia. And the picture, it may look a bit funny in this presentation, but my friend Surya actually brought to our attention the fact that our book was used in a action thriller movie, Bleeding Steel, by Jackie Chan. And of course, the book was used for a different purpose, to hide this fellow's face. But this, why I'm showing this is that this piece of information brought so much joy to Pansa that I think he felt very happy, and he shared with his family. And we also felt very happy that the book actually featured in a movie. I don't know why this book found its place at that point in time in that movie, but that's a kind of in the lighter way. But our work for this book actually laid the foundation for the regional approach that is so fundamental to dealing with South Asian climate. Very quickly, we realized when we started working on the climate services problem, because so many countries share common regional drivers in terms of climate, it is very important for all these countries to work on climate in a collaborative manner. If countries start working independently in dealing with regional climate, their interpretations and the policy decisions can become quickly inconsistent, which can pose serious problems in the effectiveness of those policies. And this, the foundation for that regional approach was very consciously laid by Pansar, and in fact, he very systematically approached the issue by helping us to more actively pursue regional collaboration. So, in fact, I was part of a training workshop for South Asia organized by the Met Office in Bhutan, and that was the first time I came into contact with the people in other neighboring countries, which started a partnership that continues till today. And this was actually at the initiative of Pansa to help us to become part of these regional activities. And we shared much of the data sets that actually were part of Indo-UK program, both in terms of regional model projections and also in terms of our analysis. So that actually helped us to collaborate not only as part of Indo-UK program, but many other international regional projects were taken up, in which we played a very important and active role. And we actually could establish ourselves to play a leading role in these regional activities. And this experience helped me to bring a regional framework to South Asian activities, which I will come back later. So what is important is that we need regional climate change projections to be handled in a regionally consistent manner, because the information is accessible widely. So if anybody can pick up information that is publicly available and start taking decisions, but that can quickly lead to chaos because there are so many ways the information can be interpreted and understood. So because of the increased volume and accessibility of the model data sets, and since they are all feeding into the national and other adaptational plans, there is a significant risk of misuse and misinterpretation. So this is where actually we need to have very good platforms to help us to deal with this issue. So this is where, in fact, as part of my work in WMO, I was supporting the Regional Climate Outlook Forum activities worldwide. And we quickly realized that the Regional Climate Outlook Forums essentially deal with seasonal predictions, but at the same time, they can quickly be oriented towards climate change and use the same approach for regional discussions of climate change issues and develop a consensus in the way regional climate change is understood and interpreted. And this work is actually now also being supported in many ways by several projects. This is one example of a project that is still underway called ARC, which actually is supporting not only the seasonal prediction on a regional scale, but also on climate change projections, in which IITM also is playing a significant role. The point I would like to make is that the foundation for these activities, though they are now independently progressing, the foundation was laid by FAMSA. And this is specific to Himalayan region. I think this was also mentioned by Secretary in terms of the consultations that we had in Jaipur, and also DGM also has referred to these initiatives. There is a WMO initiative which I personally closely promoted when I was in WMO, to have a regional climate center for the entire third pole region. But given the political and other complexities of the Himalayan region shared between so many countries, it is important for us to work together, but at the same time recognize that there are constraints that we may not be able to overcome. So in that sense, there are 3 notes that were actually agreed by all the countries who came to Geneva when I was there, and we had a detailed discussion. It is still under development, but this third pole regional climate center network, if it actually starts operations, this can become a good platform for us to have a single source for much of the information that is relevant to Himalayan climate. So this is something that I think even WMI is still pursuing, and my view is that since these nodes can be operated almost independently, the only requirement is that through the WMO framework, we can actually agree on certain common ways of doing these activities. And if these can be shared among the various groups, we can actually get a pan Himalayan climate information that can be very useful for many other applications. So the key messages that I would like to carry forward through this memorial lecture is that there has been a significant progress in our understanding of the climate and variability and change over the Himalayas. But of course, there are still challenges. But an important aspect is that there is suboptimal use of information, even the available information, which I think needs to be addressed by providing improved access to the information. And we also need to actively promote multidisciplinary and international collaborations, and also help in the exchange of information among the different groups. And there is also a need for greater focus on enhancing the national capacities and also the regional collaboration, mainly to efficiently incorporate the global and regional inputs into the more local scale tailored products. So the WMO's third pole RCC network concept can be evolved into a good platform to consolidate the efforts of all the stakeholders of the Himalayan range. And I think that needs more extensive communication and also participation to make it more viable mechanism. And I'm sure WMO will be able to support. I think the presentation by the Deputy Secretary General on the last day of Tropmet may probably refer to this again. So it would be good if we can actually formulate, at least from the Indian side, how we want to actually flesh out our part of the this network and make it work, which can even become an example for the other nodes. So Pansab's lifetime work on the Himalayas is our foundation, and his vision, our inspiration to make his dreams of our future a reality. So in that sense, I think we should be grateful to Pansab for all his contributions, and we can live his dreams in the future, particularly the younger scientists. As Secretary has highlighted in his remarks earlier, I think a lot depends upon how the youth takes forward these early pieces of work and develop further. I'm very happy to see a tremendous amount of work that is being done by the younger generation. But at the same time, I think we need to pay attention while going deeply into the science. We should also pay attention to the collaborations and applications of information that we are generating. It's not just for publishing papers, but also to make the societal applications beneficial for all sections of the society. Thank you.
Thank you, thank you, sir. Thank you very much. I think there is some problem with Joshi sir laptop. So I think I talked to him. So he said, if I am not able to connect, you can conclude something. Sir was telling. I think he not there. Means perhaps there's still the problem there with me. So
Okay.
yeah, thank you, Kumar sir. Actually, nicely you have summarized the activity of Pansab, and we know personally him and his contribution. The climate variability, dendroclimatology, the Himalayan climatology, the IPCC. So all contributions you have nicely highlighted. And this video will be available in our YouTube and also IMS website. And those who have missed this thing, they can see later. And really, we are very much thankful to you, sir, for agreeing to deliver this memorial talk and also nicely covering entire aspect of concept contribution to the field of atmospheric science and the field of particularly the climate science. Thank you very much, sir. Thank you very much.
Thank you.
Mahapatra sir would like to say something. Just a minute.
Yeah. Good evening. Namaskar. At the outset, I express my heartfelt tribute to Dr. J. Pant Sahab on this occasion. I also express my gratitude to Dr. Roof Kumar for delivering this memorial lecture, which is highly educative, informative, and inspirational for the youngsters to take off the research work in this field of climate science. Dr. Pant Sahab has been a role model in the country and outside, especially with respect to the paleoclimatology. As a youngster, I came in contact with Dr. Pant while taking the training as a meteorologist grade 2. We are given lectures by Dr. Roof Kumar and also by Dr. Pant. So that was really a memorable experience in my life, with the way in which Pant Sahab goes on speaking during his lecture. Certainly any individual, whether it's young or old, will be motivated. His speech, his interaction, his lecture during our training program as MET2 was very unique and will be remembered forever. I was fortunate enough to continue my interaction with Dr. Pant, as towards the end of the training, there is a provision that each trainee should have a project work. So Dr. Apara was head of the training program in Office of Weather Forecasting, DDGM Weather Forecasting. He was the DDGM training. And he was the guide. And he told me, Dr. Pant also will guide you. So I was lucky to have the guidance from Dr. Pant, and I was given the topic, the climate change. So my first project report in this field of meteorology was the climate change. And it was possible due to the active interaction with Dr. Pant. I immediately visited IITM, and without any hesitation, he went on explaining me the science of climate change, the references, and thereafter I prepared a research report, which was presented during my MET2 training. Not only that, after that, as and when we meet, he had got such a stress and high memory that he immediately recognizes by name and he remembers. So we learned a lot. Like me, many youngsters, now of course we are aged, we have learned a lot from Dr. Pant. He was a good teacher. He was a good guide. And he was very supportive for development of this science in this country. The name and fame, whatever we have received with respect to climate change and paleoclimatology, in the country, in the world. The credit goes to him. So on behalf of Indian Meteorological Society, I once again pay my heartfelt tribute to Dr. Pansah and the heartfelt condolence to the bereaved family members and the friends. And our highest regards and gratitude to Dr. Rup Kumar for delivering this memorial lecture. I thank all the participants, all the delegates of Tropmet and members of Indian Meteorological Society, students for joining this memorial lecture. Thank you very much.
Thank you, sir. Thank you very much once again. Yeah. So anybody has to say? Otherwise, we will break for our next item, the GB meeting.
It's getting late.
Yeah.
So I have only 2 sentences. I thank IMS to bring me into this panel, and both the lectures, both the personal profile by Dr. Joshi and talk by Dr. Rup Kumar were excellent. I have also a lot of fond memories, although I never worked in IITM. I had visited Brazil and some other places as a team member of him, and was very close. Somehow from the very first day, we developed liking for each other, and a lot of fond memories. I don't want to, I can't express now because there's no time, but I would have been happy to give some anecdotes, which I don't think we'll keep for another occasion. I thank all these, both the speakers and also the IMS. And my highest regard for Dr. Pant will be there, even if he's not there. I all the time respect him and like him as a human being, and a very, very frank person and lively. A lot of things to learn from him. So my namaskar to him, and may his his soul rest in peace. Thank you all.
Thank you, sir. And just only one sentence. Actually, I started my career in IITM with Pansah. It means when he was the director. So that is the beginning actually. And when I came after 2 years and joined IMD, he was telling, so you are leaving IITM, you are going to IMD. Somehow it is a loss for IMD, but IITM, but it is now both are, means we are working together. So now it is integrated system. But I still remember he used to give a lot of advice and really encouragement. And lastly, the Tropmet, the Bonaras Tropmet, we had a very good discussion 3 days, really. We enjoyed personal, lot of discussion which took place that I am not sharing. We will keep it for some other occasion. Thank you very much, sir. All the memorial.
Just 1 minute, when you told about Banaras, I'm sorry that there are people are getting late. In Banaras, actually, he came and around 10:30 he reached, and he had problem with the guest house. I was very much perturbed, and I came and met him personally. Some dinner was going on. Then he saw that I was perturbed. Then he told, "Arey Das, ऐसे क्यों आ रहे हो? क्यों आ रहे हो? मैं क्या बारात में आया हूँ? This is IMS. It is our society. I am not I am an invited person. Why do you worry? Don't worry. I will take care of myself and let it take its own course." That should be the spirit, and all other members should learn that it is our society. And so with that, I'll stop. It is our society, and we don't have to be very, very critical and criticize the activities of the society. Thank you all.
Okay, sir. Thank you. Thank you very much, Rukma sir. Thank you, everybody, all the viewers. We'll break for today's the technical sessions, and we'll meet again tomorrow for the technical session. Thank you, Kunduji.
Thank you, sir. And for those who are viewing us from web portal, tomorrow again our session starts at 10 a.m. And as usual, we have three plenary talks by Professor B.N. Goswami, Dr. Sunil Singh, and Dr. S.K. Behera, followed by 6 technical sessions and a popular lecture by Dr. Shailesh Nayak in the evening. Thank you everyone for watching. See you at tomorrow 10 a.m.